Good morning, everybody. Welcome to Zak World of Façades here in Birmingham, which is the second edition being held here in this city and the 181st edition globally. It's an absolute pleasure to welcome you all today. I'm Siobhan, I'm the Senior Manager for Partnerships here at Zak. And I'm pleased to welcome everybody. I just want to say a few words and give a special thanks to our partners today. Starting with Benx. Welcome to Benx, who are a UK-based company offering high-performance rain screen solutions for facades. All our partners today are based over in the exhibition area, so please do make sure you say hello to everybody. Boston Valley Terracotta, manufacturer of terracotta cladding products, are joining us today from the USA. We have Cooper Clad, who are a manufacturer of slate-based cladding solutions. They're joining us here today from Spain. Don & Lowe, they are a UK-based company offering high-performance weatherproofing solutions for the building envelope. DuPont Tyvek, so they're a global player offering high-performance weatherproofing solutions for the building envelope. Façade, we have welcome Façade today. They're a new joint venture, Belgian-Swiss joint venture, providing a cold rolled steel curtain wall system. Fedora from Azka Nobel, welcome to you guys, great to see you here. These guys are global liquid coating solutions provider. Fix Fast, who you'll be hearing from today, they're a UK-based company offering high-performance rain screen solutions and value-added products for the facades industry. Claeys, again, UK-based. Claeys are offering high-performance weathering solutions for the building envelope. Obex as well. Obex are UK-based. Make sure you go see those guys. They're offering a high-performance weathering solution for the building envelope. We have Parklex Prodema, who are a manufacturer joining us from Spain, manufacturer of high-pressure laminates for exterior applications. A Procter Group are UK-based. They're a UK-based manufacturer offering high-performance weatherproofing solutions globally for the building envelope. Turkish Glass, lovely to welcome Turkish Glass today. They are the Association for the Turkish Glass Manufacturers and Processors. And then we're Kona by Hydro. So these guys are global players providing low-carbon aluminium systems for doors, windows, and curtain walls. Finally, our agenda partner is BB7. BB7 are a fast-growing UK-based fire and facade consultancy firm. As I was just saying, please do make sure you go see these guys on their stands today, have those conversations, forge those relationships, and take advantage of the networking opportunities today that we're providing on this fantastic platform. Just before I hand you over, a couple of save the dates for you. So the next couple of European and UK stops, we are in Athens on the 29th, and then it's over to Milan on the 4th of June. So if you guys weren't aware, get that in your diaries. It'd be fantastic to see you there. And then Paris, 19th of June. London, again, that's at Old Billingsgate in London. Last year's was a fantastic success. If you guys haven't already seen on the YouTube and the photographs, definitely take a look. It'd be brilliant to welcome you to London as well. So I would now like to hand you over to our event convener and host for today, who is Aneel Kilaire, who is the Associate Facade Consultant from Ramboll. Thank you.
Okay, thanks, Siobhan. It's great to see all you good-looking people here today, and also Armin. We've got a great lineup today. First one's Birmingham Market, State of Play, Trends and Challenges, with James Watts, Director at Arup, and Ross Fittall, Commercial Director at MEPC. So please come up.
Right, good morning, everybody. We're here today to give you a bit of an insight into the Birmingham market, so I'd just like to start by introducing myself. My name's James Watts. I work for Arup. For those of you who might not know, we're a global firm of built environment consultants, and in Birmingham we're over 700 strong and pretty much have every service associated with the built environment within that office, which I lead.
Good morning, everybody. My name's Ross Fittall. I'm Commercial Development Director for MEPC. We're the development and asset management firm for Federated Hermes, which is a fund manager. My day-to-day role is I'm responsible for leading the Paradise development here in Birmingham and also looking at new projects going forward in the region.
Great. So we're going to provide you with a little bit of a potted history of Birmingham, development and investment that's happened. Ross is going to go into far greater detail on the Paradise development, which we've both been working on for over 15 years. And then I'll round up with a look forward to some of the investments and the moves around the city that you may be interested in. So we'll go back first of all and we'll focus on the public sector before thinking about private sector investment. And I think the point we want to make here is that no private sector investment really can happen without the will and the enthusiasm and the effort of the public sector. And in Birmingham, the Big City Plan was released in 2011, which was really a catalyst for a fresh start for the city. Talked about some significant moves within the city, like relocating wholesale markets and laying the groundwork for significant investments from the private sector, like Paradise. A core part of that was in Paradise in 2011, the same year, securing what's known as enterprise zone funding. And that's a public finance mechanism that allows private sector development to happen on sites that may otherwise be unfeasible. Here, the EZ funding allows us to address the abnormals, and then the council gains the additional business rates as revenue to pay back that money. In 2013, the Library of Birmingham was completed, and that really signified the intent of the city to step up and was again a catalyst for some significant redevelopment in and around the city centre. 2 years later, Network Rail completed the redevelopment of Birmingham New Street, which is the busiest railway station in the UK outside of London. And 2 years further on, royal assent was gained for HS2, which plans to bring high-speed rail links to Birmingham from London. So you can see there was a real momentum building, and then COVID hit, and of course that had an impact. But soon after COVID, Birmingham hosted the 2022 Commonwealth Games, which, if you're not a Commonwealth country, I appreciate you won't have heard of, but it did raise the profile and it brought significant investment to the city. So you can see there's this momentum growing from public sector investment, but the private sector was already aware of this and was starting to get involved well before that. So back in 2003, Hammerson's opened the Bull Ring, which was a significant milestone. And then Deutsche Bank was the first significant inward investor to the region, bringing some of their operations to the city in 2007, and then in 2014 bringing one of their trading floors here. HSBC followed, bringing their ring-fenced UK arm to the region, and that was the anchor tenant that the Kilaire development required for Arena Central. We then followed, relocating a couple of years ago from the leafy suburbs outside the city into the city centre to move into Paradise, as did Goldman Sachs. They now, within a year of opening their Paradise office, have a 450-strong operation and plan to grow even further. So now I'm going to hand over to Ross. He's going to start to talk you through some of the complexities and the challenges faced on Paradise and what makes a development attract clients like Goldman's and PwC.
Thanks, James. So yeah, Paradise has been mentioned a couple of times already, but I'll also then focus on what we're going to be looking at over the next 5 years, some of the design challenges that we're going to be facing, which all of you will be facing similar challenges as we approach our sort of journey along the net zero trajectory the next few years. So this is Paradise. It's a significant infrastructure development located right in the heart of Birmingham city centre. It actually connects the traditional business district with the cultural quarter of the city. And it's a huge long-term development. Developments like this, with all of the constraints that exist, don't happen overnight. And you'll see some of the images and some of the leading that it takes, as James was saying, really borne out by some of those public sector decisions taken 15 years ago, and then the commitment of the private sector to make it happen. It's a 3-phase commercially led development. The buildings in red there are the phase 1, and they were completed in 2019-20, so just before COVID hit. In fact, PwC took the whole of 1 Chamberlain Square and moved into that building 3 months ahead of COVID. This was also in the aftermath of the Carillion liquidation, which I'm sure some of you in the room would have been impacted by. Phase 1 also involves some infrastructure works, which I'll show you some photos of in a second, and also some new public spaces. Phase 2 are the green-blue buildings, generally in the south of the development. 1 Centenary Way, completed in 2023, and as James said, Arup and Goldman Sachs, amongst others, moved into there over the last couple of years. It's one of the largest commercial buildings in the region at 280,000 square foot. 3 Chamberlain Square completes later this month, and we're already attracting interest with key blue chip occupiers. Then this will be followed by a boutique hotel, and in the north of the site, the 49-storey, 370-bed BTR building, the Octagon, also completes later this summer. The buildings in orange there are what we call our phase 3 part of the site, the final part of the Paradise development, and alongside a new public green space for the city. So a lot has been achieved to date, but still quite a significant amount of work to go. There's a few headline stats there about the development. I'll let you read those for yourself. But I think what they show is that it is a development of significant scale. One of the largest outside of Birmingham, and ultimately delivering 1.75 million square foot of commercial space. Now, if you've walked through it this morning or over the course of the next few days during your time in Birmingham, what you may not realise is this is what it looked like in 2014 before we started any of the works. This was around the time that we secured the outline planning permission for the commercially led master plan. And essentially it was a collection of 1960s and 70s and 80s buildings. But actually they sat within a large roundabout. Now there is a gadget on this pointer which I can zoom in on, but I'm not going to attempt to try and push my technical skills. But if you can see the roundabout here that goes all the way around it, which was a huge constraint. But not only did the roundabout go around the buildings, you can see to the right-hand side of that image the 4-lane A38 highway disappearing underneath the development, so that it sits right on top of those. And in fact, in some places, it's only half a metre below the surface. There's other series of pedestrian services tunnels that link underneath it, and people and moving in and around it on foot. So very complex and very constrained site. But also then as an environment for people walking around a major European city like Birmingham is, it was an unwelcoming, unsafe, dark, dingy environment where the pedestrians were relegated to subways and bridges over the highways, and a place really that you didn't want to spend much time and dwell. And also that image on the left-hand side, I think, is a key one, where you've got these fantastic listed buildings that surround the site, but in a setting that's got 4-lane highways running alongside it. So that was what it looked like in 2014, and at that point, when we secured the outline planning permission, there were 12 million people walking through the double doors under what was the old Central Library. To what we've created today, a huge team effort, many different parties involved, a real exemplar example of a public-private partnership, but also creating new spaces for the people of Birmingham to sit and enjoy. And actually, some of those original principles of the master plan back in 2010, actually, when Big City Plan was first drafted, it was about pedestrian connectivity. I showed you those images of what the environment looked like, breaking up some of the east to west and north to south movements of people, connecting the different sides of the city. As I said, 12 million people a year were already moving through some of those horrible spaces, and the idea was to bring the pedestrians back up to the surface. And actually, the image on the left-hand side is an image of the city around 100 years ago. So we're actually re-establishing some of those pedestrian connectivities that have been lost. And the master plan on the right-hand side was then focusing on establishing streets and squares. And so that meant re-establishing views that had been lost for 40 years, creating those sight lines to some of those wonderful historic buildings. And this shows the extent of that infrastructure works as part of that phase 1 element. Now, the project part of it is a joint venture with Birmingham City Council, and that is what funds the infrastructure funding through the enterprise zone that James referred to. So essentially, that creates service plots for the buildings, removes all of those constraints, the asbestos that was in those existing buildings, realigning the highways and spanning over the A38 tunnel would have made the development unviable if that public funding hadn't been there. But then the result is that you're creating best-in-class architecture alongside public spaces for people to sit and dwell, and most importantly, in a managed, safe and clean environment. And so the quality of the architecture was paramount for us. The real overriding principle of the master plan is different architectural styles, different materials being used, and some of that is driven by the engineering challenges in this building in particular, One Centenary Way, which is this exoskeleton facade, and that is primarily because it's completely spanning the A38 tunnel, creating quite an icon of the skyline. But also, we've been able to do what a real city does and mix up those use of materials and architectural styles, but also, you can see, then set alongside the historic buildings and have a proper setting for those buildings as opposed to the 4-lane highway that we had before. And creating homes and places for people that work there that want to be in these buildings and want to be in the city centre. So in 10 years on site, a significant amount has been achieved. There's 6,000 people that work on the Paradise estate to this day, but more importantly, it's provided public spaces for the wider city to enjoy. Well, when we look to the future, this has twisted the orientation of that last image, you can start to see the phase 3 buildings ghosted in onto this image. And that makes us sort of think to the future about what the challenges will bring, how these buildings are going to be designed amongst the sort of current climate of the sustainability agenda. And we need to keep thinking of these facade treatments and material choices. So we're running out a little bit from what we've used so far, so any ideas on that one would be appreciated. So I've collected, looking forward, some of the key challenges that I think exist over the next 5 years as we approach and deliver the phase 3 buildings. The private sector funding in Paradise is actually through long-term pension scheme patient capital. So that allows us to take a long-term view about the development. Now that still means that we want to create the best buildings for now, to let them quickly, but we're not looking to sell them quickly. So we also need to create buildings that are going to hold their value for the long term. And generally, that means the most sustainable buildings. ESG is fundamental as part of investors' criteria these days. You only have to go on other investors' websites and you can see ESG is prominent across it. It's finding its way into valuations, into rent reviews now. it's a fundamental criteria to deploy capital. And there's mandatory reporting requirements as well. So ESG is a prominent investor element. Now, when you flip to the occupier, how does that sit in an occupier image, if you like, from their priorities? Well, to be honest, it's exactly the same. Corporate objectives for both investors and occupiers, particularly blue chip occupiers, ESG is at the top, or it's right up there. So when occupiers are making their decisions about which buildings they're going to go to, whereas 10 years ago it probably would have been cost-driven, desk density and location, we're shifting from a decision that was fundamentally made by the FD of that business, more across to the HR and with a staff perspective, and then more laterally to the ESG lead, where the focus is on well-being alongside the location and flexibility. So actually, we won't be seeing buildings like this anymore, with these full floor-to-ceiling height glazing. That's the time of the past. And whilst people want natural light in their buildings, we need to design the buildings that meet all of those sustainable criteria. Now, when we start looking at facade treatments and natural light, I don't think we're going to go quite this far either. When I showed James this earlier, he thought this was a concept design for phase 3 building. But I think the point is it's going to be somewhere in between, because what this starts to draw out is those well-being points. Yes, natural light is important, and this might be good on the thermal model, but actually we need a holistic design looking at natural light versus air quality versus amenities. Now, if you go back 10 years ago again, buildings with exposed services in the Birmingham market, for a speculative building, we wouldn't have done. The agents wouldn't have supported it. So actually, it's for everyone in this room to drive the design agenda for how we get to that point and strike that balance. This is a CGI, almost taken image of 3 Chamberlain Square now, and as the facade's white, it's not very obvious on that screen. But the point of this, if you focus on that at the rear of the image, is that there's about 50% less glazing, approximately, on 3 Chamberlain Square than there is on the early buildings at Paradise. And that sort of shows that shift. Now, we were shown an image early on in the design when we were trying to adjust and meet some of the more stringent sustainability criteria. And the glazing proportion was probably about 30–40% at that point. But it looked a bit more like that castle image. Now that's when we sort of think, well, no one wants to be in an environment like that. So yes, you can have a high-performing building and a high-performing facade, but actually people need to want to be in this space, which brings me back to that point about the holistic design and balancing everything out. So I think the net zero agenda is absolutely fundamental. Sustainability of the buildings is fundamental, but the well-being side of it is absolutely key as well. And it's not just the statutory and the corporate objectives that are putting pressure on us to push us down that route. The occupiers and their staff want to be in good places like that as well. That fundamentally flows down to staff recruitment, staff retention. So you can see how all these are interlinked. Now the badges that these buildings achieve, and this is again 3 Chamberlain Square, are really, really important. But whereas before, 10 years ago, they were probably, fair to say, more of a tick list to achieve some of those BREEAM ratings, now it's about the design features, it's about the whole life carbon, it's about the amenities of the building itself and the flexibility of the space. Essentially creating a space that people want to work in. Which then brings me to the point of how do we deliver these buildings in this market? It's a real challenge that I'm sure all of you are facing when you approach the point of feasibility phases of a scheme. And yes, the rents over the last 20 years have grown considerably, actually probably more since the mid-teens of 2000s, coinciding with when the first buildings at Paradise were delivered as well. These are Birmingham rents. But actually, they needed to, because, again, you'll be fully aware that in that same time period, the construction costs have risen sharply. So we need to be clever with our design, and we need to be clever with the feasibility. And that's why, from a long-term investment point of view, we can actually take a bit more of a view about feasibility. 3 Chamberlain Square would have been struggled to get signed off 10 years ago with the levels of profit that were predicted at that point. But you're future-proofing it for the long term, and we've got confidence that it will come back. Now, more importantly, from my perspective, this is the kind of slide that actually makes us press the button or not. And you can see in that same time frame, particularly in the last few years, the yields have moved out quite a lot, driven largely by macroeconomic activities such as Brexit, the trust budget, and the Ukraine war, to name a few. So we do need those to come back in order for us to be able to push the button on some of these next projects. But we're confident it will do. So to finish, I think it's important that we approach all of those design challenges striving to make the most efficient buildings that we can, but we need to make sure that it can stack up financially. But fundamentally, we can't lose sight of the fact that we need to create a space that people actually want to be in and work in. I'll hand back to James.
Great. So, having looked at Paradise in detail, I just wanted to spend a couple of minutes to close, looking at the Birmingham market, what the pipeline looks like, what some of the big moves and the investment plans are that perhaps present opportunities for some of you in the room. So the BBC are relocating to an area called Digbeth next year, and that will really be that anchor tenant that the area has required to kickstart redevelopment in the area over the coming 10 to 15 years. Not least because by 2030, the high-speed train network, HS2, will arrive in the city with Curzon Street Station just to the north of where the BBC are moving into. So those two things together will have a really catalytic impact in that East Birmingham area of town. The other station for HS2 in the region is at Interchange out near Birmingham International Airport. And again, by placing a large piece of critical infrastructure in a new area, you present opportunities for investment and development. And Muse have created a joint venture with the University of Warwick to create a new location for homes, commerce and leisure called Arden Cross, out near Birmingham International Airport. There's a growing momentum within local government and the combined authority to create a mayoral development corporation in support of delivering a new metro extension that goes from the city centre out towards the airport. Now, its primary purpose is to facilitate access for people in East Birmingham to the jobs that are existing in this new vibrant city centre we've described. But actually, one of the main drivers is creating access to the new sports quarter that Birmingham City Football Club are planning, a £2 billion investment just outside the city core. That's about 2 kilometres from that train terminus I talked about. So they need to use public sector investment to open up the potential for private sector money. Ross has talked in detail about Paradise. That obviously carries on. And in a similar vein, Smithfield, an area where the wholesale markets were relocated that I referred to in the big city plan, Lendlease have just secured outline planning for their master plan, and that will start to come online in the coming years. Similarly, just to the north of HS2 terminus is the Knowledge Quarter. This is one of 3 investment zones in the West Midlands, and that money again will help to unlock the potential for a site that's owned between Bruntwood SciTech, Aston University, Birmingham City University and Woodbourne Group. Again, an enormous opportunity for research-led, knowledge-based innovation and commercial district. And then with HS2 coming online and bringing effectively putting Birmingham city centre in Zone 5 of the London Tube map, opportunities like Hammerson's Martineau galleries become more viable because they'll be on the doorstep of this significant new landing space in the city. And so to finish, I'll go back to where we started, which is in Birmingham City Council laying out their plans for the city that form the blueprint for others to follow. And the problems of the City Council are well documented, but I think it is worth ending on this point that the new Our Future City plan sets that benchmark and that ambition for the area that looks to bring some of that investment out beyond the city core, emphasising low carbon, environmentally friendly homes, green public transport, and a significant increase in the amount of planting and greenery throughout the city centre. So perhaps you'll invite Ross and I back in another 10 years and we can reflect on how well that's done. Thank you very much for your time.
Okay, yeah. All right, thanks, James. Thanks, Ross. Certainly feeling a lot more positive about the future of Birmingham. A couple of housekeeping that I forgot to mention, but there's no fire drill today. If there is a fire, just exit those doors and we're going to go just by the Aloft Hotel, not staying there, just outside. Let's convene there. Toilets are outside on the left and right. And if there's any questions for any of the speakers, just grab them during the break. That's great. Okay. Next up, we've got Alan McCartney, who's a partner at Howells, and he'll be talking about ideas in place. Over to you, Alan.
Morning, everyone. Is this okay? So I'd like to do just a few minutes and a whistle-stop tour around how we as architects approach building design, in particular facade design, what's important to us and the methods that we employ. And that will accumulate in a little bit more detail about the building that Ross and James just very well introduced and giving context around Paradise, which is Octagon. So thank you for the introduction. My name's Alan. I'm a partner at Howells. We're a business based in the West Midlands, but with studios now in London and Dublin. We're a team of 100 architects, and we're recognised increasingly throughout Europe as exceptional designers and a design-led organisation. We've got a very clear methodology and philosophy that's been embedded in the business over about 30 years of development, that every building and project that we're engaged in is crafted, lean, elegant. It's appropriate for its context and place, and I'll keep coming back to that point. And it has a developed narrative that's ever present in the projects that we bring forward. And a range of the type of work that we're involved in, from large-scale residential master planning right the way down to cultural visitor attractions and everything in between. And as a business and as architects, we believe in the importance of ideas, and we believe in the importance of conveying and drawing, displaying those ideas. So the projects that give a snapshot of how we approach that, the ones that I'd like to share, we've got Miller's Quay, which is in Birkenhead, 500 units, BTR project. Pershore Junction, a very different scale, which is a 167-bed PBSA scheme in Sturchley in Birmingham, and then finally building to Octagon in Birmingham City Centre. Three very different facades, but are all born out of the same design approach and core design philosophy. So with Miller's Quay, this image gives a very good contextual representation of what the site is like. It's this really interesting mix of scale and grandeur. It's almost mountainous in the way that you experience weather in this part of the world. A range of some legacy Victorian heritage that's present on the site, and then some more modern, slightly disused, semi-derelict warehousing and maritime construction. But before addressing what's on the site today, we just always take the opportunity to look back. And in this case, if we go back 100, 150 years, we've got a very wonderful legacy where we've got the first publicly funded municipal park in the country that was based in Central Park. We've got the first use of a street tramway. We've got the first ironclad screw-propelled ship constructed in the country, which is the SS Great Britain. First submarine trials in the UK. And we've got an incredible legacy and history of maritime innovation that's actually still present on the site today. So that gives us a really rich context and narrative to bring forward. But when we actually zoom in, what we do have is predominantly a brownfield, disused dockside location outside of Liverpool. We've got some really beautiful Victorian architecture that's present and been retained, but albeit in semi-derelict context. And then areas such as the bridges, which have all been lovingly restored and are still in use today. They were originally steam-driven, now electrified. But with metal on the sides, that's been restored, vibrant colours, cared for and looked after. And again, that was one theme that we've brought forward in the architecture. One of the only large-scale warehouse buildings that still exists was the East Float warehouse. That was converted in 1990 into residential apartments, but it gave us confidence in the scale, archetypal form, and the way that warehousing was historically present in this location. And that's the same building on the top right-hand side of the slide, and it gives us clarity in how the Victorians organised the dockside and what it was in its heyday, particularly this very formal relationship to the waterside edge and a very hierarchical, very immediate functional relationship between buildings and what the actual use of the site was. Which is why when we inherited the diagram on the left-hand side as following the competition win, these are the outline master plan parameters that conceived at the time in 2017. A series of courtyard buildings that to me and the team at Howells seemed incredibly alien to the way that the actual Victorian historical context would have organised buildings on this site. So we fundamentally binned all of those parameters and just proposed 6 very simple finger buildings that had a very immediate and formal relationship to the waterside edge. Really simple, elegant principles that everybody would get some sun coming into their home at some point of the day. Everybody would get a view of the water. We would have no single aspect north-facing homes. Every single pair of buildings would be coupled together to provide a garden space. Given the nature of the product in this location, we had to integrate cars. Cars are a guest in this site, but there had to be ample parking provision. And we also wanted to ensure that we had public access to the waterside, but that didn't infringe on the privacy of the residential homes that were being provided. And this is the way the master plan developed. What we've resulted in is a scheme that has been now constructed but anticipates development to the east and western side of it, and it anticipates at a point in the future integration and reuse of the waterside edge in a more successful way. So going back to the chimney that we saw earlier in that historic slide, but also consideration of cranes and buildings of scale and metalwork, we knew that we wanted to put a tall marker building onto the site to give it identity and presence as a residential scheme, and then also repeats quite confidently this archetypal warehouse building that's regimentally proceeds down the dockside edge. We also knew that where we've got retained buildings in brickwork and masonry, those are parts of the past, but actually the future of this site and sort of the ongoing celebration of it is the maritime and the way that metal is treated in this particular setting. And we also saw a really strong opportunity to take, albeit in commercial identity and safety-driven initiatives, the colour and vibrancy of a maritime context and actually bring that into the buildings to be representative of what occurs on the site today and what could come forward in the future. We also know that residential homes in this particular industrialised setting needed their own identity, and the idea of just creating a picture postcard for the world was really, really key to our thinking. We're also very minded that if you've got a red building, a blue building, and a green building, you can tell your friends in which building you live, so it gives intuitive ways showing an identity to the home. I will confess, this is a trick that we played a few years prior for a building for the same client who repeal. On the site, this is the Wirral Metropolitan College. That's a 25mm corrugated anodized aluminium. Again, archetypal warehouse building, but it juxtaposes and it relates really successfully with the retained industrial heritage within which that building has its context. For elements in the facade, other than the facade itself, particularly for balconies and the glazing, we were very literal to the 1930s context of maritime shipbuilding that had occurred in the site. That photograph on the top left is actually the site on a barge that had been moored in front of the building complex for the last 5 years. So we just stole the way that balustrading was done, and we stole the crystal window systems, and that's basically been replicated in a contemporary way on the buildings on site today. For any other residential building that I've designed over the last 20 years, I would go from the inside out, and that's very much what Octagon has done actually. I want to share slides on that shortly. You want to start with the quality of the home and make sure that the architecture complements that philosophy. We did Wirral the other way around. So we knew that we had a 45mm facade module. Every single decision in that building, structure, circulation, down to the sizing of the toilet pods, were all based on preserving that 45mm modularized grid around the perimeter, which meant that going into planning, we had to have reasonably clear understanding and sophisticated ideas about all of the detailing and interfacing so that I could indemnify and guarantee that I could actually build the buildings that we had designed. And that's what we forward in size. So we've got the taller building on the left-hand side as a marker, giving a little bit of prominence and height. Not as tall as the market would allow us to go. We would have gone as tall as we could have done, but that's a 13-story building. And then this archetypal procession of warehouse buildings running along the dock edge. When you view each of the buildings as a couple, we have effectively two scenarios that are generated. In this instance, the red is accentuated and driven and made more vibrant by the relationship to the grey building. But then when you see in the heart of the site, we have complementary colours of the blue and the yellows. And we looked at about 1,500 colour permutations before deciding in this. And actually, in consideration, I'm not a big football fan myself, but the football teams and colours in this part of the world were actually one of the guiding considerations, that we didn't want to affiliate with any particular football team in this part of England. So a view on the right-hand side of some of the facade detailing itself, particularly how the buildings hit the ground, how we achieved the balcony detailing with the horizontal articulation. There is a recessive chicken wire grid behind that, so you don't have climbing issues that have come about. And then the Crystalesque buildings with the Crystalesque windows with the horizontality in the main facade. A view from the other side, where we've played tricks of changing the roof type just to give additional visual interest and distinction between the buildings, and just a little bit more identity to each of the homes and some of the details in how that facade corrugation has come forward. It's PTFE, which is effectively a Teflon coating to each of the buildings, which not only gives us a degree of colour fastness and longevity, but particularly in this maritime environment, it's really the only coating that's appropriate and warrantable for that particular site. I also have the privilege of fronting this kind of development, but I really have to admit that I sit at the forefront of an incredible team. Ramboll, absolutely instrumental in some of the early facade engineering, and really FK and Graham's were the contracting teams that brought forward the quality that we finally achieved in the building on site. Very different scale, very different location. Pershore Junction is a 167-bed PBSA scheme, 5-story building in South Birmingham, effectively in a Victorian village in Sturchley. And exactly the same method that we applied at Miller's Quay, we just wanted to look back to understand what the heritage was. And the Victorians, with the street pattern, they completed up to the turn of the century everything in this master plan except the infill corner. And then in varying degrees, when we look south, you can see the continuity of that street grid and the success of that. But when you look at our site on the right-hand side of this slide, actually, there was a building that went forward in 1935, but then there was an infill block that you can see getting built there by BT in 1954 that was very functionally derived, but completely out of character for this area and this setting. That building was out of use by about 2005 and completely derelict and a drug den by the time we inherited it in 2019. So we took a very simple, fundamental approach. We had the opportunity to complete the master plan that the Victorians set up 150 years ago. There were lots of ways that we explored doing that, and that's shown in the model images on the left. And we ultimately just came back to the really simple idea of taking the dimensional depth of the terraced housing that we had on the side of the site and just continuing that and wrapping it around the corner and giving a little bit of a setting and a nuanced uplift to the pocket park and crossroads that we would be creating. We then took a really indulgent opportunity to take a step back and look at the heritage buildings that were within about 50 metres of the site itself, predominance of masonry, red brick and brown brick. A lot of faience, a lot of crafting, mansard roofs, dormer windows, setbacks. And then we also took the opportunity to just draw the buildings, and we drew every single one that we could get close to. Each of a top, a middle and a bottom, very simple Victorian Georgian principles of organisation. We've got articulation, celebration of the entrance, we've got faience, and more refined corbel detailing in the main body of the facade. Very simple roof with setbacks, quite often dormer windows present in a lot of the residential properties quite close by, and then quite a robust specific architectural treatment to the base of the building. And then looking at 200 different brick samples, we finally chose one that we felt was complementary to that immediate context and developed that through. So we knew that we had faience, concrete creasing tiles, we also knew that, stonework creasing tiles, and then we had brickwork, and that was effectively the development of the architectural language through into the facade. One of the more complicated ones that we've done, because we as architects owned all of these interfaces, quite often we benefit from facade teams that work in partnership with us. In this particular one, all of the supply chain came through our office and we coordinated all of the interfaces. And then just to show the before and after of the building in its setting. And the curve was achieved, all the brickwork, all the glazing, all the terracotta are faceted. The only curved element in the entire building is actually the creasing tile, which made it economic to build in this particular location. The image on the right and the image on the right are taken on the same day, just from different angles, and they show really how, through the honesty of materials, there's a craftsmanship and a celebration in the quality of the materiality of the facade that's achieved just by how light falls on it. And acknowledging really the quality that Adept brought, local facade installer based in the Jewellery Quarter, in putting all the terracotta in, and then Meath Build, who hand-laid all the brickwork, really are the guys that contributed to the success of the scheme. And at a completely different scale and a completely different location in the city centre, Octagon. And Ross and James have given a really good contextual setting to what this building is. 370 homes, 50 stories. My client sat in front of me says it's 49, but I'll take the hit and say it's 50. Mix of studio 1, 2, and 3 beds and a BTR offer. And the guys have touched on what Paradise is. Paradise is transformational. It has continued and will continue to be transformational for the city. It's an incredible setting. It's a master plan that we took forward as a business, and the site that we're dealing with is that rectangle in the northern section of the master plan, first residential building to come forward. And fundamentally, the geometry that I've just shown you begs the question, why an octagon? We are not an architectural practice that does anything for vanity. Everything is deliberate and considered. So the idea of having height on this site allows it to be a pivotal marker that ties together the hotel on the south of the master plan with a setting to the north. And then to the east and the west, we've got two historic assets in the Temple of Dreams, which is our War Memorial in Centenary Square, and then the clock tower on the Grade 1 listed Birmingham Museum, and that Octagon can play its part in that intuitive way showing and part of that contemporary language in that setting. Specifically for the building itself, we've got future plots that we need to relate to, so the geometry to the east and the south is set by that, and then taking a very geometric, faceted approach to the geometry around the perimeter of the building to the north, an octagon made incredible sense in this location. When you start to look at that, you conventionally think that a one bed is 7.5 metres in length, two bed would be 10, 11 metres in length. If we can achieve an 8-sided shape with 8 units per core, every unit, including the one beds, would be 13 metres in length. From your GCSE mathematics, you'll know that the efficiency of a building, a circle is going to be more efficient than a rectangle, net to gross and wall to floor, all considerably improved by this building geometry, and that's again why it made incredible sense in this location and why we were able to build it. But we also had incredibly supportive clients who pushed us and laid the foundation. 8 units per floor, completely honest in the building all the way up. Structure, in situ slip form core, and then radial precast columns that run out to the facade. Spatial arrangement, all of the M&E wet systems, kitchens and bathrooms are pulled into the core in the centre, and that allows the facade to be completely unhindered of M&E and just celebrate the view out to the city. Very simple democratic approach to fire evacuation, very short evacuation distances through the corridors, and then the core itself is carved out as an archetypal form so that you experience the geometry of the building when you're moving through the circulation, and really an indulgent architectural celebration of what that could be. That's the plan that was developed, a series of 1 beds and 2 beds that run in a pinwheel all the way around. Each corridor is only accessed by 2 units, so there's a sense of exclusivity and privacy, and really sort of celebrating how intimate the residential experience is in each home. The 1 beds, 13 metres wide, 8 metres deep. All units are over nationally prescribed space standards. You open the front door and you get that incredible panoramic view of the city immediately. A real celebration and giving you an immediate connection to Birmingham and immediate celebration outside the building. 2 beds, we really seek to repeat that trick, but in addition to being 13 metres in width, these individual units are 13 metres in depth. And we've tried to do the same trick with the front door, that when you open it, you get that incredible glimpse view, that immediate view outside to see the panoramic setting of Birmingham as a city. We have a geometric form and plan, and we knew that with creased metal, we could repeat the geometric form in the facade design itself. Typically, to the flanks, to the corners, we've got the bedrooms. So really, really simple methodology is to pronounce the depth of the facade as much as possible to the corners. That gives the perception and the feel of privacy and an additional sort of shading to each of the bedroom spaces. Where you've got in the heart of the facade section, the living accommodation of the apartment, you want to pull the facade in so that you can get that view down to the street and you can get the view up to the sky. And that's no more intelligence than that. It's been applied to the geometry, how that's come forward in the main facade itself. Unitized system built top to bottom with a 700mm projecting articulated facade bay. There's only 3 panel types that are then repeated symmetrically around the center point of the main facade bay. It wasn't built in one hit. There were actually originally it was installed in 6 panel sequences, but they've now been coupled together into 2 panels. So each facade bay is a collection of 3 unitized that have been applied. To accentuate the horizontality in this idea of panorama within the city, the casement glazing system has been designed with a regressive SSG joint to the upper level to reinforce that horizontality to the glazing that each unit benefits from, where we then have introduced a pronounced sill at that mid-transom point that allows us to create shadow under the facade, that creates a regressive condition that hides all the casement metal, that the actual casement opening lights occur in the bottom section of that facade detail. 5 facade mock-ups were built prior to it getting to site, and that gives you a scale of any typical 1-bed or 2-bed individual bay, which the scale of each of those sections is lost, I think, when you see the building in context. The entire building was distilled down in the facade to these particular interface details. The joint is plus or minus 2 millimeters, I think, on the top end, and plus or minus 6 millimeters on the facade on the front. And all of those jointing conditions have been absolutely preserved in this quality management panel that's been provided, just with the building actually coming up in the photograph behind. To the top, we've got a really simple, articulate design, a sculptural idea that we brought through in the office that's lit in a really simple, elegant way. It's warm lighting to reflect the residential nature of the building. As residents start to turn off their lights at night, and about 11 o'clock, half 11 at night, this building will also turn off to reflect that it's a residential setting, and the crown itself will turn off. I've had a phenomenal team internally to build this one through on site. It's been a really joyful process. Really frustrating for the contractor. It's only a 15-minute walk from the office, so we're there daily. This is 2 years ago, and we're coming out of the grounds. Some of the more detailed shots of the facade going in and the quality that's been achieved. That's an as-built photograph of what we actually have achieved collectively as a team today. And then one of the more recent, following the building being topped out, giving context to the crown that's just currently being finished, which gives you a feel for the building in its setting. And actually, we were really fortunate to build this one. This has been a career-making scheme and something we're incredibly proud of, but really excited to have contributed this to Paradise and to Birmingham as a whole, and it shows what we can do when we all work together. So thank you, everyone.
All right, thank you very much, Alan. I'll never say that architects just copy and paste from a previous scheme again. Okay, I mean, I was just going to mention that if you're not familiar with Birmingham, it's a great idea to take a walk from Brindley Place all the way down through Paradise down to St Martin's Church. It's a traffic-free route, and you'll get a great sense of all the new developments and the new and old of Birmingham. Okay, so next up, we have got condensation and airtight solutions for facades, and that'll be presented by Marc Blackie at Proctor Group. You ready?
Well, good morning, everyone, and thank you for that warm welcome. The sessions so far have been really fascinating, really interesting. So my name's Marc Blackie. I'm the Business Development Manager for the Proctor Group, covering high-rise and facades on behalf of the company. So just a quick introduction about who we are. So we're a technically led manufacturer of high-performance construction materials. We're based in Scotland, and we cover all aspects of the building envelope. So from ground gas membranes, vapor control layers for roof and walls, air tightness membranes, and roofing underlays. We also provide high-performing aerogel insulation systems. So when we're looking at condensation and air tightness, what we're ideally looking for is a holistic view of all the rounded issues that would take place within that. So looking at the outer ring there, we've got the building, the occupants, and the weather. So all will contribute to how we assess the hygrothermal design to give us a healthy building. So from the building point of view, this is where as designers we have most control, but not all building types are the same. If you take, for example, a concrete structure, it'll have a higher initial moisture loading, but it will also have a higher capabilities to retain that thermal mass. On the flip side, if you've got a steel structure, the initial water loading will be less, but it won't have that ability to retain that thermal mass. Also, the type of construction will be key as well. So if you're building off-site or on-site, obviously on-site trades have a far more wet trades to consider. So that'll all have to be dried out to affect those initial moisture loadings. So, but ultimately, we're looking to get the building watertight as quickly as possible to reduce the moisture within the building. When it comes to external weather conditions, obviously we can't control the weather, and that will change from day to day, week to week. But what we can do is have an influence on the orientation of the building, which may affect the amount of solar gain that you actually get from the building as well, and also taking into consideration local structures, whether they're the buildings themselves or natural geographical structures. They may affect localized wind loads. And finally, the occupants themselves, most importantly. And what we're looking to do is making sure that we're creating a healthy and fit-for-purpose environment. So from an occupancy point of view, what will the occupancy levels be in service? So higher residential structures will have a bigger moisture loading than, say, retail or commercial. So that's something else we need to take into consideration. So as we learn those kind of high-level factors influencing the building's performance, we can then move along to assess the interaction of heat, air, and moisture movement through the building structure. So understanding that interlinked nature will be key to a durable and sustainable and effective facade system. So getting the building heating efficiently, getting the right type of insulation, looking at the fabric and any minimizing thermal bridging, making sure the building's hitting its air tightness targets and controlling the building moisture ingress and egress. So in respect of air tightness, the regulations typically demand a pressure test to be determined to analyse the air leakage and provide a method for doing so in its overall heat loss assessment. So that involves either pressurising or depressurising the building to a reference pressure of 50 pascals, and then measuring the airflow necessary to maintain that pressure. So under the building regulations, you can pressurise or pressurise or repressurize the building in either direction, but under Passive House standard, it's slightly different. You have to do it in both directions, and then the two results are averaged. So there's a slight difference between the two standards, whether you're looking at building regulations or Passive House. They typically give you a backstop or worst acceptable value. Now, depending on the regulations, the backstop is typically around between 7 to 10 metres cubed per metre squared per hour. Now, in the Republic of Ireland, the backstop is set at a maximum air leakage rate of 7 metres cubed. England and Wales, as Part L, it's 8 metres cubed, and in Northern Ireland, it's set at 10 metres cubed. Now, in Scotland, a rate of 7 metres cubed per metre squared per hour is used for the target emission rate, and a rate of 10 metres cubed or less is recommended. So to put what that effect can have into context, we set a baseline SAP dwelling emission rate of 12.18 with an air leakage rate of 7 metres cubed and a wall U value of 0.15. So assuming that all else is equal, let's consider what changes we can make to reduce that dwelling emission rate by an equivalent amount using insulation versus air leakage rates. So it's a really simplified example, but it does go to show the kind of general principles, really. So if we were taking the air leakage rate to 0.5, which is roughly comparable to Passive House standard, it will reduce the dwelling emission rate by almost 7%. So if we were to achieve a reduction like that through fabric insulation, we would require a U value of 0.05. So what does it mean if we were to get that dwelling emission rate through the U value on its own? So it would require a significantly greater thickness of insulation, 570 mil of typical fibre slabs outside of the frame. You might also need extended fixings if they're available, so they might be bespoke. There might be increased flashings and other ancillaries, and also the space footprint of the building does become compromised. So, and it also might not be practical to include those levels of thickness. So getting the air leakage rate down to 0.5 gives us a far more realistic build-up to be used, and in practice isn't that difficult to achieve, because the increasing numbers of passive houses, certified buildings across the country and across the world as well. So designing in that air tightness does provide you for designers for more flexibility later on, particularly in relation to material choices. So for example, it might allow you to have thinner insulation boards, or if you've got combustible rigid foam insulation, that can be replaced with less combustible but lower performing mineral fibre without affecting energy efficiency. Now, correct membrane placement and specification is really critical to optimising performance for both condensation control and air tightness. Now, membranes will have different characteristics. So an air and vapour control membrane are both air and vapour tight, and they're placed on the warm side of the insulation. Now, vapour permeable membranes are an airtight but vapour permeable, which means in some instances we can omit the VCL, which allows us to place that air tightness layer anywhere within the wall build-up, or even actually on the external sheathing board before the installation of the external cladding. So, as I say, the correct material needs to be placed in the correct position. So just to highlight some of the product types on the screen there, so we've got Proctor's ProCheck A2, which is our A-rated VCL for placement on the warm side of the insulation. Wrap-Tight, which is our self-adhered air tightness breather membrane, and ProBreathe A2, which is our tape-applied A-rated membrane to be placed over a sheathing board. Really, the selection of any of these membranes is down to a successful hygrothermal analysis, and the building BS 5250 references two standards for that. There's the simplified Glazer method and the more up-to-date and advanced dynamic numerical simulation method. So with that in mind, I just wanted to give you, over the next few slides, the application of our Wrap-Tight self-adhered air tightness membrane used in high-rise and facade. So it's a high-performance self-adhered air barrier that's really changing how we think about air tightness in facade construction. So as we face demands for energy efficiency, compliance, and buildability, systems like Wrap-Tight are really stepping up to meet those challenges. So Wrap-Tight is a self-adhered, vapor-permeable air barrier. Now, unlike traditional air barriers that may require mechanical fixings or internal placement, Wrap-Tight can be applied externally and bonded directly to the sheeting, creating a continuous airtight seal across that building envelope. And that kind of external placement is a real game changer, especially in complex facades. So why does that matter? So firstly, it's self-adhered, so there's no need for tapes or fixings, fewer penetrations, so there's less thermal bridging. Secondly, it's vapor permeable, but airtight, meaning that moisture can escape, but air won't leak out. So it supports durability and energy efficiency. And thirdly, because it's external, or it can be applied externally, we avoid that difficult task of aligning internal air barriers across floors and systems. Wrap-Tight is it's BBA certified, and it performs exceptionally well in wind and water and air tightness tests. We've seen it applied in a number of projects, from CLT to high-rise, and also high-rise residential, where that speed of install and envelope integrity is some of the key drivers. It also simplifies your air tightness strategy, supports Part L, and reduces any on-site complexity. So for architects and facade engineers, it offers certainty in both performance and execution, and from contractors, it means faster builds with fewer variables. So it's a modern solution for modern facade challenges. So as I wrap up, I just wanted to quickly highlight some of the technical support available through the A Proctor Group. So one of the key advantages of working with Proctor is not just the quality of our products, but it's also the depth of technical resources that we can offer. So you'll find a comprehensive suite of tools, so U-value calculations, thermal bridging calculations, condensation risk analysis, both in terms of the Glaser steady state calculation and also the dynamic numerical calculation as well. And along with BIM objects and system-specific guidance, and really that is the difference. It's not just a membrane, it's a whole system approach backed by our in-depth scientific knowledge and building expertise. So thank you very much for your time yesterday. Thank you very much for your time today. I'll be around afterwards if you want to have a chat about any of our technical tools or if you've got any project-specific requirements. But thank you for your time.
Okay, thank you very much, Mark. And I'll be interested to speak to you more about having a single membrane and see if we can get those low levels of air tightness. So next up, we've got Andrew Pries from Boston Valley Terracotta. He'll be talking about architectural terracotta industry for sustainable high-performance facades. Thank you.
Hi everyone, thanks for having me here today. I'm here to talk about an ancient, really timeless material that integrates really well into high-performance sustainable facades. But first, before I want to talk about that, I want to talk about something that I'm sure everyone is keenly aware about, which is the urban heat island effect. It impacts pretty much all the major metropolitan areas. As you look across the map of Europe over the past, we'll say 150 years, you can really see how many urban heat islands have popped up and really across the globe. It's quite insurmountable how many urban heat islands are there. And this is a challenge that we're facing today, especially when you couple that with the global CO2 emissions. 42% of CO2 emissions are from the built environment, and when we boil that down, 2/3 of those emissions are from building operations. So I'm sure you can see the correlation between urban heat island effect and building operations. So how do we solve that? A team from Beige Architecten, Nippers Helbig, Transolar, and Tri-Pyramid looked to solve that during our ACAW workshop last year. They looked to do so by trying to slow and control the flow of water across a terracotta rain screen facade to increase the evaporative cooling potential of the material, of the facade. They additionally studied the different wall types that you could install this with, starting with the base case traditional rain screen attachment system, and they were able to eliminate about over 50% of the embodied carbon within that system. And they did this all while making quite a beautiful facade. But it's not just about making beautiful facades, it's also about the data behind it. So they tested it, and after a 10-minute rain event, the terracotta facade was about 11 degrees Celsius cooler than the prior to the rain event, and it maintained that same temperature differential for over 2.5 hours later compared to other facade materials in nearby setting. This is great. I mean, it's a great prototype. It proves that this could really work as a game changer for how to eliminate some of the urban heat island effects. But it's just a prototype. What's next? How do we bring this to market? What other ways can terracotta contribute to the built environment, solve some of these other solutions? It's been around for thousands of years. I challenge you all as creative thinkers to think about how terracotta can contribute to the next innovative facade. For those who don't know what terracotta is, it's an ancient, timeless material that is known for its versatility, durability, and malleability. It fits seamlessly in both historic contexts and also in contemporary facades. It is it's a geologically derived material made from one of the most abundant materials on Earth, which is clay. All of our clay suppliers follow the Land Reclamation Act in the United States, which basically means we don't want to leave scars on the earth. They have to restore the land back to nature and allow it to reacclimate and not be an old strip mine, if you will. Additionally, we incorporate up to 30% of recycled content in our body in the form of shamut or grog. And terracotta is one of the most green products out there on the marketplace. When you look at the amount of energy required to produce terracotta compared to other materials, we require about half the energy as cement and 100 times less energy than aluminum. We like to joke, if you remember the old food pyramid, that terracotta is green like veggies, so eat your veggies. But they do say that the greenest building is the one that's already built. Battersea Power Station Turbine Halls A and B is a project that we had the pleasure of being a part of. So a quick thing about Boston Valley, about half of our business is heritage or restoration projects, and the other half is new construction. So the Battersea Power Stations were in pretty rough shape when, before the large project commenced. Here you can see some of the damage from being basically abandoned for quite a number of years. We had the privilege of supplying approximately 17,000 units to this project, and really it's quite transformative now, seeing the before and after. It's really quite stunning. In order to pull off this job, we developed 3 custom glaze matches for this project and cut 32 unique extrusion dies to produce all the material required for the job. So I challenge everyone, I'm giving you a close-up here, to figure out which one of the units we replaced and which ones are historic. Another project we did in London is Rathbone Newman Passageways by Make Architects. This is a signature project for Make Architects, and it's this jade glaze was custom developed specific to this project. The unique thing about this glaze is it's actually to match the client's jade bracelet that she had. So when she came to visit our factory in the United States, she pointed to her wrist and said, "This is the color I wanted," and we custom matched that glaze specifically for her. So here you can see a couple of different rounds that we were going through. And then we custom bent the extruded terracotta panels to meet the 2 different radii on the passageways. And then the bullnose pieces, which cap the entrances, are hand pressed, and they're about 600 millimeters tall, just to give you some context. So they're quite deep, large units. And really, it turned out quite stunning. It's a great wayfinder for pedestrians walking through here to go into the central Rathbone courtyard, where there's a beautiful garden inside of it. Changing scales a bit is the Marylebone Square. This is by E8 Architects. This is an entire city block. It doesn't look like an entire city block. The architect actually purposely chose 4 distinct glaze colors, and we'll see a couple of photos coming up of those to break up the facade. We are unique where we have 4 different production methods for producing terracotta. So I'm sure most people are familiar with extrusion. We also do hand pressing, ram pressing, and slip casting. So for this job, we produced about 9,000 extruded panels, about 400 ram press panels, and then a combination of 300 panels between hand pressing and slip casting to pull off all the different features on this facade. This facade was installed by Zerelmi, and it was put in place following a more traditional stone veneer fixing methodology. And that's one thing that's great about terracotta is you really can put it on a facade in a myriad of different ways. Unitized current wall, precast, stone fixing, rain screens, really the possibilities are quite endless. And I have to say, with the project being complete, it fits seamlessly within the neighborhood in Marylebone. But it stays distinctly contemporary, so it really does a great job blending the old and the new all together. Jumping across the pond to Toronto, Canada, is a project called The Well. This was designed by Harini Pantarini, a Toronto firm, and then BDP Architects out of London was responsible for the retail space, which is where our scope of work resided. This project has 3 distinct white glazes. They wanted to develop a variegated facade that seamlessly blended the historic neighborhoods with the new, more contemporary Toronto skyline as well. I think they did a really good job of meeting that. Additionally, this undulating quad mesh canopy, it's about 3,500 square meters. We had to custom tailor some of the panels to receive all the penetrations and make sure that all lined up well and didn't have some big ugly gaps around them. This entire project was fixed using our typical rain screen tracking clip system. So even though the modules are quite large, as you can see on the right-hand side, our system was able to support it without a problem. And that even includes the curved soffit panels and the bullnose radius arch pieces as well. This project, actually, sorry, let me go back. This project is quite forward-thinking. It's really impressive what they were able to pull off. I suggest you all Google the project The Well to figure out why it actually got its name. The developers really were quite forward-thinking in all their sustainability. This project achieved LEED Platinum, which is quite an achievement, and this is one of 7 buildings on the the plot that achieved the LEED Platinum status. Speaking of forward thinking is a project that we did with Arup during our ACAW workshop last year as well. This was a multinational team from Arup comprised of participants from the London office, the Toronto office, and the Los Angeles office. They want to rethink how to utilize terracotta in a wall typology. So first, just like Banish and team did, they studied different wall systems to understand how much embodied carbon is found within each wall typology, to look to see what could they do to eliminate a lot of that carbon. From there, they looked to take advantage of terracotta's compressive strength. Terracotta's compressive strength, sorry, I'm going to be American here and give you pounds per square inch. It's about 10,000 PSI, or about 3 times your typical compressive strength for regular concrete. So they looked to take advantage of this properties and make a modular system that was easily deployed on site that didn't take up any more wall cavity than a current wall construct to be developer friendly, to make sure you maximize their rate of return for that. They additionally needed to make sure it passed all of the thermal analysis required to be a built wall. So they studied it thermally, structurally, they looked at the condensation, they looked at how to control the moisture. And this wall system, they were able to save had 25% less carbon in it than a traditional brick wall, and 40% less carbon emissions compared to a terracotta rain screen. So they were quite successful in achieving the numbers they were looking for. And they came up with a really beautiful glazed finishes for both the interior and exterior wall systems. This system is able to be just dead loaded onto floor slabs for up to 6 stories in height, and after that, it just requires minor post-tensioning to be able to go up to more of a mid-rise height, if you will. So it's quite a successful wall system. The insulative material that they're using is foam glass to achieve the thermal performance. So I mentioned ACAW a couple times. ACAW is an annual workshop that we put on. It's the Architectural Ceramics Assemblies Workshop, where leading architects and facade engineers come to partner with us to design and really push the limits of what's possible with architectural ceramics. We've been doing this for 9 years. We're going into our 10th year now. And I just want to quickly go through a couple of projects. This is by Wish Jenny Elsner Associates. They deal a lot with heritage projects in the United States, and cornices are quite often understructured in the United States when they were built in the late 1800s, early 1900s. So Wish Jenny looked to take advantage of some of the rain screen fixing systems that we deploy to be able to create a heritage-looking cornice, but save immense amount of weights. I want to say this saved approximately 75% of the weight compared to a traditional cornice assembly. Or here's Woods Baggett's system. They look to incorporate PV panels in a spandrel system, so utilizing ram press terracotta to increase the performance of the PV rate. Additionally, they look to, they want to beautify the PV panels. In their words, they're quite ugly, so they want to use terracotta to make them look a little prettier. Or Seldorf Architects with Sogotech look to use origami folding principles to reduce the weight of terracotta panels. So by folding the terracotta, they were able to save about 50% of the weight and create a self-structuring panel. ZGF looked to create a modular screen that would be adaptive to different programmatic needs interior, or also respond to the sun as it goes across the sky. Henning Larsen look to create a facade that is actually carbon positive by promoting moss and lichen growth on the facade. We utilized a directional glaze so that there were specific areas of bisque terracotta where the moss could attach to, and they developed this really unique crackle glaze to go around with it. Cook Fox looked to create a modular masonry system that allowed for birds, bees, and plants to inhabit the screen. And then the pods could be interchanged depending on if you need a different program or if one would happen to get broken or something like that. And then finally, Eric Perry Architects looked to create a feature wall for the fishmongers in downtown London, hence the shape. Looks like a fish scale. This green wall, they also want to promote lichen growth on the terracotta. So you can see some of the bisque terracotta is where the lichens would start to grow, and then the glazing pattern was to allow the lichen to assimilate seamlessly into the facade. So it didn't really transform greatly over time, but it's just this seamless transition. So terracotta, it's really can be a lot more, as you can see. Beyond aesthetics, beyond visual appeal, terracotta facades can transform functionality. It can reflect sunlight, it can capture sunlight, disperse heat, capture rainwater, create habitats for birds, bees, and plants. The potential really is immense. We just have to embrace it. So let's reimagine facades as dynamic elements of the built environment. Imagine terracotta facades that can do more. What new innovations can we unlock? How can these achievements help shape high performance and sustainable facades in the future? The possibilities really await. We are opening up applications for ACOT, our 10th anniversary of ACOT right now, so if you go to our website, feel free to apply. It's a great event where you get to learn a lot about terracotta and get to actually get your hands dirty and build some of these prototypes. Thank you all.
That was brilliant, Andrew. Amazing case studies and a lot of new products. Just before we break for tea and coffee, we're just going to do a small plug for the Society of Facade Engineering. Yeah.
I'm just going to invite Aneel to be with me, give me some support here. So, Society of Facade Engineering, this is the Birmingham hub. There are a lot of familiar faces who might already be part of the Society of Facade Engineering. Who are we? Not a bunch of geeks. That might have been how it started, but it's a big network now. So, there you go. So, one of the main things is, and the core aim for this year as well is to expand and bring people together from our industry. And when I say in our industry, you don't have to be a facade engineer. You know, it is called facade engineering. If you have an interest in facades, you can be part of this network, and you can, bring it forward. So we're not just a few people. It has expanded a lot, and it has been expanding in the background in multiple countries. You can see there are a lot of events happening around the globe. You've got New Zealand, Australia. You've got London Hub, which is very active in its own self. Italy has recently started, and it's really active as well. So if you are part of the Italian, hub, you can be you can join their events in Italy as well. We've got a Scotland hub, and also we have a New South Wales hub as well. Another thing was we've got started Dubai hub recently, and I just want to touch on this one here. Recently, Camille is here in the room, who recently started Women in Facades to be recognized. So there's a group. If you want to join that, please talk to Camille, who's from BB7, is at the back of the room here. All right. And this is the Birmingham Hub. Aneel has been chairing the Birmingham Hub and making sure the events, and he's done an incredible job there. We've had a Birmingham Walk, I think last year, and then we had a site visit as well, which was the October project, which I think was recently displayed in the presentation as well. It's a really good project. We've got some in the summer walks coming up as well, and some technical talks and site visits. I would really encourage you, if you are a facade contractor, a builder, a main contractor, manufacturer, please come to us. Let's collaborate. We can bring this network even bigger and share the knowledge that we have among ourselves. There's a SAV Facade Awards that happen every year. I think the winners have been selected. I'm not sure. But
No. The entry deadline's been extended to the end of this month. And you can see all the categories there. So please enter a project if it finished, completed last year. There's some of the winners from last year, but that's on the same day as Zak London. It happens in the evening, so you can do 2 in 1 if you're free on the 5th of November.
And Zak is one of the best collaborations we've got, because we both are doing the same thing, bringing facade people together, isn't it? So there are a lot of categories in here, and you can put your projects through, and the people you want to get recognized as well. Who can become a member? I've put this picture. You might be there, you might not be there. That's the last Zak World of Façades. Why I've put this picture is just showing you anyone who's interested in facade is here, and is part of Zak and everything. So every one of you can be part of Society of Facade Engineers. You don't have to be an engineer. I'm just saying that again. You have to have an experience, and that's quite easy to get people part, to become part of us. You can start from the student route, affiliate route, associate member. The student route, if you're part of the MSc, you can straight transfer yourself. If you can show your experience within facades, you can get to a membership. And the best part is this: after you've got the membership, there's a route to chartership now, which is brilliant. And the chartership is CIOB. Oh, sorry, SIPSI, my mistake. Big one. Sorry, David. So, yeah, so best thing is, after you've done that, you've got 2 titles next to your name. One is MSFE and MSIPSI, which is brilliant. Okay, so these are the benefits for joining us. I'm just running out of time, and this is the end. Just a few links to our websites, what's happening, and the route to chartership, which has started. Anyone who's member can become a SIPSI member as well. There's a route there by showing your experience, and I think it's a brilliant opportunity because we did not sit before in any place with other charterships, if you get what I mean, and we've got a route to chartership now. Yeah, thank you.
Okay. Yeah. Okay, so we're going to have a break till 10:55. Help yourself to tea and coffee and visit the stands. Okay, thank you, everyone. Next up for this session, we have Gurprit Bassi, director at Wintech and a good friend. He'll be talking about facade retrofitting for net zero buildings.
Thank you, Mr. Clare. Sorry, Dr. Clare. I'll be presenting today about facade retrofitting of net zero buildings. Right, so why did I pick this particular topic? Well, retrofitting is the buzzword at the moment in lieu of demolition, and net zero is another buzzword at the moment floating around. So what I did was combine facades into both retrofit and net zero. So a little bit about Wintech. We've been around for 40 years. You might have heard of us, mostly doing stuff with facades, but we're also doing stuff with fire and structural, and also energy modeling, which you'll see in some of the slides. So from the end of this presentation, I hope that you'll have understood that I haven't really advocated for facades, whilst I am a practicing facade engineer, but you'll understand the context that retrofitting has, that facades have within retrofitting and net zero, hopefully. Right, let me just go on to the next slide. So this is the backdrop. This is from the UK GBC. The UK has one of the oldest and leakiest housing stocks in Western Europe, possibly the world. 20% of our housing stock was built before 1919, a further 34% before 1964, and yet 80% of the buildings in use today will still be inhabited by 2050. The CCC 7th carbon budget was released a few months ago, and what they've done is they've allocated more of the carbon budget to the years 2038 and 2042. It's about a 10% increase. So what does that mean? Well, the Climate Change Committee is an independent body that writes policy on behalf of the government. And what they've essentially said is that the built environment now is going to occupy more of the carbon budget for the years coming up. So the grid, electricity grid is decarbonised. We've done a lot with that. Now we're going to focus on the built environment. And to meet the UK GBC's carbon trajectory roadmap, they think a 59% reduction in energy consumption is needed in the office sector alone. And for houses, they say we need to retrofit 2 homes every minute for the next 25 years. I mean, those are just some staggering numbers to me. So why retrofit? Why not demolish? Let's run through it. New buildings are nice. They're less restrictive, they perform better, they're less prone to failure, and they come with shiny warranties. I'm sure Clive will tell us about that later. A building might not be able to be adapted to modern needs, so it lends itself to being demolished. It might have structural issues and make retrofit unviable. And you might redevelop a site because it offers more value. So let's knock it down, rebuild it, let's not retrofit. However, retrofit can be less expensive, it's less time consuming. It can save around 60% of the costs compared to a new build. It can often retain cultural and architectural value, and relative to knocking a building down, it's often the lowest embodied carbon option and uses less resource. So why don't we consider retrofit more of the time? Well, we should, and there's been a few planning decisions lately. This was the previous Conservative regime, where they dismissed new build in favour of retrofit on the basis of whole life carbon. What's happening now with the new Labour regime is they're almost abandoning that somewhat and trying to increase the amount of building in this country. So was this a blip, or is it a future trend? Well, there are some incentives with the planning laws in terms of speeding up planning. If you are doing a retrofit, there's grants you can get. So for me, it is part of a trend, and it wasn't just a blip. Also, obviously in London with the GLA, it now requires you to do whole life carbon assessments. So what are the drivers for retrofit? There's lots of drivers. So if I have a retrofitted building relative to one that isn't, it would give me higher rental returns. It would give me stronger tenant demand. It would increase the capital value of my building, and it would give me greater regulatory resilience. So let's explore that for a minute. So minimum energy efficiency standards will be improving by the year 2030, we believe. At the moment, it's said that you will need to have a minimum EPC C for a non-residential building, for a residential building, and EPC B for a non-residential building by the year 2030. So what does that mean? Let's put some statistics to that. Everybody loves a good statistic. Savills have said that 77% of the UK office stock is currently related below EPC-B. And the Foundation Research for Home Loans has revealed that just over 2/3 of landlords, 67%, currently own at least one property that does not meet the new requirement for an EPC-C target. So that is staggering. And it's a monumental challenge. Obviously, you can get operational cost savings as well. And with often with companies with Scope 1 and Scope 2 emissions that they need to declare, ESG requirements and brands, they all want to align with more energy efficient, better performing buildings that are retrofitted. And all this is related to stranding risk. So what is stranding risk? Well, stranding risk is a building that has the potential to lose economic value or become unusable due to changes in regulatory or market expectations, just like we've discussed here. Buildings with low energy consumption and higher occupant comfort will always be seen as more valuable than their poorer performing counterparts. So there are a few other drivers for retrofit as well. Maybe your building fabric is coming to the end of its life, some of the MEP components. Can we tie that in to a retrofit? Maybe you've got some building failures that you need to upgrade. Can we also tie that into a retrofit? So what is a net zero building then? Right, so a net zero building, the UK net zero carbon standard pilot version was released last year. Version 1's coming out later this year. And what they've said, there's a lot of definitions and they've kind of unified the definition. And what they've said is for a net zero carbon aligned building, you have to meet these limits. So they've set limits for upfront carbon, operational energy, fossil fuel, heating, refrigerants, and delivered heating. They've also set targets for how much on-site renewable generation you can do. There's an option to offset, and then there's some additional reporting requirements for whole life carbon, water, electricity, heating and cooling. So that's the basic definition of what a net zero building is. And these are the types of retrofit you might see on a building. So this is from the UK GBC Guide for Offices. So what they've done here is given us some statistics. And for optimization, so this is how my building's used, maybe tweaking some of the controls, telling people not to open the windows when the air conditioning's on, for example. You can make some absolutely massive savings, 26% reduction in energy consumption. If you add a light retrofit onto the, in addition to that, so maybe I'll install some PV, maybe I'll do one-off retrofits to lighting, we can get to the region of 37%. And when we start to do a deep retrofit, which is most of the building, the fabric, the ventilation systems and so on, everything interacts, but you can make some significant savings there in energy reduction. And so if you go back to the first slide where we said that, you know, the UK has got some of the oldest building stock in Europe, I think we're going to be more on the deep retrofit side with most of the building stock that we have than the light retrofit. So what would the methodology be when we undertake an analysis of a retrofit? Well, in its basic form, this is based around PAS 2035 and PAS 2038. It would be good just to sit with the client and just say, what do you expect? What do you want to get out of this? Then from that, we would gather information about the building, so its fabric performance, its heating, its cooling, its lighting. We'd benchmark that all into a model, and then we'd do some parametric analysis. So we'd optimize the model, see what comes out economically in terms of payback, and then the most important step after that is how do we strategize? So now we know what would work in terms of energy reduction, how much it would cost, but then you need to factor that into timeframes. What is coming online, what are the service lives of our existing components, and can we strategize accordingly? Then we execute and build, then we do our post-completion. So we'll take 12 months of energy data, we'll do our guides on how to use and operate the building, and we'll try and close this performance gap between what we modeled and how the building's actually being used. So that's the basic process. So in terms of actual retrofit options, what's the best ones? What gives the best payback? So this is from the UK GBC again. Green is good, so you got energy reduction on this side, and we got cost on the bottom. And anything in green, basically at the top, is good. Anything below is bad. And as you can see, generally most of the facade retrofits come off quite badly. So you've got your wall insulation, number 8, and your window replacement, number 6. What does come off quite well is air source heat pumps. Air tightness is a good one, number 5, so that is facade related. So it's a case of how do we improve the energy reduction of our facade? How can we make these numbers look better? So for example, for number 6, the window replacement, I'm sure that's only based on energy efficiency of the windows. When we do replace a window, do we not always replace the gaskets around the window as well? Would that not contribute to the air tightness? And so would that figure not look better if we considered that as well? So can we look at these in a different way and make the facade look a little bit more attractive there with these numbers? Also from the Climate Change Committee, if you read their report, they do say that some of these technologies they envisage are going to get cheaper over time. So that's air source heat pumps and PV. So do we factor that into our retrofit? Do we do that later on when it's going to get cheaper, or do we do that first? So again, it's something to think about when we undergo a retrofit. So when we do a retrofit, there's 2 ways to do it. So this is from the UK Net Zero Carbon Standard. You can either do a stepped retrofit or an all-in-one. So what's the difference? Well, if you do an all-in-one, your operational energy target is much more stringent at the start. So maybe I want to target net zero, but I want it to end in the year 2030. Your operational energy target value would be less stringent. But if I want to target in 2050, my energy target, operational target, is much more stringent. So at this end of the spectrum, you'd probably end up doing a deep retrofit. At this end of the spectrum, you'd probably end up doing a light retrofit. But you can classify your building as net zero aligned all the way up into 2050. So it depends on which target you want to reach. So why is this important? Well, in terms of a stepped retrofit, let's think about that for a second. If we're doing a deep retrofit, which includes the facade, the Climate Change Committee said in their report that we should do the most cost-effective and quickest retrofits first. Kind of makes sense. You want to do the cheapest and you want to do the quickest because you want to try and reduce carbon as much as you can quickly. But when it comes to a deep retrofit, the facade is essentially intrinsic to the performance of everything else. It's intrinsic to your heating, your cooling, your ventilation. So does it make sense to do the quickest and cheapest first if I'm doing a stepped retrofit? A deep stepped retrofit, it doesn't. You want to do your facade first, and then everything else is based on the design of your facade. So my heating system doesn't have to be as big, my ventilation system doesn't have to be as large because I did my fabric first, and my building is still being occupied whilst the retrofit is going on. So fabric first. So this is a mantra which has been around for a while. It used to be quite a mantra, but now it's turned into a bit of a myth. So let's explore the pros and cons to fabric first. It can often be the most cost-effective investment. As you saw with air tightness, it came off really well. So as in terms of cost effectiveness, it can be quite cost effective. They're often long lasting. It will reduce the size of your renewable energy generation system. So if you upgrade your facade, your PV system may be a lot less. It can encourage passive performance. So when you redesign your facade, can you design passively? Can you put some breeze-layer on the outside and reduce overheating? Can you incorporate ventilation within your facade to do it passively instead of actively and reduce energy consumption that way? It will enable some technologies to be considered where they would not. So this is really important. So when you upgrade your facade, maybe your air tightness value comes down, and that would mean you could use mechanical vent heat recovery systems because they rely on really airtight facades. Maybe you want to consider air source heat pumps. Well, they run at low temperatures and they need really large emitters. So maybe if we improve the thermal performance of the facade, now we can start to consider air source heat pumps. It will also help to meet EY targets for some certification schemes, bring the fabric into a good state of repair, and help improve internal occupancy. Now here are the cons. It's not quick. You know, if you're upgrading your facade, it could take years in some projects. If there's a climate emergency, you know, it's not quick. Some fabric improvements can be costly. They tend to be more disruptive, so that's a choice you need to decide upon. And some, like air tightness, can be quite difficult to implement. So you might estimate that you're going to try and achieve a certain air tightness, and air tightness kind of tries to find the path of least resistance, and you're always fighting a losing battle sometimes when it comes with improving air tightness. So can we make a net zero building without considering the fabric? And the answer to that is yes and no. And it really depends on what version of net zero you're trying to aim for and what building you already have. So what are the risks? Well, when we do retrofit a facade, are we making anything worse? So if we improve the air tightness, are we reducing the indoor air quality? We really do need to check. If we're improving the thermal performance, are we making overheating an issue? So we do need to check other performance aspects if we do retrofit the facade. We do need to check planning and listed buildings. Sometimes you can't retrofit a facade. Are we opening up a can of worms? I'm sure most of you who do facade investigations have undertaken investigation of facades and found out that what you thought was there is not what you thought. How much investigation is enough? And I can't stress enough, every time you do something to the facade, do an air tightness test, because the more tests you do, the better you can understand what you're doing to that facade. Where do warranties and responsibilities lie? And how do we get better at assessing remaining design life? So it's easy for us to go onto a building that's 25 years old and say, your glazing units are probably going to fail. Are they? Do we need to get better at just saying they might last a little bit longer than we thought? Checking glass is always a big one on a building. How do we find out their G values, their daylighting values, how much insulating gases remain in the unit? And the more we can figure out at the start of a retrofit, the better. Information is king. So what are the opportunities? Can we improve occupant comfort? Can we introduce these passive design measures like we've talked about? Can we improve the aesthetics? Can we eliminate risks that were previously present? So if we're replacing glass, maybe toughened on the outside, can we now think of reducing any inherent risks, use laminate glass? Can we increase the design life of the facade and reduce its maintenance? And can we start to consider other technologies like we discussed? So we did think, how are we going to get net zero in our building? So this is our offices in Wolverhampton, and we are net zero. We are net zero using the UK GBC definition for the years 2030 to 2035. It's a 1980s building, not a 1960s building, but we have 50 mil of insulation in the wall. It's not great. Double glazed airfill units, again, not great. 100 mil of insulation in the roof, and we've got a shocking air permeability value for 21. But we do use air source heat pumps, so that's great. So how did we become net zero, essentially? Well, all we did was we put a VCL in the roof, we changed our fluorescent lighting to LED, and we put a 60 kilowatt PV installation onto the roof. And as you can see, those three retrofits that we did are kind of on the green end of the spectrum, and the ones we kind of dismissed are, unfortunately, the fabric ones. But if we want to get to net zero by 2050, we're going to have to incorporate some of these fabric elements if we want to be net zero by that definition. So this is what we did. This is our solar insulation. The air tightness, you can see there's quite a few penetrations in the membrane. There's ducting, there's all sorts. And we only reduced the air permeability rate by a value of 4, which again, so our value went from 21 to 17, which is terrible. But it was still the most cost-effective option in terms of payback, so in terms of cost, and it was pretty minimal in terms of its disruption. Just this slide on embodied carbon. We did measure the embodied carbon of all the options, and I just want to stress that air tightness generally always comes out as the best option for embodied carbon, generally speaking. And the last slide, this is something we did on Cullinan Laboratories in Oxford. So this is the home of the UK's nuclear fusion research. I mean, if they figure it out, we can forget about net zero, right? I mean, free energy. But incidentally, they've got a 1960s facade. So what we did was we did an energy model, and we implemented some passive design measures into the facade. So we got some vertical brise fins to reduce overheating. We reduced some of the glare that was going into the building because they had an issue with that. And we incorporated some of the M&E, which was on the outside of the building, into the facade, just to make it a little bit neater. So this is where we introduced passive measures into a building envelope, but also some aesthetic and incorporating some of the M&E as well. So it's taking advantage of what's there and making it better. That's me done. I think my time's up. Thank you very much.
Stay there, Gurps. Thank you, Gurps. I have got a couple of questions for you. So you said fabric first. Yeah. Is that a myth then? Because obviously on Court's House, you didn't go after the fabric in any kind of aggressive way. You put some PV panels on the roof. So
I'm going to tell you why.
Yeah.
We were at an advantage because we had a massive south-facing roof. Mm-hmm. Imagine if you've got a high-rise building, residential, whatever, you're not going to have that luxury. So that's why I keep saying it depends. If we didn't have that luxury, we probably would have tackled the facade.
Okay.
Yeah.
And then one bigger question, which you're not going to like, but with the net zero building agenda and the UK being 1% or less than of global emissions,
right,
do you think we still need to be pursuing net zero buildings for 2050? And what are the reasons for that?
How long is a piece of string? Obviously, you should get your own house in order first. It doesn't matter what everybody else does. So that's point number one. Point number two is it's increasing our resilience almost and not reliant on anybody else if we do it ourselves. There's lots of points about this, but those are the two that I'll just keep there.
All right, so, we'll discuss further.
All right, thanks a lot. Cheers.
Cheers. Okay, and next up we've got Eric Claeys from Façade Steel, and he's going to be talking about hybrid steel curtain walls and CO2 emissions.
Good. My name is Eric. I'm the founder of the group Façade, and we are based in Belgium. We are based in Belgium, and we are what we call the system house, but not a classic system house. We only develop what I would say disruptive technologies. Innovation is nice. By the way, it is a nice buzzword. We don't believe in innovation. We believe in disruption. And the reason for this is very simple. The reason for this is very simple. When you look at the market, and the reason of our existence here is twice. What have my colleagues, competitors been doing the past 50 years? Only one thing: copying each other, and even their stupidities. All these catalogs, by the way, nobody can understand or read, are copied. And there's a second reason, and that's a concern. I did some studies about. By the way, to give you my background, I have a double civil engineering degree in construction and building physics, and I'm a master in business administration from Vlerik. And I'm 40 years in business, so I have some experience, so I can talk a bit about more philosophy. I think it's important in these times. Second reason is that the curtain wall facade contractors, they go faster bankrupt than they can start. It's almost a joke. And now we see we are present on the 5 continents. By the way, it's not only in your country. It's the same in Canada, it's the same in the US, it's the same in Australia, all over. There are lots of reasons for that. I was preparing a book on this. But you know what the main reason is? The first rule when you do a business is that you should differentiate. Differentiate. And what does the most of these players do? They compete on the market with exactly the same products. There's one big player, a German house, Belgian house, French house. They sell their stuff and let them fight amongst each other, and they have only one criterion left to compete. That's price. But I'm not going to speak about price. I'm going to speak about something else. All what we do is patented. I'm not joking. We have 800 patents. I don't like patents, but it's the only way to protect your technology. It's a pity. It costs a fortune, but it's the only way. And we don't laugh at it. When people know us, I don't know when people here know me, we had two people who tried to infringe, and they will not forget it. We have a big aluminium department, by the way. So we see, I'm here for cold rolled steel, but all our technologies, we have them in aluminium. I'm here for cold rolled steel for one specific reason, because they wanted me to talk to you about. Because this is disruptive. And why it is disruptive? Oh, that's very simple. Cold rolled steel has some features not aluminium doesn't have. They don't have the problem of the carbon footprint. It's 10 times less. The fire resistance, we have standard products which are fire resistant to hours. It's nicer, better. You can recycle it for the rest of your life. I said cold rolled steel, thermally broken, and installed from inside, without welding. No welding, And why no welding? Because you can't find people who can weld. We did it together with Montanstahl. So we have our aluminium department. Montanstahl is our steel partner, and Montanstahl is the global #1 leader of production, special steel and stainless steel profiles for applications in curtain walls. This I was trying to talk to you about, but I have to do something else. I think at my age, you see a lot. And I'm going to tell you the main challenge of our business. The huge lack of knowledge. I see it every day, the huge lack of know-how, people involved in projects. And it's not going well. It's alarming. And what is a curtain wall? That's an envelope around a building. You have a box, you put an envelope around. And the way that envelope behaves is controlled by two sides. Building physics and structural engineering. Building physics and structural engineering. I'm going to give a few topics what I see some days. I've known the time that there were, building physics means a curtain wall is hanging like a curtain on a primary structure. And that primary structure has to respect some rules. Nowadays, they don't expect it anymore. I have known the time where a primary structure was stiff. Now I see more and more primary structures, we call it primary structure, we call it lasagna. Moving like this. No idea the consequences of it. This means that people even don't know the law of Newton, the law of gravity. You know what is the law of gravity? This is a pen. When I open my hand, what's going to happen? Fall down. Some people think it's going to float. I see it every day. And this is not okay. You see it even in standards. I don't know if you know the ASTM standards from US. They have interstory movements, like this and like this. Did you ever see moving a building like this? An elevator, yes, but not a building. The building moves like this. And you have differential deformations. Now listen to me well. Why are these norms like that? Because these norm commissions are controlled by commercial organizations. And believe me, because we did all the testing. If you would do the testing, and which are representative for the real behavior of a building, 99% of the systems, 99, they would fail. 99. Due to the deformations and difference. I have some others. Sustainability. Mamma mia. What I hear daily about sustainability, it is amazing. How can you speak about sustainable buildings and glazed facades? How is this possible? I don't understand this. I'm going to explain me. Did you ever hear about the greenhouse effect? When sun is coming through the glass, and the heat is coming on the surfaces, and it's absorbing, traveling, giving off. It's per definition, even not with a double skin wall to make a sustainable facade. So that's also a topic we should think about. What people say, sorry, it is bullshit. You have to be aware. Last thing, you're engineers, it's all about money. You can all think what you want in all the stories, and I've been involved in, I think, 800 projects worldwide. It was always money. When you do something creative and innovative, it goes hand in hand. We developed a technology, not because we liked it. Everybody knows a stick. Everybody knows a unitized. The guys who developed this, I know them. You see my color of my hair? The guy who developed this is a friend of me. He's called Mr. Fenzi, he's an Italian. It was a good idea because there was some here. He had a lot of disadvantages, negative points, contest. But what he didn't consider, the long list, the huge long list here of negative points of unitized. Not to say very high material costs, astronomical transport costs. How can you speak about sustainability when you have trucks full of air? High long and pre-finance, high storage cost. Installing fast. Tell me about lead time is huge. You need months of fabrication before. So we have to combine both to develop the new technology which you can install fully from inside. Glazed from inside. All kinds of products, claddings, like for instance that these fantastic claddings, they're ceramic. You do it from inside. All of this better. Performance is uncomparable. But last but not least, much more efficient. and cost efficient. In steel, we do that in steel and in aluminium. I go over this. I think you receive this. Read your books at home. It's not my goal here to speak about this. No welding. Why no welding? Because people can't weld. You can't find them anymore. Circularity. Nice one. This I want to give you. Sustainability. 4 minutes. In a building, you have about 20% embodied carbon. 80% operational. They speak here about, all over the world, about green buildings, and they only look at these 20%. That's a discussion in the margin. That's here the big thing. There, the operational. This I explained to you. That you can reduce by steel from 20 to 2. But we have the technologies in the house to make this 80 to 0. I go further. We develop technologies where a building doesn't consume energy anymore, almost, and this is only due to your exterior skin, we call that a facade. And the building itself is one big power plant, and you don't see it from outside. So you have a huge balance in plus of energy you generate. We can market that, we are from Belgium. And now for developers, listen to me well, the revenues of these sales of electricity is higher, is more than the finance cost of my building. Did you hear me well? That's facade construction. You need to make your box, that stupid box, you have to make it a business model instead of a cost. Important, eh? That's how they solve. It's about keeping the sun out, eh? Don't think that sustainability has anything to do about winter. It's keeping the sun out. That's the main problem. We can prove this with reports, 1,000 pages. This, they do it where they have a common sense approach. That's a building here in UK, BM Gold. Let's laugh me about. I go over this. Stainless steel, we can bring the stainless steel product. By the way, our steel facade has the same weight of an aluminium. How we did it, it's our problem. And we can bring it in stainless steel and with a two-fold, an AE16, 316, alloy which has been developed to be used on offshore constructions. We give 50 years guarantee. We do it at the same price of an aluminium one. We do it on the same price of an aluminium one. Eh? Not about circularity. That's one I like. I don't know if there are investors here in the house. What is a building? A box, a grid around. A grid with infill panels. That grid lasts at least 50 years. When you have a good grid, not crap, good grid, at least 50 years. But not your infill elements. By the way, the evolution of the infill elements, the technical evolution, is enormous. We will build now for ourselves a new building, we start at the end of the year. The vision glass is PV, and you don't see it. Eh? So what do you need to have? An upgrade, 15, 16, 17, 20 years. That's renovation. We have unitized systems. You even can't. You have to take them out. Structural glazing, from the perspective of sustainability, the biggest crap on the planet. This is crap, people. Listen, this is crap. You even cannot take out the glass. If you need to renovate your building, you have to dismantle your entire building. This means anything at inside to be, it's a catastrophe. We will bring this, I don't know if there are investors in them, as a financial product to market. So we can be able to developers, let's say that you have a building, 100 million to invest, facade of 20 million, we will do, our company, the investment of that facade. 80 million for them, and this 20 million, we will lease it to him. And you can only do this when you have a top product. And we will lease the facade for 50 years. Contractual, 17, new building, 34 years, new building. Even for builders who only construct for themselves and to sell, he can sell the contract with it. About lead time, so it is spoke about. That's our Fuzzy. We will launch that little boy They make it in 3D with a little bit more belly, and he will, from now on, I think on the internet, he will explain from time to time something what we are doing. In facades, you need to think, and then you need to work. And the whole business, believe me, it will changing, and it will change fast. We will do that. Claddings, from inside, sun, all the modalities. I go fast. Grenfell, over what we concern, all over. First think, then doing. What is this? That's our small boy. And what we are looking for, maybe lasting. We don't want sales. We are not interested in sales. We are looking for partners. And partners clients with 6 features. Trust, 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 and the 6th one, a little bit of know-how. The rest we have. These people we are looking for to work on UK, and we will come. You will see us back, for sure. Thank you for your attention.
Okay, thank you, Eric. Interesting perspective. I'm a champion for aluminium myself, but next up we've got James Hind from SimpsonHaugh, partner there. He's going to talk about form, colour and texture.
Good morning. Can you hear me okay? Glad I'm following Eric. Thanks. We're going to show a lot of aluminium now. So, great segue. So, I'm James. I'm a partner at SimpsonHaugh, and I co-lead our Birmingham office. I've actually been in Birmingham now for 2 years permanently. But actually got me thinking, we've been active in this city for about 20 years. And actually, you know, the themes here with form, colour and texture probably have its roots in one of our first buildings in Birmingham, which is Holloway Circus, fully aluminium. Could take you back now 20 years, or even further. Completed in 2007, we started it obviously, you know, early 2000s, and it's a striking addition, still is a striking addition, and was at the time, to the Birmingham skyline. 120 metres tall, 220 hotel bedrooms for Radisson, SAS, 150 apartments that sat above it, penthouses at the top in a Belvedere. And it was seen as being, you know, a symbol of ambition and confidence within the city at the time. I think it still is. You know, it still looks good amongst recent development. And the form is important here. The form is really driven by its location, holding that position on the ring road, on the inner ring road. It's a really tight, congested site. And that form, that kind of perfect part of the cylinder, is driven entirely by kind of holding that junction. You can see how the hotel bedrooms at the lower levels work, and then segue into the apartments on the upper levels. And it really is a form that is driven by the plan. In terms of the elevation, this is, you know, 20 years ago, us kind of starting to play with some of the building blocks we probably take for granted now in unitized curtain wall. At the lower levels with the hotel, kind of hiding vents and openings within a curtain wall construction with perforated panels to get a seamless kind of skin, a unified surface. On the upper levels for the apartments, some slight puncturing with glass louvers. Really trying to explore the potential around curtain wall and what it brings to a kind of sculptural, strong sculptural form. And some playful elements as well. So here is the tiger print frit that we employed, and it's part of that language of unifying the overall facade. It's doing 2 very important jobs, we think. At a human scale, it's adding visual interest, not only from the outside looking in, but also from the inside. Great examples of reflections and shadows on the surfaces inside. And yet on the outside, at a building scale and at a city scale, it's forming that job of unification. And these are the as-completed building photographs. You can see this really strong sculptural form has a presence within Birmingham, still has a strong presence today, completed at the Crown by the sculptural Belvedere, offering views out to the south of the city. Playful elements at the back in the way in which we dealt with the cores, and the form, colour and expression of that building all kind of derives from the plan, exploration of the plan on site. And for us, I think looking back over this 20-year period, this is a kind of a precursor to a lot of the work that we've been doing elsewhere, particularly in Manchester. Sorry to mention the M word. But for us, I think this is a key part of the lineage of form, colour and texture. And in that 20-year period, since we completed Holloway Circus, a lot of those building blocks that we've kind of explored and a lot of the thematic expression that we've explored, we've started to play with in more detail at Great Jackson Street in Manchester. Specifically, one that I've been working on, which is Plot F. Two pictures here, 100 years apart almost. You can see in that south part of the city, 100 years ago, it's a dense network of streets, working environments, living environments, cheek by jowl, probably really unpleasant, nowhere near the kind of level of nostalgia that we think might be attributed to it. Late 20th century urban planning kind of destroyed that whole grain, gave us really a kind of a clean canvas to work with, really. And in 2007, this is the state of the whole of the Great Jackson Street area at the south edge of Manchester, really. It's car parks, surface car parks, light industrial, not actually a very pleasant place to walk through or work. It didn't stitch the city together. It was very much an outlier. In that 20-year period, since we were doing Holloway Circus, we were fully invested in this area. We did numerous master plans for various developers that kind of came and went. And then after the recession, Renneker really started to pick up some of the key sites. And we evolved this master plan through successive iterations. And at the point when I picked this up for Plot F, we were at 2018-19. We'd already completed the first phase of Deansgate Square, or the first phase of Great Jackson Street in Deansgate Square. We'd completed Crown Street, which is at the top end of the site on the left-hand side. Phase 1, we were about to complete Phase 2. And these are the kind of scale of the buildings that you can see throughout the whole of the master plan. Very much, different in character, different in quality, but some of those thematic expressions that we saw on Holloway Circus really kind of been taken through. And this is us kind of maturing through the language of unitized curtain wall. Plot F itself is a smaller plot along the edge of Great Jackson Street, really abutting Deansgate Square. It's starting to kind of stitch the two ends of the whole master plan together. It's interesting listening to Alan earlier at Howells. I think this is, again, an expression of how we work through the plan and how the plan particularly informs the form and our approach to form making. I like to call this the corner problem because really, as we've explored a number of different plan types with various developers, the corner apartments are always quite tricky to do. They're always the bits that are quite baggy at the ends. Extra space here that is great, architecturally, but maybe if you're a developer working to fairly tight margins, that's the bit of plan that you're not really getting a huge amount of value from. So we approached it in the other way. We thought, well, actually, can we tailor the plan to create something that really kind of works for the economic model and take space out? And one solution is to kind of look at corners like this, and another solution was to think about how they might actually chamfer off. And actually getting back away from a square, we knew, having done the circle, that was the 360 as part of Great Jackson Street, that is the most efficient plan type you can do. And the more you start to cut these pieces back to a purer form, the more efficient that plan shape gets. We weren't quite at the octagon level of efficiency, but we were starting to explore how those corners worked. And then we thought we could add to that by thinking about how this works with the mix. So the mix, particularly for somewhere like Manchester, is limited in terms of one beds. And we thought if we could work those corners, those chamfers, by pulling in and pulling out, creating a minimum points at wastes and maximum points, we could really start to explore something, a model that works vertically with the mix, so that we're not having to introduce any kind of transfer. Everything stacks around the core, around the key areas in the middle of the plan, it all stacks, and that only movement happens in the corners, and we can move from something that is one bed heavy at the minimum level plans to a typical plan where we've got mainly two beds, and then the maximum plan at the corners where we're using that extra width on the plan form to create the three beds. And these are a pair of buildings, so they come together either side of the site, separated by a piece of public realm. And actually, we were migrating from a master plan with 3 buildings on to a master plan with 2 buildings on, albeit going up higher. But what we're realizing there is that actually we're creating 10% extra public space, 5% extra accommodation, more separation between the buildings, and actually in terms of total number of stories built, fewer numbers of stories. So a more efficient way of building. So moving on to the envelope, actually what becomes important then once we've got the basic form is how we start to express that. Given that the corners are the most important parts of how these buildings work, we want those corners to be really celebrated. And the answer for us was to actually flip the typical kind of curtain wall, glass-faced curtain wall on its head, and look at something that was more solid, and then using the corners as the pieces of glass that really kind of express themselves. We looked at various colours. We were looking at these as a pair. We wanted them to have a distinctiveness between the two, but work together very much as a pair. Different colourway options, really. And we settled on a blue and a green. These are from Necce, Italian anodizing company. Quite a high level of subtlety, really, between those two colours. And what we're looking at here is how we can start to think about those planar faces as being predominantly solid or appear to be predominantly solid. It's the same amount of glazing that we're using on all of our buildings, really. But that idea of having a perforated rapid vent dealt with in a very different way to what we were doing with Holloway Circus. It's glass behind, so we're getting a level of daylighting and views out through there. So obviously there's impacts on how big those holes are. But it helps to give the overall appearance of something that's more solid on those sides and gives a sharp contrast to the corners. The crown then becomes a really important part of our kind of toolkit, really there, expressing those planar elements by coming up a full story. We'd have liked to have gone much higher with this, but it's then working within the constraints of stack joints and where they naturally occur, but still having that level of expression between the corners and the planar faces. And this is how it was all starting to come together for planning. These are a pair of buildings then that, because they are adjacent to Deansgate Square, work quite well in terms of material palette, but are very, very different from its neighbour. And over the course of the last 20 years, we've become really familiar with how these details work. But for us, I suppose the interesting parts are then how we deal with the abnormals and the unknowns. Inflected joints at floor levels, outwardly facing joints at floor levels, two very different kind of design profiles and systems. You know, we can't really do that in isolation, and we need input from the full team to resolve those details. And then eventually, you know, supply chain comes on board and takes them further. Different set of thinking around where joints and panelization works, particularly when you're dealing with things that actually expand outwards and then inwards. So what is the minimum part that we can go to on when we come to the tightest part of that fold, up to then where the maximum is. So, you know, it's a different way of thinking, and certainly, you know, starts to become quite interesting. And this is a really splendid VMU, really. So Focky were our design partners on this, and one VMU with 2 different facade types, one for building F1, one for building F2. F2 is actually being taken first, is halfway up now. F1 is following about 6 months behind. This is the light blue and the light green. But even in these early stage kind of mock-ups, you can see exactly how that inflected surface works. That idea of getting different levels of reflection and that contrast between the corners and the planar surfaces. And we're bringing a lot of that macro design into the kind of the detail, really. So whilst these are, simple circular holes, actually the design is that when you look up at these, you see the building form kind of echoed in the movements of the rapid vents. And as with the crown, it's equally important how we hit the ground with these buildings. So the idea of this inflected corner, actually following the geometry all the way down to the ground, is then realized in these super-scaled concrete columns, which, after a long process with Renneker, they've actually been cast in situ, which is quite incredible. They're now protected, covered up, but the full pour was near enough perfect. It's going to be fantastic. This is the first phase of the two buildings. This is F2. It's been branded as Contour. And what's great about this is you can start to see from various viewpoints around the city glimpses of the building as you pass between different parts, where that inflected corner is starting to become realized. And you get that very sharp contrast between the aluminium faces and the glass on the corner. And even to a point where you're getting sunsets reflected in the glass, and that angled face giving a very, very clear level of contrast. One Port Street, by comparison, takes a very different approach in terms of colour and texture. This is a project that's been on the books for the same amount of time, really, as Plot F, but is realised in a very different way, but still carries on those themes of colour, form and texture. It's in another part of Manchester. It's at the opposite end. It's actually at the confluence of three very kind of sensitive parts. Northern Quarter, which is over to this end here, Ancoats, which is below, Piccadilly Basin, which leads you back to Piccadilly train station here. Tricky site. We're going to have a little moment here to mourn the loss of HS2. Your gain, our loss. But it formed a very, very significant part of how that whole area of Manchester starts to think about stitching together the various zones. So it's still a material consideration. It certainly was at planning. This is Piccadilly Basin. It actually sits within the Piccadilly Basin SRF. It's Brownsfield Mill here, which is an immediate Grade 2 star listed building, since been taken on by Urban Splash and developed as Avro. Jackson's Warehouse, which is one of the few remaining warehouses linking into the canal infrastructure with the boat holes at the end here. They've since been filled in. Further out into Ancoats, you've got Royal Mills. So that's the immediate site context that this building sat in. This is the strategic regeneration framework for that area. Back in 2016, this is an area, again, like Great Jackson Street, we'd been involved with for 20 years, maybe even longer now, actually. And the site in question are those two, A and B at the top there, two separate buildings when we picked it up. A 33-storey building that actually fronted Great Ancoat Street, 20-storey building that sat behind. And whilst we had worked through that SRF, and it was very much our sort of design intent, when you come to look at individual plots in a more granular detail, you start to rethink, how they actually work. Plus you're bringing in a particular brief that starts to inform how things work anyway. So the decision was made actually to migrate away from the strict kind of positioning of the SRF and actually solidify the building into one piece that moved the mass further back from Great Ancoat Street, which is very much part of the ring road, and then front that piece with a much lower level podium. You then have the tall tower working as a local landmark in that area. It's set back from the road. You've got the opportunity to do something that edges the road to create street frontage, and then you capture everything around the site with placemaking in the middle. And that strategic move separated the building into two material responses. One, which was the tower, a unitized curtain wall response to the tower using red anodized aluminium. North and east faces very much a skin, something that's quite taut. South and west faces, same rhythm, but having a fin on getting depth, a little bit of texture coming through on those surfaces. And then the podium pieces, in contrast, working very much within the palette of the local area. Brick. But they're three pieces, so those brick pieces start to get explored in a slightly different way. Rhythm, opening sizes, gathering of windows, responding to three different faces. And moving further into the courtyard, opportunities for balconies, internal kind of loggia spaces, upper level roof terrace spaces, and a kind of a framed window arrangement to the courtyard inside. And at planning, this is how it was looking. It does look like this, very similar to this as it's being completed. On the left-hand side, you've got Great Ancoat Street and the podium buildings that kind of very much relate to the scale, the emerging scale of the buildings along Great Ancoat Street. And then as you move further into the basin, from various vantage points, you start to see the tower. Now, actually, early on, after planning, we moved slightly away from the red towards more of a darker bronze, which brings with it quite a few challenges, because then you start to look at the whole palette, all the materials together. So the brickwork that we had selected at planning, we started to reinterrogate. It's key that that needs to work with the aluminium in the first instance. So we started to have a look at all of these different kind of dark, all from red all the way down to sort of dark bronze, even some really kind of dark, kind of black finishes to get the right type. And again, another splendid VMU. And what I like about this is these photographs were all taken on the same day. So it reinforced the fact that we felt that we probably had selected the right color when it did, you know, the final selection was a dark bronze. Here you can see in this particular angle, it's quite dark. You know, you're really just starting to express the depth and the texture of the fins. And then as you move through to different viewing points, it starts to look quite bronzy, which is great. So you get this chameleonic kind of feel and texture to the material surface. The rapid vents themselves, again, you know, linking back to Holloway Circus, that idea of, you know, it's a similar set of building parts that we're working with. Here, rather than glass behind, we chose to actually do material on material. It's the same surface. And it's creating that depth and texture. That VMU was really straightforward because it's one subcontractor. This VMU was really difficult. It's about 6 different subcontractors. And I don't think there's any easy way of doing VMUs like this because you've got so many different people with hands in the mix. Brick guy, window guy, metal guy, mastic guy, probably somebody else doing some other metal work, say like the balconies and the flashings. But we're trying to control all of this and bring all these different parts together. But you're ending up with 6 different supply chains as well. So the anodizing for the windows is a different anodizing to the anodizing for the tower. So we're trying to get a close match. But that's actually UK anodizing. The tower was coaxial from Italy. And so then that whole sequence of decision-making becomes exponentially grown and quite hard to manage. Concealed fixings down the side, suddenly you're into an environment where you're dealing with smaller and smaller subcontractors who are perhaps less used to working in the way we would like to work. But we got there. The other part of maybe unintended consequences of actually making that early stage material separation between the forms is how to deal with things like weatherproofing lines. You've got a unitized curtain wall. You've got a junction with a brick piece, and you've got waterproofing and weatherproofing lines that kind of migrate in different positions relative to the geometry. Particularly difficult when dealing with a third plane, including the roof. at these points. So these are our kind of early sketches to try and understand how those particular pieces work, how they come together. Actually, the trick is it hinges on this piece of unitized curtain wall actually not being unitized curtain wall and is added in afterwards. But those kind of ideas have to be thought through with the supply chain. So this is then Focky coming up with that, that detail subsequently. And the great thing about working with material like this is once you start to then see it coming into sites, this is very early on in the installation process, but you can see there's a duality already with these facades and how they work. You get the tension of the taut skin on one side, you get the thickness and the depth of the fins on the other side, and it's the same day, it's the same photograph, and you can already see how that kind of chameleonic texture and nature of the anodizing starts to work. And the depth that you get through the texture on the rapid vents, the smooth surface, and the deeper texture on the fins, which we think ends up being really successful. Much later in the program, once the tower has almost been complete, the brickwork starts to follow. Again, another kind of, product of the process really. We're dealing with multiple different facade types and subcontractors, different installation techniques, but that idea of the texture, the grain, the rhythm, the depth, that heavyweight materiality working on the brickwork, sharp contrast with the smooth, taut skin of the facade on the tower, we really enjoy. And you get incidental reflections then, things that we didn't think about, that light bouncing off the tower and that reflectivity hitting then the surfaces of the brickwork. And the tower is actually now complete. The building will complete at the end of the year, maybe December, January, when it will be open. But you can start to see exactly how all of that starts to come together, particularly in the tower. So the fins on the left-hand side, again, that sharp contrast with the surface on the other corner of the tower as you turn around. And that's me. Thank you very much. I think I'm ahead of time.
Okay, James, just while we're setting up for the next panel discussion.
You didn't tell me about this bit.
Oh, I've got a couple of questions. But it's one of the common kind of building blocks that you use on your high-rise residential is the rapid vent.
Yes.
Can you explain a little bit why you tend to use the rapid vent for ventilation openings?
I think the main part is so we don't have anything falling out of the building. I mean, at certain heights, particularly when we're dealing with, the heights that we're going to now, 70 stories potentially, it just becomes really impossible to open a window at those kind of heights. 30 stories, you could probably, do a window opening. But I think there's, multiple decision-making processes there. The first one is, making sure that we don't have things falling out of buildings. Mm-hmm. So you are then dealing with smaller holes that you really would struggle to throw something out of. Maybe a small chihuahua, but that's about it. But I think it does come back to this idea of how we want to think about these buildings. And for us, it's very much a kind of a sculptural form. And in the right setting, an opening window works. But 9 times out of 10, we're thinking about this surface as being something that's kind of unified and homogeneous. And so the rapid vent is a device that allows us to really kind of work with that and explore, different textural patterns and different bits of visual interest that you don't necessarily get from a window.
Yeah. And you get that full floor-to-ceiling glazing. You don't interrupt it with a transom.
You get that full floor-to-ceiling glazing, exactly. Yeah. So you get a window that is just from floor to top, which I think, is part of our kind of design language and has been part of our design language for 20 years. And then adjacent to that, you've got a rapid vent, which, in some instances could sit above the floor, and you've got a transom behind there, so it's hiding all of that, technical delivery.
Okay, yeah. Okay, thanks a lot, James.
You're very welcome. Thank you very much.
Right, now we've come to the part you've probably been most eagerly awaiting, and that's a panel discussion with myself, David and Mohammed. We don't have Daphne, unfortunately, she's stuck in Tokyo. So guys, if you'd like to come up, we're going to have a short presentation just to introduce a little bit about AI and the way it's used and the tools we have, and then we'll have a panel discussion. So, okay, thank you. Okay, so today we've got myself, Associate Ramboll in Façades, and we've got Mohammed. He's our expert data scientist, and he'll tell you what he's been doing at Ramboll. And we've also got David Brooks, who's a studio lead at Bonbrian. Okay, and yeah, so you can go through it. Okay. Should show my good side now. Thank you. All right, over to you, Mohammed.
All right. So, hello everyone. This is Mohammed. I'm from Ramboll. Work as a data science lead in there. So, whatever building could design itself. Just imagine that you design 3 or 4 sketches of a building, and in your sketchbook, and you were in the office, just realized that the time is late, so you put the sketchbook in the office and went home. Then overnight, these buildings, these sketches started to go organically. They started to mate and mutate, and their offspring started to come up like better than their parents. And this cycle's repeated and repeat till you come in the next day, you find very nice new designs that you never come up with. This is not a dream. This is a reality even before the hype of ChatGPT, and it's called natural-inspired AI. And the one that I explained is called genetic algorithm, so it's inspired by how the like people and like creatures move from one generation to another, and with every iteration they got like more fit and better. But this is not the only flavor of nature-based AI. We have base colonies, we have ant colonies, we have like swarm intelligence as well. So it's a very rich area. And just to give you like a sense of how this works in the real life, so this is the tool that we first developed in Ramboll. It was an in-house tool. The engineers just roughly put the buildings where they wanted them to be, just the heights, and then it started to generate and optimize based on a set of criteria and some constraints. And all of these are just generations that they are getting better and better. This tool is then sold to View City to be scaled. And then the engineers can take it, draw and tweak and enhance it further. So it's not like a full automated tool, but it's a very good start. So next time you hear that the AI is a way that computers mimicking a human intelligence, you can shout, well, not only human intelligence, we have other non-human intelligence as well. So if like nature-inspired AI can solve design problems, what else can AI do? And this is where we move from nature to neural, when we looked at our brains and got inspired by how these neural networks are working. And this is where the artificial neural network came into dominating the like AI domain. So now we can see all the large language model, the things like ChatGPT, they can have a conversation with you, they can generate images for you and create ideas for you. And these technologies move very fast. Like as you can see, this is a prompt that we have 3 leaders, 2 women and 1 man. And in early 2022, the technology wasn't like up to standard. So we all laughed at this technology by then. But when we look like a year later in 2023 in May, I think the image is more realistic. So these things move fast and we need to move fast as well. So this is why in Ramboll we developed something called RamGPT, which is similar to ChatGPT, but it's specialized for Ramboll. And it's used the Azure OpenAI large language model, which is like everything that we write in these chat models kept within our environment, so they are not shared with the OpenAI. And like the employee can generate code, create images, like access the web as well. And it's hooked into the Ramboll's databases. So People can ask questions about a project, when it's gonna end, what is the left of the budget, and all of that things. So the facade engineers used it as well for ideation, interrogating long documents, as well as building like code boilerplates for Grasshopper. And speaking about Grasshopper, this is one of the parametric tools that we built as well in Ramboll. It's not AI, but the code behind it was like refined using the RAM GPT technology. But what if these chatbots are not only talking to you, confined to these large language models and this chat, but we have different large language models, they can talk to each other. And this is what we call agentic AI. Agentic AI is, they say the 2025 is the year of agentic AI. And each one of these not only can talk to each other and delegate tasks to each other, but they can interact with the outer world. So they can book a flight, or they can organize their calendar, all of that by giving them one goal, and they can figure things out by themselves. This is a very hot and fresh area, so it's not in production yet. And the like the examples that in production is not up to standard, but it's the way of 2025, I believe. And that's me, to David.
Great, thank you very much. Right then, it's easy to start these things and go once upon a time, and that's probably a nice thing to do with a story. Once upon a time, there was lots and lots of drawing workshops, and the pen, the pencil, the rubber, and these old-fashioned rotary pens were kind of everywhere. That's where a lot of architects started. And standing here today, we've come an absolute remarkable long way in a short period of time. I think my first year at university in Manchester, there were skipfuls of drawing boards, just people weren't having that lesson, that kind of tutoring that happened. And CAD and 2D AutoCAD and other drawing softwares were started to be talked about. It's still used today, but again, we've come into 3D element of work with BIM, 3D modeling, goggles, VR stuff, and we are on that kind of beginning journey of the AI. It's been around for a long, long time, but it is just starting to sneak into the profession and be used. Universities are talking about it. It is massive in universities for exams, whether it's written or the visual side of it that us architects do. Few images. The middle image is a picture of me trying to code and look at AI and put in a code. There's a problem with that. I'm holding a pencil in my left hand. I'm left-handed. There's limitations with AI because of the technology and where it's sourcing images from. Most people in the population are right-handed. It's very, very difficult to get someone holding a pen or pencil left-hand generated with AI. Try it. Another limitation is clocks and time. There's a favourite time that is advertised. So just be careful with the limitations on AI. Also be careful with the limitations on when you're hiring people. I have been caught out with recruiting people where they have blatantly used false information, false images, and using AI caught me out. So there's a big question at the moment. Is it cheating, or is it just using that latest technology that we've got at our hands? Something we talk about. A very, very blurry image. But this was graffiti. I was tutoring at Manchester School of Architecture. This is graffiti I found. It stuck with me for a long, long time. I think it was probably a Nokia phone looking at the image of that quality to show how old it is. But I think it's always important to remember about education and how much kind of debt students get into. But with technology, I've got to ask that question. With images that are getting produced with AI, graphic design is really, really a question to kind of have because people can get cheap images quicker and fast. Moving on to a bit of architecture. So credit to BDP. They have been working at the University of Warwick for a very, very long time on a variety of different schemes. This is the STEM project. The reason I'm talking about this one here is we have been successful with Kia, and we're going contractor side as Bond Bryan Architects to deliver this scheme. So BDP is staying client side. This is a project that's been looked at for a while. It's great to see some of the conversations about all the different systems, whether it's glazing earlier. The pen is still around. We are still sketching. We are still scribbling. It's important to say the famous saying is the pen is mightier than the sword. I would kind of take that into where we are with AI and technology. AI is happening at such a speed, it was probably going to be more powerful than both computers, CAD design, pens, and everything else. A great scheme that we are looking at moving forward. It was a competition that we were working with Kia against other contractors. So we part of that process between September and December last year. We stumbled across AI, we used it, we've been using it in-house. We've got our own in-house guru that's pushing the boundaries with it. We asked the question, we use this, when we are architects and designing things, what we want to be doing is making sure that we're designing not just for practical completion, but what does the building look like in 60 years' time. So we've been typing looks of things. You can see the trees are taller, higher, a little bit older. They don't look like trees. Trees don't normally grow like that. There's been a few drones and there's a few things, but it was fascinating. And the thought of what we're trying to do is present a scheme is for that buildability, but also weathering and making sure, for example, there's no nesting birds, there's all that kind of stuff that we can look at. This one's a little bit extreme. This one's a little bit like kind of Skynet and Terminator, and we didn't use this one in this presentation. I think it was a step too far, but I hope you can see it's a powerful tool, it's useful, and I encourage you to use it if you haven't used it, and take it forward. It's not just all AI, the pen's powerful, 3D printing's powerful. Again, just another image. Go and have some fun with it. If you've got any kids, any grandkids, any graduates, allow them to have those tools. Type anything in, it's free. It's a fantastic tool. I talked about stealing earlier. Another famous quote, bad artist copy, good artist steal. There's a question, we can have a debate afterwards. Is it stealing? Where all this information coming from with AI, it's stuff that's been designed, it's stuff that's on servers, it's stuff that's it's not forward thinking. I'll leave it with that. I guess without sounding like the Terminator, okay, hasta la vista, and we'll start the conversation.
Yeah, take a seat.
Do you need this?
Just drop that there.
Thank you.
Okay, we'll kick off with yourself, David. I mean, within these large language models, we're obviously feeding lots of information in, and we can control that to a certain degree. In terms of design bias, how do we account for that, and is it something that we do want to control in a very careful way?
I think with the control, it's got to come with the control of the designer. Someone's checking things, someone's looking at it. The design bias is what we talked about and what we've heard about before. It's great. There's other examples from Simpsons where the bias has got to start really with the site and the local conditions and whether it's a corner plot. So I think the bias is never really generated by a machine. It's got to be derived by something else, and that's something, whether it's a client's brief or more importantly, the design that can help with materiality, whether it's the red bricks of Manchester or other kind of materials that might be of that vernacular.
Yeah, so we're saying we've got to feed in perhaps those specific building blocks that your practice is keen on exploring. Say for SimpsonHaugh, it's a rapid vent, or for yourselves looking at it over time. Yes. And that materiality.
Yeah.
Yeah. Okay. I mean, after that, we don't really want to have a stagnation in the design approach. We want to keep moving it forward, and that's one of my major concerns. So how do we? He says the bots can start talking to each other. We can widen it open. So how are we approaching that within RAM GPT so that we can control it and manipulate it effectively on this larger scale? Because it seems to me that it could easily get out of control, that we don't actually know what information's within it and how we're getting the outputs we are because of that level of complexity.
Absolutely. So when we talk about biases in AI, we are not talking about just a bug. We are talking about something like way deeper than that. And probably it's a little bit challenging to tackle such a problem because the main first reason that we are not aware of it, and the people who use the AI, sometimes they are not aware of it, but probably the other reason is that the biases manifest themselves in every single stage of the development process. So it could be from the data itself, it could be from the model itself, or it could be from the data scientist or the developer that developed this tools, like unintentionally. And probably the sad truth about bias is that AI doesn't generate bias, AI repeats bias. So if we see that bias is in AI, it probably abides from ourselves as well because it learns what we do, what we share on the internet and in books and all of that. So in RamGPT, we had like 3 tactics in order to tackle this. The first one was raising awareness. So we always tell people who use RamGPT, do not use RamGPT for things that are not fit for RamGPT. So for example, you can't use it for screening like CVs, you can't use it for analyzing emotions or promotion or all of that. All of these should be like an intention decision by the decision maker. So that's the first one. The second one is a prompt engineering. So, and you can try it actually. If you go to ChatGPT and just ask it, tell me more about the health system in country X. It will give you an answer, but it might be a little bit biased, especially if you compare it with a prompt like, give me a well-balanced view about the healthcare system in country X and compare it to other countries around it and cite your references. In this way, the way you frame the question will definitely reduce biases a bit.
Okay.
The last tactic was the feedback loop. So we make it very easy for users who use RamGPT to report to the developers that there is issue with the response, and that then can be modified. And in the coding perspective, there is something called system message. I don't want to get into technicalities, but it's just it's a guardrail what AI can do, what it can't. So there is a very long list, like for example, don't help with self-harm, for example, or don't help with something is illegal and so on. There's a very long list. But these shouldn't be taken for granted as a methodology that is foolproof. No, I think biases in AI is more like cybersecurity. You can't just rely on an antivirus and that's it. You need to raise awareness for everybody in the organization that using AI.
Okay. And then, I mean, just touching on something about, you said about copyright and recognition of who's producing what. Do you think that's a major risk of AI, that it's going to infringe on a lot of copyright?
I think it started. It's definitely started. Yeah. The legal teams will be all over this, and whether we start to see it in the music, we start to see it in Hollywood, so in the construction world and professions we're all in, it will definitely be there. Robots, AI, it's great, but you can't blame it. You can't blame it. The reality is, most consultants need insurance, will need insurance for a long, long time, because the risk's always going to be there. Someone's got to check constantly the robots, haven't they? You might get 80% of it there, you might use it as a tool, but ultimately, someone's got to be the author of that drawing, model, whatever it is. So I think it's interesting times, and it's very, very difficult to prove the source of that image, isn't it? It's not like you go to a library, you've got a president, you've got a bit of history. architecture and design can be quite simple. We've been doing it for hundreds of thousands of years. Walls keeping the sun out, from the examples of the mud huts to the kind of these big glass boxes that we've got now. We want to keep the rain out. We want to keep the sun out as much as we can with daylight and overheating and things. So it's this balancing act.
Yeah, so, I mean, we've had a lot of parametric tools around for a long time. And the question I get asked is, right, can we increase the complexity on the facade design? Can we optimize for cooling variables, heating variables? And through Fat Panda, we can do a lot of those things. But at the end of the day, a few gentlemen in there and companies, and they'll be thinking, right, how do you actually build for, this curved panels and this sort of complexity?
Curves and complexities are expensive, but bring it back simply about a level of complexity. Whether a facade's got double glazing, triple glazing, I think the wall thicknesses, we're at a kind of a limitation of what we can do with the facade with regards to the building physics that we talked about. Nobody talks about quadruple glazing. There's a reason for that, isn't there?
Yeah.
It's expensive. You become a level of threshold with all the passive house stuff. The facade can get to a certain thickness, but without a real radical change in the science and someone inventing a new material that kind of changes U values to an, like this nanogel and all. There's a limitation of what we can do, I think, with the current technology that we've got. And AI certainly isn't going to do that on a kind of a concept stage or taking something from, I don't know, 300 mil to 250 or, there's a limit
to stay the same.
There's a constraints that we've got at the moment that I think gives us all that purpose to be innovative, to kind of, the other slide earlier about, the extremes of sticks to the kind of, it's the hybrid stuff. It's using all these things together to come up with something a little bit more innovative and push the boundaries a little bit more that we've got. I think it's somewhere where we should be targeting, rather than sitting here thinking in 10 years' time, we won't be needing so many consultants. We won't be needing kind of the thermal model because it's all automatic. I just don't visualize that at the moment.
Yeah, perhaps we've made things very complicated, and this is a route to make things a bit simpler. So we might
efficiencies.
We won't need as many SAP modelling engineers. Yes. Yeah. Sorry if there's any in the crowd. But yeah, if we move on to employment, because that's, I'm sure a lot of us see a lot of headlines. I mean, are most jobs going to go towards an AI? And you'll basically just have data scientists like Mohammed programming it all. But I mean, what's your thoughts on jobs within the industry? Are you seeing a change already towards a migration towards more data science rather than engineering roles?
I think so a bit, but it's probably because of the hype of it more than anything else. So I remember. Like maybe 10 years ago, it was data scientist, and then now data science is no longer the hottest job out there. Now data engineers, and then data engineers faded away, and then AI engineer and so on. So I think it depends on what is circulating in the media that affects what people go. But to be honest, you can't plan more than 5 years now about things. Things are moving very fast, and probably the only thing that we can put our hopes in to the resilience of the humans, just to learn more and to be adaptable more than anything else.
Yeah, because I see things have got more complicated as time's gone on. We've had more consultants, we've had more specialisms. So with all the extra modeling capabilities and data, we've actually created more roles. I mean, you mentioned about the liability aspect, which is quite interesting. So is that almost a saving grace that you just can't rely on, you can't sue AI?
Absolutely.
So the liability's got to rest with somebody, and that sort of yeah, that's going to be a
It's with all
practice zone.
It's with all the designers, isn't it?
Yeah.
It's something that will be there for a long time. I think someone else mentioned it earlier in one of the presentations. There's a skills gap. You know, they're talking about the steel curtain wall. The tradespeople, and this isn't just like a local, regional thing. This is probably going definitely national and international. The welders are missing, the bricklayers are missing. There's a skills gap in the construction industry that is here to stay. AI and robots aren't going to change that. MMC will change that, off-site manufacturing will change that, but there's an element of people using and latching on things to kind of scaremonger these things a little bit. The basic skills gap with maybe someone, that example I was talking about, internal emails, external emails, the spelling and grammar was atrocious. It was almost like a text message, and the conversation came about is that students have got a lack of knowledge of how buildings go together. They've also got a lack of knowledge where they're not fit for purpose sometimes, and some of that is COVID. We're still suffering from that. They can use AI, it's a tool, but I think just be cautious. I will still recruit, I will still help all these graduates and students that need it, but there's a level of upskilling that most businesses need to do to bring them up to speed. And AI is a tool, but it's not the solution for everything, and that's the bit I'd say.
Yeah, because you mentioned, during the interview they used AI and they used these tools to get through the interview. Is that allowed or not? It's a bit like having a calculator and checking your arithmetic.
Correct.
You can always get hold of a calculator, so maybe you don't need to know 4 times 8 or 5 times 9 off the top of your head. I just wonder, we're now at a point where we've got to be really good at demonstrating our competency with the BSA and getting onto the various registers. How do we navigate that?
You got to have checks and balances. You got to have systems in place. There's some really, really clever software that can do the face recognition stuff. You can have filters on your face. You can go onto videos. There can be automated, automated text that if it's a Zoom or a Teams interview, there's a level of risk that you kind of really don't know what you're up against sometimes, and that element probably just needs looking at for most businesses.
Yeah, and then in terms of, if I see a lot of the younger graduates, engineers, just going straight into RamGPT and asking, right, what are the loads for barriers, and it chucks it out. And it will just chuck out the standard residential load case, whereas it may be a restaurant or an overcrowding load. And it's really difficult for them. I'd always say, right, go back to the standards and read every single standard. So how do you think we get these tools to get them to not just use RamGPT, but get deeper into the learning and understanding? Because otherwise, if they don't get to that level, then there'll be nobody writing the future standards or be developing new codes and updating things. So have you guys thought about that risk?
Absolutely. I don't want to scare people, but I think if we didn't get the intention action to prevent this, I think this is the default where we are going. And we've seen it in a couple of things. You just mentioned the calculator. You just mentioned the spelling checker. We are way less capable of mental arithmetic than our parents are.
Yeah.
So why? Because we use them. The GPS, for example, without a GPS, I wouldn't be able to reach here. Actually, I've lost my.
Yeah.
So I think we need to make sure that we have the intention to learn, and there are solutions for this. For example, for organizations, they need to prioritize learning and allocate time for that, and sharing knowledge as well, because you won't be able to demonstrate that you've learned unless you shared it with your colleagues. And for individuals, you need as well to use these tools as a coach, not as a genie that gives you the answers at the end.
Yeah, we need to embrace it, but we've all got
Exactly.
responsibility, and I think that's where our responsibility lies, to keep the education going. So, you know, the first architect I ever worked for is in his early 80s. He's sort of a coach and mentor. He was there talking to me about brick dimensions and the basic level of construction. We've all got that, you know, our level of expertise. We've all got that care and duty to make sure we're upskilling the next generation. So there is an interest, there is an appetite. The British standards and all the other documents do get updated, and we embrace it. We have to. Otherwise, it'll take us over.
Okay, that's great. I think we'll wrap it up. Maybe just my final question is: should we be saying please and thank you to RAM GPT? Because it does use a lot of energy every time we prompt it.
Well, I think this question is harder than you think. The short answer is yes.
With all that extra energy, just
yes,
by,
definitely. But there are arguments about it. So on one side, that these things use energy, yes, and they cost money. But on the other type of argument that these models learn from us, from how we interact with them. So if we treated them like in a rude manner, they might learn that from us. And we don't want that. And the second thing, even that they are like not capable or not human or just AI, but just picture, I would picture my daughter, for example, if she was screaming at her doll. That's behavior I don't want. I want her to treat everybody, even her doll, like in a good manner, because that will be a habit. And for me, yes, I say please and thank you, and with a bit of extra of cost, but I will feel more comfortable with that. Okay. Cool. People might agree, might disagree.
Yeah, why not? It doesn't cost anything apart from the energy that you're kind of really talking about. But it's setting the scene, isn't it? It's setting the scene of what response do you want back?
Yeah. Okay.
Brilliant. Thank you.
All right. Thank you very much, guys. Give a round of applause for our panel. Okay, we can break for lunch now, and we will be back. Okay, David's here now. We can start. Okay, so session 3. Great list of presentations. First up, we've got Adam Graham from Broadway Malyan, who we're talking about Bioma Tower, imprinting on urban memory. Over to you.
Yeah, afternoon, everybody. It looks like it's my job to wake everybody up, I think, after lunch. So I'll try and keep it as entertaining as possible. Dancing to a minimum, though. Dancing to a minimum. So yeah, today I'll be talking about Bioma Tower, imprinting on an urban memory. There's a couple of themes that I'm going to look at, predominantly the delivery side of it, and the optimization efficiencies we went through with the principal contractor, but also that collaborative process we went through with the local authority as well as a consequence. But if you just bear with me, what I'd like to do is I'd just like to go through a bit of a background, a very brief and quick background of where the site is, actually, because that's super important, and it's something that a number of speakers have touched on today, and it's the location and setting of the site is essential in that design narrative, and that thing that we can really hang our design on and then look to develop through all stages of the design. So it holds a key position on the edge, St. Martin's Square, the edge of the city proper, if you like, and then Digbeth. It's a 30-storey tower, and it's called the Bioma Quarter, which I'll come on to in a moment. So long history on this site. Back in 2009, there was a plan approval for all 3 phases. The Bioma Tower itself is phase 2 of the 3 phases. The first phase was a hotel and the redevelopment of the cold store, repurposing of the cold store. And then 2014-15, Broadway Malyan picked up the design to submit to planning again that reflected both a change in client, change in owner, but also a change in the market. And we kind of fast forward to 2020 when we undertook the detailed design stages. So if you just bear that in mind, you bear the location in mind, you bear that chronology in mind, we then look at how that 2009 application came into being and the design guidance that was used to develop that design. So what's important to remember is our site obviously is helpfully in red. Apologies for the tiny, tiny map, but the point of this is you have what tall buildings were designed back then. We had a detailed guide of parameters called the High Places Plan in 2000, was adopted in 2003, and essentially tall buildings were placed along what was known as the Birmingham Ridge. If anything wasn't placed along there, it had to be exceptional. It also couldn't be in a conservation area or next to listed buildings. So if you bear in mind what we just looked at previously, if I just quickly go back, our site was outside of that ridge, which was over here on the map, and we are next to 2 listed buildings and in a conservation area. So how did we get, or how did the previous architect Trevor Horn get the consent? How did it get through planning when we had so many constraints? Simply, it was the power of a concept, and the power of this concept lay in understanding the real etymology of not just the name and where the bioma came into being, but actually going as far back as the geological past, understanding where bioma itself came from. Now, it's widely considered that the Biorma Quarter and the site itself is actually the original settlement of Birmingham. Like most settlements, this was because there was a ready supply of water, and this was dictated by the geology. I don't know if we have any geoengineers in here that could attest this, but simply you had the impermeable mudstone, the sandstone strata that forced water up. So as history dictates, the settlement establishes itself, gets bigger. The Biorma name itself came about from that people, that group of people. We then move on quickly, rapid period of growth through the Anglo-Saxon times where landlords, again, money, it's interesting, we mentioned it before in one of the previous presentations, is that money dictates a lot of things. So during the Anglo-Saxons time, landlords wanted to obviously incentivize and increase rents, so they started to divide up plots for tenancies. These tenancies were known as burgage plots, and these typically manifested themselves as long strips of individual plots that individuals rented. Now, again, so Biorma, the original seat of settlement in Birmingham, is also one of the last remaining places in the city where these burgage plots are actually still visible. So with that in mind, the prominence of the site, a very clear understanding of where and how this site came into being, those combined were the key to unlocking this site, and were the key to unlocking this site in terms of planning, because it was considered exceptional circumstances. And then, as you can see, the previous iteration, again, it was looking at taking these burgage plots and making them empiric to the design. So it was from both a layout perspective and the structural principles as well of the original design. And then I'll come on to in a bit more detail in the presentation of how that then linked into the facade design and materiality as well. So fast forward, 2014-2015, Broadway and Malyan were appointed to resubmit to planning to reflect the changing market, changing brief requirements as well of the changing client. And simply, we just needed to maintain the key principles because the concept was fantastic. We didn't feel it was appropriate to review this or change this. So we looked at it very much from an optimization perspective. How can we tell that story more clearly without going into greater detail? There are obviously efficiencies in the plan that we could look to develop. There was also the changing uses as well, which again I'll come on to in a bit more detail as we go through the presentation, but essentially we had to reflect the change of uses in a tall building, which is quite difficult. I won't read through all the key points there and of kind of the details of the mix, but needless to say we had a lot to get into a a relatively small footprint, so the way to do that was to go up. And with that in mind, at the beginning, in 2009, it would have probably been the first, or one of the first tallest, the tallest building in Birmingham, just because of the program and what happened. You know, there were a couple of things. COVID is one. It just didn't quite pan out, but you know, obviously, we think it was one of the catalysts of tall buildings in Birmingham. And then, so how did we take this forward? Well, the consented scheme was quite busy. I think in terms of the massing, we had a change in use, or certainly we had to look at increasing certain use types, and that was particularly the commercial element. So how did we reflect that whilst maintaining the burgage plots, you know, which was empiric to that design? So very, you know, they're very strong. If I just point you in the direction of this plan over here in the top right, that very clearly illustrates what was before in red, and we tried to include where all the steps and step backs and change in massing occurred. How do we then bring that back in down into a footprint and just give a real clarity in design, clarity in footprint as well? And it was all about simplifying the diagram. And again, as I said before, very simple strategy with the uses. We wanted retail, some sort of activation at ground. This then transitioned into commercial. The commercial then stepped back at level 10 and 11, so it created terraces. We then step back again, and it goes into the residential component. Now, this principle in design and in that scaling also then reflected in the material of the buildings, which I'll come on to now. Again, this is just sort of telling you a bit more detail on the retail and the uses, but as you can see, it very clearly steps in those changing uses, and then you have a number of penthouse apartments at the very top of the building. Now, I touched on the appearance and composition and how that reflected the use. We obviously wanted something very solid at ground at the retail part of the building. You know, this is the area that people, pedestrians, would interact with the building. It was something that was very much seen as solid, reflective of the sandstone strata that I touched on previously. And then as you work your way up the building, it wanted to become lighter, wanted to become aspirational, if you like, where the living accommodation is and was. So if you just bear that in mind as well, kind of the composition, so we're going from heavy to light. So again, fast forward a little bit, and where we can get into a bit more of the nitty-gritty of the delivery. We then tendered the scheme, and JRL Midgards were appointed, were awarded the contract, and then very early on we worked with them to refine and optimize our stage 3 design, if you like. And this was very much a collaborative approach. Collaborative both with clients, contractor, and also the local authority. Because as we all know in this room, what you have consented and what you deliver is likely to be different, or certainly there'll be changes, and it's how we mitigate that risk, but also not lose sight of that overriding concept. So there was quite a long period of managing those stakeholders. So how did that manifest itself? Well, in the appearance, and it's kind of typically what we're going to concentrate on now on the facade, and it's something that we actually touched on when we were discussing previously, is it's the first thing that you come into contact with, or certainly tall buildings, not only from a great distance away, but that individual at the ground floor, it's super important. So one of the key principles of planning was it was a solid surface, solid material, stone. That didn't change. That was something that we worked closely with Midgard to retain. But understandably, when it came to the podium and it came to the GRC element, which we had proposed in our tender documentation, that's where we felt that there was a real opportunity to optimize that design. So how would we continue that appearance of stone, that kind of faceted approach that we had developed as well, to give it that solidity, that illusion of a solid material rising up through the building? How and where do we look at the kind of those critical junctions? So there are a couple of things that we looked at, and the first one was actually to omit the GRC and replace with aluminium. So at this time we're talking closely and working closely with our colleagues at the local authority to say, you know, look, there's a number of reasons why we've looked to change this, but primarily we don't think that overriding concept. You still have the burgage plot lines going through the building. We still have that faceted, that kind of animation to the profile of the building and of the facade. That's all retained. That's all fantastic. However, we have made it easier to deliver. We've managed to unitize the facade which also saves us time, program time, and allows us, which I think was probably the most important point with the local authority, we managed to maintain the quality, albeit there was a couple more, there were a few more lines that came into the elevation compared to the GRC element, but principally the order and rhythm of the elevation didn't change. You know, you're talking about you know, the millimeter gaps between panels. And so with it being a modern method of construction, we were able to maintain quality and control of those interfaces. There's a bit of fun and games with the slab edge and that level of coordination. That was not a challenge, but I'll come on to why and how that was easily managed. I felt easily managed and mitigated throughout that process. So, well, essentially, the proposed cladding then sat clear of the column edge. So that was deemed a win. But another kind of important point that I wanted to touch on was these winter gardens, and they were challenging, I think, would be a fair assessment. Difficult to make, to coordinate with the drainage. Apologies to any MEP engineers in here, but you know, there was basically no space for services, so they were pulling their hair out, understandably so. So we looked at how we could optimize that solution. The tendered solution was it was a continuous slab. We all know that it's a nightmare to weather that. How do we weather that? How do we continue a weather-tight seal? So very early on, the principal contractor actually suggested we use that as a completely separate precast element. So again, that enables us to control quality, but it also helped us to really thin down that slab. So we're creating efficiencies in material costs there, cost saving, but also in terms of sequencing, we were able to cache channels in for the post-tension connections as well. So that again was all deemed positive. And then actually now during the construction phases, Midgard have actually managed to develop the design in such a way that we've been able to omit any drainage and rainwater goods to those winter gardens. So again, another example of how we've really optimized, or certainly how now Midgard, as they're in the throes of construction, have optimized the design. I couldn't not show how then we optimized the plan, particularly in light of what happened in Grenfell. With Grenfell, the client, but everybody within the design team, client, local authority, everyone associated with the project saw the value, understood the value of going back and putting in the additional escape stair, with only the loss of 12 square meters of NIA per floor. So that again was just an example again of the kind of collaborative approach that we took. So talking about the local authority, such a period of time had passed that they felt that the colour, that was a good way of putting it, they felt that the colour wasn't representative of the aspiration, or where Birmingham saw themselves in terms of the colour palette. So I'd already previously talked about the idea of solid material, solid surface, stone. That changed, and we developed that with the local authority. So in this view, you can see we've gone from sort of light, you can sort of see we've gone from light to dark. We've gone through, and then we actually really liked kind of the darker one that really did set the contrast, but the local authority sort of chose this one for the lower podium level, just because they felt it was more in keeping with the aspirations. Similarly, at ground floor level, we had originally proposed a beautiful rusticated sandstone. We changed, and that was changed to a Mangolan granite with just a simple water jet finish, which looks well. But does that link to the burgage plots, that idea of sandstone, and perhaps not. But again, that was just an example of when you go through that collaborative process, sometimes you've got to take the wins, you've got to take some wins and accept others, accept losses on others. And then just some construction photos that really illustrate particularly the podium level, and that change of GRC to the aluminium profile cladding, which, from a distance and certainly with the sun shining on it, it has that sharpness, that quality, that solidity that we were really striving for. Whilst it's not the GRC sort of colour, it looks well. And actually tomorrow, we structurally top out for this, so we will have topped out as of tomorrow, and then obviously it'll sequence as we go through. So facing the future, I just wanted to use Bjorma as a bit of a sort of segue, I hate the words, but segue into sort of what are we doing and how we see the evolution of Birmingham tall building design. And this is just something that was quite nice. There's been quite a nice image that illustrates that point, how quickly it has developed over quite a short period of time and how it continues to do so. And how does it continue to do that? Well, again, I've said you'll have that word ringing in your ears, is collaboration. And the softwares to do that. It was invaluable, the BIM environment in which we were working with the wider design team, and then when we came into the delivery of the projects, and particularly when we were looking at those interfaces, we had very tight programs to work to. It undoubtedly unlocked that design sequence, and I can't talk about sort of the digital collaborative environment if I don't talk about AI. Obviously, before lunch, colleagues had touched on it. And what I find quite interesting is, again, from my point of view as an architect, I think it's a fantastic tool that we should be leveraging, but it is just that. It's a tool in my mind. It will never sort of take away that human sort of quality, that human input. I was chatting to someone before during lunch where it's that painterly quality, but that's probably just the romantic in me, perhaps, who thinks you'll never remove that. But interestingly, I did this whole page was actually done using AI. I just thought it was quite an interesting talking point. AI thought it fit to give itself an extra finger. So I think, it's, again, not without its limitations, but even sort of setting out and looking at the page layouts, it's not bad, it's quick, and it gets something out that you can talk to. So, as I say, we very much use it as a tool. So what I'd like to do is now just talk about how we then use that tool and how we have used that tool in more recent projects, the most recent being the Narrow House in Birmingham, which is fairly fresh to the press. And again, it's a very constrained site. It's a very historic site. It's a contextually rich site as well. It's only 8 meters wide, so it is a funder's nightmare when they look at it on paper. So we had to look at some sort of clever ways of unlocking it. 2 of those were, so there was 2 strands to it. It was, do we look at sort of an innovative use class? So we started looking at co-live, but also do we look at how we can leverage kind of those environmental components, credentials, how can we take it further, and how can we ideate that quickly within the constraints of a client's program, which are, as we all know, usually tighter than they first lead you to believe. So we went through that ideation. We very quickly came up with we'd like to use or completely drape the thing in photovoltaic panels. We got in touch with providers, manufacturers. Really, AI enabled us to do that piece of work quickly, because in the background we were sort of rapidly prototyping. We were going through. We were testing, the panel size, orientation, how many, what degree it goes in and out. We did that all very quickly. That then arrived at this building where we were then also able to propose other elements of environmentally considered design features. So, it was stacked with B blocks. We recycled the brick, particularly the engineering brick from the existing warehouse. And needless to say, we really leveraged the environmental credentials of the facade, particularly as the site itself. I should have mentioned this earlier. Actually, it was one of the first, if not the first street in Birmingham to be fully gaslit. So again, it's at the forefront of that kind of technology. And it does look to pump more energy back into the grid than it actually uses. We've even, at very high level now, because this is actually in planning at the moment, we've actually looked to talk with other providers, suppliers, of how we can provide electricity for community groups, etc. So, yeah, lots of positive things in Birmingham, and genuinely Birmingham I do see as one of those forward-thinking cities as well. You know, again, go back to that word collaboration, it'll be ringing in your ears, but the local authority were all over this, very collaborative in the process, really wanted us to push it. I think at one point, I mean, most people here will probably know Simon Delahunty Forest, you know, he was thinking, what if it was all black? You know, we were doing those sorts of tests. So again, very much a collaborative design experience. I think that's something that really comes through in what we do day to day. And that's me. Thank you for your time.
Okay, thank you very much, Adam. And next up, we've got more of a sustainability perspective from Paul Chatwin at Cundall. He'll be talking about facades and certifications considerations. So over to you, Paul.
Good afternoon. Who likes a medal? Who likes a badge for their buildings? Well, hopefully after this presentation, you'll see how the facades on the buildings that we design can help contribute to those aspiring clients that we've got who challenge us engineers, and a design team to come up with the badges that we want. So there's a new kid on the block, which is the UK Net Zero Carbon Building Standard, which is undergoing a testing phase. This standard looks at operational energy, PVs, so that last building would score very well with the PV side of things, and embodied carbon, but that's not live yet, that's undergoing this pilot phase. We're used to energy performance certificates. We've had them for probably 20 years now. And some cases we know that there's this performance gap between true energy and what you get with your EPC certificate. We've had BREEAM for quite a while now, and Birmingham City's policy still includes BREEAM Excellent for major developments. And we've got another new standard, or relatively new standard, which is probably better than the EPC, which is focused on operational energy, which is called UK Neighbours. And it did come from Australia, where they've had their Australian neighbours for a while. And lastly, we've had the WELL badge, which focuses on health and well-being, the internal environment. So our facades that we design will impact all of these ratings one way or another. Sorry, I forgot one. This one isn't actually in force yet, but has been mooted and talked about for a while, and that's to do with embodied carbon. So during the recent nice weather, I've been touring around Birmingham, taking photographs of facades, probably because I knew I'll be on stage in a couple of weeks' time, presenting to a collective of facade specialists. And I know that when I look at building physics and when I look at sustainability, that there is more to a facade than its window-to-wall ratio, its thermal bridging, its U values, and the G values on the lighting. They are, you know, signposts to the city of what we can do as a team with our fantastic buildings. And you'll see some of the images. There's old buildings as well as new buildings. One thing I considered for this presentation today was creating a top trumps sustainability card. And I did play with this in my head for quite a while. You could have the usual age, height, and things like that. But what about public value or social value? What about its embodied carbon? How could we compare buildings? Because the facades will actually influence things significantly. Take the rotunda, designed after a candle kind of image. That was the concept that the architect used. Was an office, has been converted to residential in 2008, is 60 years old, celebrating its 60th year this year. So there's lots of good merit about the embodied carbon, the retained existing structure, the mixed use, well, the change of use. And it's EPCs. There's about 170 EPCs on this building because each residential has one, is around a C badge. But how does that compare to other buildings? How could we use top trumps for commercial workplaces? On the far right, 5 St. Phillips, I'll be talking about this in a while, around some of the technical details, is currently, had a Cat A works done to it, and it's undergoing a Cat B works this year. You've got 103 Colmore Row, which is a highly glazed facade, which is something that we are doing less of these days, obviously because of the pushes on sustainability, the glass is high embodied carbon, the operational energy and the comfort side. And we've already heard quite a bit on Free Chamberlain Square. Free Chamberlain Square is going for BREEAM Outstanding. It's already had its neighbours 5-star design review undertaken and certified independently. So that's, again, high up on the credentials list. But then there are other types of developments. So with these public spaces, they would score very highly on a social value or public value, and the facade treatment may be entirely different to what an office treatment would be, but they're still worthy of getting high credentials. Residential is slightly different. Again, when you look at residential, some of the regulations are actually harder to achieve than other regulations, but you can still get a BREEAM standard for residential, which has changed now from the HQM standard. I can go on. The middle one, 19 Cornwall Street, is an interesting project that I worked on, which has been recently completed and handed over, where one of the facades was replaced, 3 of the facades were retained. That also is a very smart building. It's got the health and well-being certification, it's got BREEAM, it's got EPCs, and it's also achieved a design reviewed for a 5-star building. So let's just drill into some of these certifications a little bit further. Taking our old and well-known EPC rating. When we look at these buildings and a client comes to us and says, I need to get an EPC B or C, I need to comply with the future regulations, what can I do? Can I just change out the gas boiler, put in a heat pump, and all my pain goes away? Or an intelligent client, like we had in this case, said, well, I want to do the facade first improvement. I don't want to just chop in a gas boiler for a heat pump, and then it might be expensive to run. Can I do something with the fabric of this 1990s building? And we run through simulations. We look at improving the roof U-value, improving the wall solid components of U-value. And it brought it from a G to an F. And at the same time, you get a better air tightness, so we can use a new air tightness. But it wasn't a huge leap, we found. The software, when you put in, forget what we do to the facade, let's just change the gas boiler to a heat pump, which we know is a little bit more technically involved than just changing the boiler to a heat pump. You have to look at emitters, new pipe work, and disturbance. That automatically got a B rating. This is why sometimes the EPC conventions and rules aren't always the best rules to follow. You can get an A for that building if you did the fabric works and the heat pump works, and that's without PVs. You could probably get further improvements. Let's just dwell on BREEAM. For Free Chamberlain Square, achieving an outstanding rating in BREEAM is an incredible challenge. One of the hardest credits is related to the modelling side of things. You have to get an EPR 0.6 value for your mandatory requirements for outstanding. That 0.6 is made up of 3 different components of design. One is to do with systems efficiencies, one's to do with the carbon performance of the building, but one is to do with its heating and cooling demand. That then says, what is my fabric doing? And the fabric for this building, we already introduced more wall-to-window area that was explained earlier by Ross and James. So that does play to our advantages. We did look at 0.7s and 0.8s for the UCW, and this created some challenges commercially. But we're finding that we're on this knife edge, and this facade is impacting that 0.182 at the bottom, and we had to do lots of iterations to modelling in order just to meet this sweet spot in a mandatory requirement for a BREEAM outstanding. This project is in Manchester, and it achieved the highest operational energy rating of 5.5 out of 6 stars for the UK. And the facade you can see is something slightly different than your normal facade. What we worked with this client is we then took the window to wall ratio slightly lower keeping it keeping it landscape means you get better daylight penetration than going portrait. We looked at the passive house kind of U values and air tightness. To achieve its neighbours 5.5 star, sorry. To achieve the neighbours 5.5 star for this particular building, has a 25% margin in it. So in reality, it will potentially, if it's operated well, achieve a 6-star rating. 6 stars is phenomenally good, but it does challenge the design of the building. It does push down those envelopes. So the challenge I always have typically when it comes to operational energy assessments is the U value. The UCW compared to what you can achieve with a more traditional solid building. But we want to encourage modern methods of construction. We want to encourage a facade that is designed and can be built very efficiently off-site potentially. So that is not necessarily a solution that I have, but is one of the key challenges, is how to maximize the thermal performance of a facade when using curtain walling. The last kind of case study I've got is health and well-being. Health and well-being puts the certification on the individuals that live in these buildings, whether that's the staff, whether it's visitors to the building. It puts them at the heart of the design and what the facade can do in order to support the WELL accreditation is look at daylight penetration. And some of the things that we've considered is the use of light shelves. What we don't want is buildings where you drop the blinds because you've got a glare issue and then you leave the blinds down and you lost your view and you've lost the artificial lights going off and saving energy. So there are lots of tricks that you can play with the facade that are low cost, affordable, that can actually support these certifications. But as I've mentioned before, there is much more certification schemes out there. But the focus for this presentation is on the emerging UK Net Zero Carbon Building Standard, EPCs, BREEAM, neighbours, and WELL. But we mustn't forget embodied carbon. There is no real pass-fail on embodied carbon assessments yet, but we are starting to know what good looks like. Part Z of the building regs may come into force and we may have a minimum standard. You do have in London and the GLA minimum standards there that need to be achieved with your embodied carbon. But this UK Net Zero Carbon Building Standard might drive some of our designs to consider the embodied carbon assessments early in the design process. And we've already seen from one of the earlier presentations today how the investors and the occupiers of buildings are acutely aware of what good looks like now for their reporting mechanisms and releasing of funds. So what has Cundall been doing? Cundall's developed several tools that will help streamline and make this process efficient. With one particular project going into planning permission, the planners asked if we'd done any intelligent analysis on the facade. And we had done some intelligent analysis on the facade, but we pushed a large script, which was quite a simple script to create. I say simple script to create, a highly technical script to create that looks at various technical parameters on a small element of the building facade and rotated. We do this for each type of facade. And it focuses on window to wall ratios, external projections, G values, and you can see instantly by slide, once you've got the results, you can then play with the results to focus on how much do I want shading wise, what is the right window to wall ratio, how does that then impact on cooling energy, heating energy, my light, my solar load. So quite a sophisticated piece of script writing that can take a design from BIM into Rhino, and then we can use some of these scripts to do these kind of assessments to look at then the sweet spot. I guess what's really useful about this is doing the analysis is one thing, but sitting down with the design team, the architect, the client after, and challenging and saying, well, what if we do this? What if we do that? How does that impact on these numbers? So for an early stage design tool, I find this is incredibly powerful. The other tool that's been developed over the last 5 to 10 years is our carbon calculator tool. We are seeing embodied carbon requirements more and more across clients' targets and KPIs for their for their projects, and those are off the back of developers' KPIs and targets. And I know the industry for facades has got their methodology and tools for assessing carbon, and that forms part of our software tool as well. So we're able to report on alignment with UK Net Zero Carbon Building Standards, or alignment with KPIs for GLA or anything else. So I believe that's my last slide on badges for your buildings and certification schemes. So if there are any questions, please do feel free to catch me after. Thank you.
I've got one for you, Paul. I've got one for you, Paul. Hold on. I've got a question for you. Go ahead. Yeah. Okay, so Paul, one of my favourite buildings is Alpha Tower in Birmingham, which is opposite Paradise, and it's Richard Seifert's scheme. It's quite a medium to shallow plan, and it gives quite a good daylight to the spaces. You showed 3 Chamberlain Square, which is quite a deep plan building. I'm wondering, I'm sure that it works very well in terms of carbon emissions, but how does that score in terms of health and well-being and daylight and views?
Yeah, I think the window design for any building and the window to wall ratio is always a challenge. 3 Chamberlain Square did have some winter gardens in its design early on to maximise the health and well-being for some aspects of that building, and that did have to undergo several reviews. When you've got deep plan buildings, you can obviously look at atrium, but and atriums really do help that feeling, health and well-being feeling, but they don't always give you great savings from an energy perspective, and they can introduce more facade elements. A simple rule for daylight, and this is not a very complex rule, is if you can see the sky, you will benefit from daylight. So with taller buildings, a lot of the challenge is, how do I get daylight to be effective into that building? So atriums will work well to support that element. There is that balance on external window to wall ratio and getting daylight in for health and well-being. A deep plan building is very efficient in its form, but it will then, you'll have to play some kind of tricks in order to get that daylight into the buildings.
Okay.
I don't know if I've answered the question there.
You
but,
have another one. Yeah.
Ross actually mentioned it quite well. The rules in Letty say 30 to 40%. It does depend on your elevation, but that might create a gloomy environment if you're not careful.
Yeah.
So you do need to make sure that you've got those places that people can go to where they will benefit from natural daylight. It doesn't have to be everywhere, but it could be winter gardens, I think, are a good solution.
Yeah, no, it's just because a great space and a sustainable space is one that's well used and people want to go in and use it. It's no point creating a really highly energy efficient building if it's too dark or
But we do know if you've got too much glass, you're too hot or too cold, and who wants to see my legs under a desk if they're close to the window?
You've got good legs.
So,
all right, thanks,
Thank
Paul.
you.
Okay. Okay, next up we've got Ian Wilson from Benx, the chairman. He's going to talk about addressing the challenges of rain screen specification.
Good afternoon, everybody. Hope you're enjoying the conference. So as Aneel says, we're going to look at the challenges of rain screen from our perspective as we encountered them, and some of the things we're doing to try to address those challenges. First, a few words about Benx. We've been trading now for more than 20 years. We supply EWI and rain screen products and systems into the new build, remediation, and energy efficiency markets. We like to consider ourselves as quite an innovative company, but I'll say disruptive from now on, following this morning's presentation from Eric. We do invest a lot of our retained profits back into testing and certification, which, as you will know, is a requirement in this industry. In terms of our key metrics, we have about £35 million in sales. We have just over 100 employees, and we operate from 8 UK locations, including 2 fabrication facilities. If you haven't come across the Benx name before, some of you may know one of our operating subsidiaries, SPS EnviroWall, which is a leading supplier of EWI systems, while RCM, our other operating subsidiary, it distributes rain screen products and systems, probably most famously our Y-wall sheathing boards. Excuse me. I'm going to spend a couple of minutes on our evolution because this sort of leads into how we got to grips with the challenges of rain screen. The top half of this slide plots the development of our EWI business, SPS Environable, over the years. And you'll see that those 4 milestone events highlight the introduction of a certified EWI system, which is a requirement in the funded energy efficiency sector. The lower half of the slide shows the evolution of RCM, our rain screen business. Until about 12 years ago, we were largely supplying sheathing boards with some ancillary items. But over the years, we started to add other components to our offering, so that by around 2018, we were offering quite a wide range of rain screen products. And it occurred to us that there may be an opportunity to introduce a complete system to the market, as we've been doing for many years with EWI. But before leaping in, we thought we'd do a bit of due diligence, talk to some stakeholders, and also compare it to our experience of EWI. Fairly early in this process, we started to identify some of the key challenges. Now, most of the issues we identified stem from the complexity resulting from fragmentation in the supply chain. So what I mean by that is that for every component in a rain screen system, we noted that there were numerous potential suppliers. And while some, just like RCM, offered multiple components, the concept of a complete system was virtually unheard of at the time. And certification, to the extent it existed, also happened at the product level. So when creating a new specification, the specifier not only had to select the components, but also consider the compatibility of those components in a complete system format. And that was an issue because it involved engaging with several, sometimes multiple suppliers for design collaboration, documentation, etc. And that was a challenge in terms of the logistics of it and timelines, etc. So much so that several of the architects we spoke to said that wherever possible, they'd reuse an existing specification, though they did accept the limitations of that approach. Now, this complexity also affects contractors who, for procurement, installer training, supply logistics, and site support, have to coordinate with multiple suppliers in some cases, a few, but up to multiple suppliers. And this often led to errors and delays. And guarantees for rain screen, we noted, were for specific components and not the whole system. In fact, one building owner said to us that they cover so little of the system, they're hardly worth the paper they're written on. Now, contrast this with EWI, which we knew well. EWI has long been dominated by fewer than 10 companies that act as consolidators. So what they do is they combine components into systems, have them tested, and then certified and offer them to the market. So with EWI, the whole specification process was streamlined and simplified by dealing with a single supplier. This also extended to all of those processes with the contractor as well, where we can eliminate a lot of that complexity of dealing with multiple parties. And the guarantee for an EWI system is for the whole system on a single document. So it occurred to us that maybe we can replicate some of these benefits of EWI and take them into the rain screen market. So we took what we call the EWI plus approach. EWI systems typically start at the insulation layer and work out. We thought if we go right back to the sheathing board, we could offer a complete outer through wall solution. So we created prototypes, designs. When we were happy with them, they were tested. We submitted them to Kiwa for Agremont certification. And as many things in life, it took a lot longer than we expected, cost us significantly more. But at the end of last year, we were able to announce the launch of our SafeWall family of rain screen systems. So what exactly is safe wall? Well, safe wall is what we call an outer through wall system. Starts at the sheathing board, works outwards. They are Agremont certified, and they're for light gauge steel frame construction. The Agremont certification includes all of the items shown in this slide. There are currently 3 versions of safe wall, all with the same components, but a different decorative finish. First is safe wall with Swiss pearl, which features panels in a wide range of colors and finishes. They're fiber cement. The panels have a special surface finish, sealed edges and back coating to help ensure that they have weather resistance and durability. This is an A2 S1D0 fire rated system. Second system is safe wall with rock panel, which features colored compressed basalt panels. They're almost 100% recyclable. The panels are lightweight, easy to install, and can be cut, bent, and curved. And again, the system is A2 S1D0. Safe wall with LuxClad, our third system, features lightweight, highly durable, colored aluminium panels. The system is A1 non-combustible. The panels are almost 100% recyclable and available in any RAL color. I'm going to spend a couple of minutes on the benefits of safe wall. First is in streamlining specifications, which can be particularly helpful where time pressures are most intense. We can supply the draft specification and all of the documentation associated with that system, and also technical support from one team. Sorry, let's go back there. Safe wall is also versatile. I've described briefly the 3 system options, but you can also combine those finishes because each of those systems uses the same components back to the sheathing board, so you can create seamless combination facades. And you can also select different components within those system layers to suit different budget or project requirements. And because all of the systems are either A1 or A2 fire rated, they're suitable for retrofit or new build projects on buildings of any height. But we're not finished yet. In fact, we're going to develop safe wall in 3 key directions. First is to add new component options. In fact, as I was sitting there listening to the last presentation, an email came through with the latest update of the safe wall Kiwa certificates with a new insulation option in them. We're also going to continue with our testing program. We want to make sure that safe wall will always offer the strongest safety and performance credentials. And we're going to bring some of the ancillary items inside the scope or the guardrails of the Kiwa certifications. And third, we're going to offer more design choices. I spoke briefly about the 3 panels we have currently. We're looking to add brick slip and render options in the short to medium term there. So we see the safe wall approach as potentially the start of a new way to specify, procure, and install rain screen systems. So in summary, we believe that safe wall addresses many of the issues we identified associated with the complexity of the rain screen supply chain. It does this by reducing complexity risk and inefficiencies. Safe wall is currently unique in the market. It's the only Agremont certified outer through wall rain screen system. We think others will adopt a similar approach, but actually we don't mind that. We think that certified systems are the best way to ensure safety and performance of rain screen. Thank you for your attention. If you haven't already done so, do please visit our stand in the display area. My colleagues and I would be happy to answer any questions you have or discuss any project-specific requirements. Thank you, and enjoy the rest of the conference.
Thank you very much, Ian. Okay, so next up, we've got Ashley Phillips from DuPont. He'll be talking about fire systems innovation and setting new performance benchmarks.
Hello and good afternoon, everyone. I'm Ashley Phillips, Senior Technical Specialist at DuPont. And today I would like to talk to you and give a brief introduction into who we are, how we work, our motivations, and our goals. Just about resisted the urge to knee slide across the stage there to the music, but maybe there's time for a stage dive at the end from the standing ovations. So. Probably not a good idea. Yeah, so all of our activities are driven by our core values. These are safety and health, respect for people, highest ethical behavior, and protecting the planet. DuPont was founded in 1802. And it's safe to say the initial safety conditions weren't great. 1818 saw a gunpowder mill explosion that actually killed 34 workers. And in subsequent accidents on numerous occasions, DuPont family members and other people have been injured seriously and fatally. So for over a decade, we've had within the business safety at the core of what we do, and now at the heart of our operations as well. As we continue to innovate, we see that this core value really drives and leads to new materials that are safer, such as fire-rated systems. The ongoing development of these systems is also driven by industry drivers, such as the Building Safety Act. So now as designers and specifiers, installers, and manufacturers like ourselves, everyone's now accountable directly. So what we like to do is present information clearly to you, but also allow access to data that's reliable so that we can mitigate risk from everyone involved in projects. We find all of our core values align very closely with the UK construction industry, such as the drive to create more durable, energy efficient, and safer buildings. Our permeable breather membranes and our air and vapor control layer membranes, AVCLs, have long been a focus for us to achieve these goals. Our core values and response to industry drivers has led to our product evolution. We have a rich history and have been supplying Tyvek materials for over 80 years. Many of you may know the company. We have a good reputation for quality, and the properties of Tyvek, such as its breathability and durability, has led to our market-leading position. Within our breather membrane range, initially we developed a patenting technology which self-extinguishes when ignited. This became known as Tyvek Fire Curb, and this product is still our most widely specified breather membrane within our entire range. It's a BS1D0 classification, fire classification, and whilst current regulations set this as the minimum standard for relevant buildings, we would like to go beyond this threshold to further future-proof and guard buildings with even safer material. So I present today Tyvek Trifecta. It's a fire-safe breather membrane. It's able to provide vital protection against the three elements: fire, air, and water. It achieves a A2 classification, A2S1D0, and that's including the anchoring tape. From a scientific perspective, I'd just like to delve a little bit deeper into what this means in terms of fire propagation and fire spread. So EN 13501 Part 1 includes SBI testing, single burn item testing. Various factors are incorporated in this testing, and I've highlighted just two of which I'd like to speak about today. The first is heat release, and the second is smoke production. And these are looked at over a 10-minute period within the standard. Heat release needs to be below 7.5 megajoules, and smoke production below 50 meters squared. And that's for an S1 class. Fire curb, you can see, is represented as the blue bar, and Trifecta as the white bar here. Whilst both products are compliant, we can see Trifecta produces almost half the heat release as fire curb. But more importantly, it produces 4 times less smoke production. We know, and the Fire and Rescue Service statistics tell us, that smoke inhalation is the leading cause of fire deaths. So despite membranes being exempt from Regulation 7, as designers, if we can use and specify materials to limit smoke production, we feel it's a significant step forwards towards safeguarding the lives of building occupants, especially in high-rise and high-risk buildings. In developing this product, we did not want to compromise the primary functionality of the membrane. External envelopes require a membrane to be, yes, breathable, but also highly water resistant. A thorough understanding of water protection and water resistance is required by designers so that we can specify and design buildings that will be future-proof, and we can avoid costly remediation. BS 8104 recommends W1 as the best practice, especially for when the building is located in an exposed area with exposure to persistent and driving rain. Today we're in Birmingham. We're at 183 meters above sea level. It's moderate exposure here within the class. If you're close to the coast, within 30 miles, it would be extreme exposure. But obviously, of course, building height needs to be factored into this as well. Please be aware that many other manufacturers produce fire-rated and other materials that are W2. This is something that we would not recommend especially for rain screen applications. We're pleased to say that we achieved W1, and therefore it's a superior level of weather protection, certainly for exposed conditions such as rain screen facades. With up to 12 months UV exposure as well, this is the most durable product within our entire range. It allows contractors to temporarily waterproof zones of the building on large-scale projects and with over 12 months before the rest of the external envelope is installed. We ensure that our ongoing development complements our existing portfolio. So now by combining the Tyvek Trifecta breather membrane with the A2FR AVCL, air and vapor control layer membrane, we can offer a combined system to combat the surface spread of flame across both the exterior membrane and the interior membrane. However, to specify these materials correctly, especially fire-rated materials, we need to consider many things as designers. Firstly, substrate material, substrate type. The second is ancillary products, and also fixing methods. It's critical that we understand the scope of application and the system details that are within that test certification report. Once designed and procured, the installation is also really, really critical here. The contractors, as an industry, we need to have a protocol that mirrors as close as possible the scope of application and the test classification report. But a common problem with the industry currently is that the test criteria is very standardized and there's limited interfaces compared to a real-world built environment and a fire scenario in real world. There are a number of exemptions that, of course, the building regs include, and we at the BKC, I'm part of the Building Knowledge Centre, we're able to give further explanation on these nuances. Another factor that I'd like to talk about is airtightness and fire systems. Is many people, operatives, don't go to learn specifically how to install these. So they don't, have expert training necessarily. And it's something that we really advocate at the BKC. So if you get in touch with us, we're able to talk through the details of the system and how they can best get proper air tightness and proper value from these products. So I skipped over a slide earlier on. I'd like to go back to this slide. And this is that I'm part of a BKC team. So here at the BKC, the Building Knowledge Centre, we're based in Bristol. And we encourage collaboration. We supply materials to every inhabited continent. And within each region, we have a team of dedicated professionals to support clients with a really diverse range of material applications. Whilst each region has its own specific team, we come together as a Building Knowledge Centre. And what that means is, and from a UK perspective, the UK regulations and our team here, the regulations that we see are that we're some of the most stringent fire regulations in the whole of the globe. And so this information that we can pass to colleagues overseas as well drives process and regulatory change, not only here in the UK, but overseas. And it allows us to develop systems that are essentially future-proofing ourselves. So the talk today, we hope you've enjoyed how our global team have responded to the UK's change in fire regulations and how we can help protect building occupants as well as property assets by using high-quality engineered materials. I'll leave you with a summary at the end, which is another video. Probably won't stage dive. Waiting for a standing ovation. I don't think I'm going to get one, but that's okay. And yeah, as I say, please come and speak to us. We're on the stand. Any questions, any queries, if we can help on projects, we will. We're here to help. And thank you for your time. Thank you for listening. And speak soon. Thanks.
All right, thanks, Ashley. We're going to circle back towards rain screens. We're going to talk more about rain screen remediation now and protecting thermal performance. We've got Stuart Whiting, who's a facade consultant at Fix Fast.
Good afternoon, everyone. Getting to near the end of the day, I'll try and keep you awake. So, this presentation is focusing on thermal performance and rain screen remediation. There's a lot of focus, rightly so, on fire performance and on structural performance and the safety aspects of that. I think that our experience is that when it comes to thermal performance, there needs to be a better understanding and better knowledge share. Condensation is a risk, but it's not going to be covered in this presentation. We're going to focus very much on U-value. So, heavy slide to start with. They get lighter, I promise. You don't need to read this. Obviously, if you're a facade engineer or a building physicist, you should know this anyway. For those of you that lost your notes from your CPD, photograph it. But there's lots of terminology that you need to understand and talk about when we're talking about thermal performance. Really, the takeaway for this presentation is U-value through wall performance, thermal performance of the wall. The lambda value, that's the performance of a material, thermal conductivity of a material. And you also hear terms like psi value and chi value. So the psi value is basically the line loss for a rail or something with a thermal bridge within a rain screen, and the chi value is the point loss from a bracket. It gets lighter soon, I promise. Building regulations. So what do the regulations say? We're going to focus on volume 1, which covers the residential aspects and dwellings. The first point in the approved document is 4.1, which refers us to BR 443. That's the guidance that we need to follow when we're working out the weighted U-value of the external wall. Moving forward, there's different sections within the document that relate to new build, replacement elements and existing. So again, we're going to focus on the replacement elements and look at what the rated U-value we need to achieve is. The target value in table 4.2 says 0.18. Notice at the bottom, there's a little bit that says area weighted average U-values. You can't just look at the solid elements, the insulation, etc. You've got to take into consideration the losses with the components that are part of the rain screen system. There's also another section a little bit further down in approved document that talks about renovated and retained items. There's a bit of ambiguity, and on different projects, different building control officers look at things in different ways. I know we see people coming to us saying that they need to achieve a 0.18 or a 0.3. Always check with building control in your project what your target U-value is. What's the challenge when it comes to remediation? A lot of the remediation focused on fire. We're taking out insulation that's got a lambda value of 0.02. We then replaced it with insulation that's got far better fire performance, but actually has got worse thermal performance. So typically 70% poorer value, so increased thermal conductivity. And that's going to have an impact on the through-wall U-value performance, and ultimately the same thickness is going to give you a worse performing wall. What does that mean actually in the real world in terms of thickness of insulation to achieve target U-values? So simply, first of all, looking at some models, looking at simulations without considering the rain screen. If we model a typical SFS wall, 100mm SFS, sheathing board, look at how much insulation you need originally, and with a new non-combustible insulation to achieve your 0.18 or your 0.3. So you can see left-hand side, 0.18, you're going to be using typically about 125mm of a mineral wool insulation. To achieve 0.3, it's only going to be 60mm. The reality is, though, you're increasing the insulation by 50%. Now, it's having an impact on the wall build-up. It's not actually achieving the performance that the original insulation had, so it's not going to be compliant with building regulations. And that's before you've considered losses. You've got to consider the weighted average and take into account the losses from the rain screen system. What are the losses? We're back to psi and we're back to chi. So psi value, cladding support rails, the bit that the panels are fixed to, typically vertical or horizontal. A substrate profile. A lot of remediation projects and even new build projects will have a profile fixed to the sheathing board so that you can fix the helping hand brackets off the positions of the SFS studs. That needs to be considered in your calculation. And then you've got the helping hand brackets themselves, the point loss. BR443 gives you two options to work out what the impact of those losses are. Option 1 is numerical modelling, and option 2 is just add 0.3 to your U-value. Option 2 isn't even an option when you look at the targets that we've got to achieve, so you've got to go down the route of numerical modelling. Let's look at the components. Not straightforward as other people have said previously. There's lots of components that go into a rain screen. There's lots of different materials that need to be considered. And all of those materials have different levels of thermal conductivity. So this chart just gives you a visual comparison. You'll see that aluminium I know 6063 and 5052 are two typical grades that will get used in aluminium components. They have different levels of thermal conductivity, but it's substantial. Steel and stainless steel, still significant in terms of their conductivity, but significantly better than aluminium. Hopefully there's not too many of you using steel in your facades. And then you look at the other elements, the cement particle board, etc., relatively low levels of thermal conductivity. I think this slide just indicates how important it is that you take into consideration the metal components within a range screen system, because they are going to have a significant impact on U value. Probably one of the most common questions we get asked at FixFast is, can we have the chi value for your bracket? If only it was that simple. There is not a published chi value for a bracket. You need to model the bracket within the wall build-up, and only then will you actually understand how that's performing. The same goes for the rails and the substrate profiles. So you have to go and model that wall build-up. You have to model the complex components, the brackets, etc. in software. You import that into 3D simulation software. You then run that simulation 2, 3, 4 times, depending on the number of components you're looking at. And only then can you work out what your chi and your psi values are for those components before you put them into a U value calculation and work out the reduction. So anybody that just says, here's a chi value, they probably haven't got the right chi value for your wall build-up. Because for them to understand what the chi value is, they've got to understand the details of your wall build-up. So, focusing on brackets and point losses, are all brackets equal? Can you just take the chi value for one bracket and substitute it for another bracket when looking at the design iterations of your system? So on the left, we've got the Speedy Match brackets, which FixFast supply. We've got an aluminium bracket and 2 versions of stainless steel brackets. On the right-hand side, we've got some, I'm going to say, miscellaneous generic brackets, identity slightly disguised. You'll see that the yellow, orange, and red brackets come in single, average, and double. And that's because most range screen systems incorporate single and double brackets. Double bracket being twice the size of the single bracket. When you're looking at working out the losses, you really need to work out what the average size of the bracket is based on the ratios of singles and doubles. So again, it's important to take these things into consideration. I'm going to skip that slide. So what we're going to do is look at producing a little model that considers the performance and looks at the performance of those different brackets. So standard wall build-up again, 100 mil SFS. We've got 150 mil of insulation and 185 mil bracket, and the brackets are at 600 centres and the rails are at 600 centres. So the bar charts, the green, that's the chi values. So that's the point loss of each of those individual brackets. So you see that the stainless steel, A4 and A2, much better performance, much lower values. Low is always good when it comes to thermal calculations. Big is bad. So the stainless steel, not much difference in terms of their performance. They're going to give you the best U value. When you then look at the aluminium brackets, the reality is it's based on the size and the amount of material of the bracket. There might be differences in the grade of aluminium, but they don't have a significant impact. So the green bar, that's the Speedy Max aluminium bracket, and then the orange bar, that's a typical average value for a ratio of 3 singles to 1 double. And you'll see the impact there that it has on U value. Your U value will increase if you have more brackets or larger brackets within your facade. Next scenario, what about centres? How do the centres of the brackets, the centres of the rails, how do they impact the chi value and how do they impact the rail? So same model's built, and what you'll see is that the chi value is the same. The chi value doesn't change because the wall build-up hasn't changed. What does change is the U value. The U value will go up significantly if you've got closer centre brackets. So you've got heavy facades, you've got high wind load, you're going to end up with brackets down at maybe, I don't know, 300 centres in this example. You're going to have a U value of 0.4. You're not going to get that through building regulations. You're going to have to increase the thickness of insulation. At the other extreme, the other end, 750 centres on your rails and your brackets, you're going to be down at 0.2. Yeah? So you can see that you've got to understand the rail and bracket centres to be able to calculate your U value correctly. If you don't have the right number of brackets modelled, then you're not going to basically get to the right answer. One of the other things that needs to be thought about is rail embedment. So quite often the cladding rail will pierce into the face of the cavity insulation. It's generally accepted that if it doesn't, you don't need to model that as a loss and you can ignore it as a line loss. But once it's actually embedded into the insulation, you should really be producing a model to calculate what the impact is going to be on U value. So this time we're just looking at no embedment versus 10 mil embedment. Left-hand side, so green bar is your chi value, that's your bracket loss. There's no line loss because the rail isn't embedded, and you achieve just under 0.18. 10 mil of rail embedment, aluminium rail embedment, and you go to 0.2. So actually your U value is now no longer compliant. So you've got to consider when you're designing your range screen system and you're modelling your thermals, is the rail going to be penetrating the insulation or not? Interestingly, if you go from an aluminium bracket to a stainless steel bracket, the impact is far smaller. The comparative less conductivity of the stainless steel bracket helps insulate, and actually, therefore, if you've got rail penetration, you're not going to see a significant increase. It might go from 0.179 to 0.182 in this scenario. One of the other things that we often see on projects is large cavities. When you get to large cavities, often there's a bit of a hybrid solution used. Most range screen brackets are only available in circa 300 mil long. So if you've got a 400, 450 mil cavity, you'll end up seeing that the designer will basically put a top hat at the back onto the sheathing board, fixed to the SFS, and the bracket fixed off the front. Again, that needs to be modelled as part of your thermal calcs. So one of the benefits of the Speedy system, we do brackets up to 600 mil in a facade application, so we can do away with that top hat. But is there any benefit? So left-hand side, shorter bracket, 300 bracket with a top hat, and you achieve a U value of just under 0.2. If you just use a single aluminium bracket, the longer one, fixed straight back to the SFS, then your U value is at 0.18. So you get better U value, it's easier to design and it's easier to install, and it's going to be more cost-effective as well. Getting near the end now, I promise. So stainless steel versus aluminium to achieve 0.18. What's the typical build-up you're going to be looking at? Is there going to be a benefit of going down the route of stainless steel? So as I said earlier, with no brackets, you're going to be looking at about 125 mil of Rockwell insulation to achieve a 0.18 U value. It's not valid. If you go to stainless steel, you're going to increase that by about 25 mil. So you're going to go to about 150. And if you go to an aluminium bracket, that's going to increase to about 225. These are based on 600 by 600 centres. There's different performing insulations. If you have a thicker SFS, it's going to impact it, etc. So that's only applicable this scenario, but you can see the trend and the relative performance between stainless steel and aluminium brackets. So to summarise, know the target U value for your wall type. I've focused on 0.18, 0.3. New build, you may be lower, you may be down at 0.13, 0.15. Your calculated U value has got to account for the thermal bridges. So you've got to understand the construction of your wall. You've got to understand the details. If you're going to understand that, you need to understand the structural performance and what your bracket centres are. So actually, it's a holistic design. You can't do one without the other. As I said earlier, ensure the sign, the chi values are relevant to your wall build-up. You can't just be provided with a generic psi value and chi value for brackets and substitute it. It's not valid. And verify the quantities of brackets per square metre. If they get closer, your U value is getting worse. From an installation point of view, just make sure that your components that are delivered or installed and the centres that have been installed at match the thermal calc. The designs evolve and the thermal calc doesn't always keep up. You don't want to end up with a building that isn't compliant. Avoid gaps in cavity insulation. These calculations will work on the basis that there are no significant gaps in the insulation. If you've got gaps going through around brackets, etc., or interfaces between cavity barriers, your U value is going to be worse. Minimise the use of top hats and rail embedment unless it's already been calculated in. And if you've got those type of changes creeping in onto site over significant areas, or there's wholesale change in terms of the design, you've got to consider the thermal impact and look at redoing your thermal calcs. So that's it. That was a whistle-stop tour of U values and thermal calculations. If you'd like to come and have a conversation with us, talk to us more, we're outside. Thank you very much for your time.
Yeah, please do make the time to visit all the stalls and chat to the product suppliers. Thank you very much, Stuart. You didn't need to rush as a facade consultant. I love that stuff. You could have talked all afternoon. Chi values, love it. Next up, we've got Tansu Kumru. Hope I said that correctly. From Turkish Glass, she's the vice chairman, and she'll be talking about glass, and every project has its own unique story. So, a bit cryptic, but yeah, thank you.
It's wonderful to be here with you. Today, I will introduce you to Turkish Glass, a comprehensive solution partner for the most demanding projects all around the world. Turkish Glass represents the glass manufacturers and processors of the Exporters Association of Turkey. They are interdependent and complement each other to provide excellent project management. Every project is a unique journey for the Turkish glass ecosystem. This journey begins with a project-specific glass consultancy. Turkish glass manufacturers undertake detailed technical calculations to identify the ideal glass type and thickness. Then the certified Turkish processors, in cooperation with the manufacturers, will continue this journey by supplying the right glass of the highest quality and at the optimum price. Turkey has many years of experience in the glass industry with an architectural glass production capacity of 200 million square meters per year. With its high production capacity and powerful ecosystem, Turkey is a global glass production hub. Moreover, our extensive product range allows us to meet all needs, such as energy efficiency, safety, security, noise control, and bird protection for both residential and commercial buildings. All of our product ranges are now available as BIM object, providing a comprehensive solution of glass options for your projects. Turkish Glass is not only the solution partner of today, but also tomorrow. That's why we are continuously developing innovative products in our Science, Technology and Design Center to support the unlimited creativity of architects and to remain at the cutting edge of the glass industry. Having all of these capabilities, Turkey exports glass products to 175 countries, providing customized glass solutions all over the world. Now, I would like to share with you some of the residential and commercial projects that showcase our world-class capabilities. First of all, let's take a look at examples in Europe. You can see the signature of the Turkish glass industry in important projects in many European countries. In Bulgaria, in this special project, our glass products provide visual integrity in harmony with the horizontal and vertical profiles used in the facade design while minimizing heating and cooling expenses. This building, which is designed to resemble ocean waves, ensures maximum energy efficiency with an holistic insulation system including bricks, window profiles, and glass units. This palace is one of the great historical landmarks of Hungary, built by the Archduchess of Austria in the 19th century. In transforming it into a luxury hotel, the architects combined a sense of place and cultural heritage to create a hotel full of meaning for today's guests. We supported this project with our high-performance heat and solar control coated glass. The Victoria Tower renovation in Brussels aimed to transform the existing structure into a low-energy and fossil fuel-free building. The facade with solar control low-E coated glass adds extra value while maximizing the efficiency of ecological resources. This tower in France is a dynamic oval shape with gray and silver glazed elements combined with a white metal structure that allows for magical nighttime lighting. In Manchester city centre, refurbishing this building rather than demolishing it dramatically reduced the carbon footprint of the building. The choice of glass with highlight transmission and a solar factor value of 0.37 further enhances the building's sustainability. This building in Romania achieves exceptional heat and solar control with its triple glazed glass, which beautifully reflects the blue tones of the lake and the sky. Now I would like to show some projects completed by Turkish glass all around the Americas. In this building in New York, we developed glass solutions with silver characteristics that are compatible with the anthracite material used in the facade design. Located in the center of Silicon Valley, Tower 27 serves as housing for 20,000 new technology employees. For this extra special building, we developed a glass solution with 50% light transmission and a solar factor value of 0.33. Due to the hot island climate of the Dominican Republic, the best choice was our glass products with 50% light transmission and 0.25 solar factor, which ensures both the comfort of the hotel guests and reduces cooling costs. At the same time, our glass product with its unique bluish reflective color has been chosen by Marriott hotels worldwide. As you can see here, this building near the Mexican border with Texas needed maximum solar control due to the region's extreme temperature. Our special glass with 40% light transmission and 0.22 solar factor was uniquely suitable for this project. In addition to large projects, we provide services for various boutique projects in the United States. By integrating more wood and triple glazing into architectural design, we have created sustainable buildings that achieves effective energy efficiency. At the same time, we have utilized highlight transmitting glass to produce bright and luminous interior spaces. We collaborated with an architect who required a green facade due to the influence of the regional culture in a tower project in Bolivia, South America. This is a fine example of the creative capabilities of Turkish glass. Now I would like to share some unique projects from Turkey. Yes. We have developed new products for special projects such as Istanbul Airport and the International Financial Center. The facade glazing in the airport ensures maximum energy efficiency, safety, security, and noise control all at the same time. The Istanbul International Financial Center was completed less than 2 years with a total of 1.7 million square meters of glass units, including IG units, laminated mirror, and tempered glass under the extremely challenging conditions during the pandemic. The planning and coordination power of the Turkish glass ecosystem made this possible. Additionally, in our Bank Tower project, there are 2,760 different types of triangular glass units with a variety of sizes. This highly complex project was completed in 18 months with end-to-end planning between Turkish glass manufacturers and processors. The Istanbul TV radio tower, now a city landmark, gets its extraordinary elegance from the glass. The strong bond between glass and light shapes the architectural form. Grey tinted float glass and laminated low-E glass were used with their low reflectivity and high heat and solar control, ensuring the continuity between indoor and outdoor spaces. This flexible mixed-use cubic project is made up of various cubes that can adapt, expand, and evolve entirely based on the user preferences. The glass selection ensures maximum natural light utilization along with energy efficiency. This port management building, which is inspired by the container, receives natural light not only from the front and rear facades, but also from above with a special design using solar control low-E glass with high light transmission. Located on an archaeological site, the Museum Hotel preserves historical texture and offers a unique hotel design. Guests can view mosaics from 13 different civilizations. To ensure sustainable and low energy environment, 7153 performance heat and solar control glass were used. The largest solar power plant in Europe, located in a desert climate region of Turkey, is managed by the Central Control Building. The building's facades are designed to blend the earth and sky thanks to their high reflective levels. On cloudy days, the facade boundaries blur, merging with the sky. At night, the facade contrasts with daylight experience, revealing the interiors and courtyard. We also play an active role in a wide variety of projects in Africa, taking into account the culture of the region. We met demands for glass, reflecting the colorful culture of Africa at the Dakar Stadium in Senegal. We have developed highly effective solar control glass for the Senegal airport, including its bridge and train station. This airport has been recognized as the best in West Africa for passenger experience. Another airport in Africa that provides passenger comfort with its unique glass solutions. We developed a glass solution for the seaports complex in Rwanda, taking into consideration the climate, humidity, and temperature of the region, with glass having 58% light transmission and a solar factor value of 0.32. We met the glass needs of the Congress Center in Equatorial Guinea, which has a unique exterior design. In addition, we produce solutions in line with the needs of the hotel projects in Africa. The Nigerian Ministry of Finance project was carried out with the aim of modernizing the city and improving the working conditions. This building was covered with gray glass that provides effective solar control while allowing the view to be seen clearly with its low reflectivity. In summary, every project has its own unique story. As a comprehensive solution partner, Turkish Glass supports you throughout this journey with the strength of its powerful ecosystem. We believe that together we can enhance human life globally with our environmentally friendly glass solutions. Welcome to the new age of glass with Turkish glass.
Thank you very much, Tansu. That was brilliant. Amazing case studies. They say the glass skyscraper is dead, but it looks like it's still alive and kicking. A lot to do with the various coatings and G values that you can provide. So we're now going to go towards our final tea and coffee break. If we get back for 15 minutes, 20 minutes you've got, and we'll have the final session with two guys with the proper G values. Okay, cheers. Okay, so final session. Well done for getting here. We've got Clive Everett from NHBC. He'll be talking about facades under the spotlight.
So, yeah, my name's Clive Everett. I work for the NHBC. I'm going to be talking about insurance, and obviously, as we know, facades are very much under the spotlight as far as the insurance industry is concerned at the moment. I have to caveat this by saying I'm not an insurer, I'm not an underwriter, and I'm certainly not an actuary. I'm just a facade consultant that happens to work in the insurance industry. I'm going to go through a quick overview. So some of you might not really understand how an insurance company works. I'm not going to go into the detail because we would be here for like the whole day. It's a lot more complicated than people think. But I'll just give you a light overview. Then we're going to talk about what's actually shaken up the insurance industry, what the rebalancing is that's going on at the moment, and what the future might look like. But these are all my observations as a facade consultant. So we've got an insurer. An insurer either decides that they have an insurance product that they want to sell, or the industry or the government will come to an insurer and say there needs to be an insurance policy for this. So the insurer's got a couple of routes. So that insurer can self-insure. So that's where the insurer has to decide or obtain enough capital to be able to pay out on all the claims on all the policies that it's given. So if it's taken £20 for every policy and it's given out 100 policies that are covering £1,000, it doesn't have to cover the £20 per 100 policy, it has to cover the 100 policies times £1,000. So there's a lot of risk there for the insurer. So most insurance companies don't self-insure. They just can't. Even if they could, and they then had a really good product, as that product sold really well, soon they'd run out of capital and they wouldn't have the money in the bank that the FCA requires them to have. So for that reason, most insurers don't self-insure. It's just way too dangerous. So what they do is they go to a broker. And a broker will go and talk to a number of people and they'll pull together an insurance panel. And that insurance panel will normally consist of a lead insurer, someone who's actively interested in doing that kind of business. That lead insurer will normally then marry up with a specialist insurance company. So they won't have the capital, they won't have the funds. They will have some funds, but not the level of funds that the lead insurer will have. But the specialist insurer will be able to give them advice on what that risk looks like. So they will have underwriters and actuaries who will be able to work out the level of risk, and that's what determines the premiums. And then you have a third party, which is sometimes involved, which is a follower insurer. Basically, they're people that have got money, they're investing, and they'll go, well, if the lead insurer is happy and the specialist insurer's told him what the risk is, I'm quite happy to jump on that ship and put some money in because I'm going to make some money, because it's all about making money. Then that enables the insurer to sell his product and as that ball starts rolling, he starts picking up more policies, the insurance panel just gives them more and more money to stick in the bank so that it's all covered. The important thing to note about this is that the lead insurers and the follower insurers will normally be in the insurance industry across the board. So they'll be looking at all sorts of other insurance policies and covering those as well. So it won't just be this product. And that's interesting for later on. So what's shaken up the industry? Well, obviously, over the last 7 years, the insurance business has taken multiple hits. Residential home warranty providers, which NHBC is one of the largest, obviously. We've taken really large hits from, we partially direct insure, but we also have reinsurance policies as well. But we have paid out an awful lot of money because we provided Section 4 cover, which is effectively cover against failure to comply with building regulations. And obviously fire safety comes into that. The one that most of you will know more about is the professional indemnity insurance. They've taken massive hits, and that's as builders attempt to recover their costs from their architects and their consultants, their subcontractors, and their suppliers. And then it moves down the chain. Now those architects, consultants, and subcontractors are going to their subconsultants and trying to claim off of them. So the ball is started rolling at our end, and it's now carrying on. Certainly from the residential home warranty providers side, we've seen the worst of it now. But certainly from the professional indemnity side, the insurance companies are still taking an absolute hammering. I'm not trying to make you feel sorry for them for a second. So, the other thing that's come into the equation is the Defective Premises Act. So where everyone thought they were on the hook for 6 years because of the change to the Defective Premises Act, if you built your building before June 2020, you're now liable and responsible for it being a habitable demise for 30 years. And if you built your building after June 2022, you're on the hook for 15 years, even if all the work that you did was just remediation work. So it's now just not new build, it's also remediation works as well. So getting to the point about some of the conversations we had earlier about retrofitting, refurbishing existing buildings, those would fall into that 15-year category. So what rebalancing is going on at the moment? Well, insurers are obviously trying to recover some of their losses. They're absolutely not going to recover all their losses, but they're going to try and recover whatever they can. So they're going to do that by increasing PI insurance, and you've all seen that happen in the industry. And they're also increasing residential fire insurance premiums, because this is where we talked earlier about these insurers don't just insure warranty providers, they don't just provide PI insurance, they also are in the wider insurance market. If they're in the insurance market, they'll be providing cover for cars and all sorts of stuff. But one of the places they can try and recover some of the money from is from insurance premiums on fire. They'll also try and mitigate future losses. And this is where it starts to impact you guys. You've had the hit on the insurance premiums. Now we're starting to move into the future world. So they will start discontinuing insurance products. There were 20 major, so there are hundreds and hundreds of people that provide insurance covers. But all of those come out of a pool of about 20 insurers. The rest are just bolt-ons, trickle-down insurers. So there were 20, that's significantly decreased because there's not the appetite for it. They've seen everyone taking a big beating, they've taken a big beating, they're just moving out of the industry. They're reducing cover on certain products, as I said before, as a warranty provider for residential homes, we're no longer providing what we call Section 4 cover. So we're not providing cover for building regulations, failures to comply with building regulations. Or they will still provide the cover, but where there are higher risk items, if you want that higher risk item, you will pay extra money for it. So yeah, I can see there's a number of facade consultants in here. If you're a facade consultant and you've signed a waiver with your PI insurer to say, we will not have anything to do with fire safety, your premium will be lower. If you're a facade consultant or a fire engineer that is in that world where you have to look at the fire safety aspects, your premium will be substantially higher. What this whole experience has generated is insurers have suddenly wanted to know more about facades. Up until the last 7 years, a facade was a facade. As far as an insurance company was concerned, they didn't care what it was made of. They do now, and you're going to see this moving forward. You're not seeing it yet, but you will see it moving forward. So insurers are trying to understand how some facades aren't that expensive to remediate and some of them are colossally expensive to remediate. So the government produced a paper in December 2024 where they analysed 300 projects that had been through the Building Safety Fund. It's a readily available paper. The variance that they showed was the cheapest one was done for £739 a square metre, and the most expensive one was done for £2,528 a square metre. Now, you're all knowledgeable people in here, you know why that is, and there'll be lots and lots of factors as to why that is. The insurance company, up until 7 years ago, was blind to all of this. So what's that going to mean for the future? Unfortunately, you are going to continue to see inflated insurance schemes at the moment until such time as the insurers have to start reducing the premiums. And they'll have to start reducing the premiums as new insurers start to come back into the market, because then that's when competition will happen. But that's not happening yet. The new players, so the old players that were in the business have now gone. Some of them may come back, some of them won't. But what they will be replaced with is new players. The new players, they don't have any legacy. They haven't got any outlay. They haven't got any claims against them. So they're just making hay, effectively. So they will make good money on the good premiums because the market is driving high premiums. But eventually, the old school will want to take some of that quota back. So they will start competing against each other and we'll start to see the premiums come down. But like I said, it's not happening yet, and don't hold your breath. Insurers have also started to cotton on, and how they didn't before, but they believed that if a building was constructed in accordance with the regulations, that meant that it was a safe asset. What they've learned is that the approved documents and the building regulations that sit behind them are designed for life safety. They're not for retaining the asset or protecting the asset. As long as you can keep the people safe in the building and enable those people to get out of the building safely, once they are all out of the building, if that building burns down, the building regulations doesn't care. And that is something that the insurance companies have no clue about. So yes, it's true that the recent changes to the regulations have effectively removed combustible materials from new buildings. Obviously, we've got a lot of historic buildings still there, still with combustible materials in them. But new buildings over 18 metres won't have combustible materials in them. But that's not true of buildings below 18 metres. So you could actually start to get into a world where your insurance premiums, your fire safety insurance premiums for buildings below 18 metres will actually be higher than those for a high-rise building, because the high-rise one doesn't have any combustible materials in it, and the low-rise building will. So they will either not insure those buildings, or they will apply higher premiums to them. And what you may find is that insurers will start driving the market. So rather than you working to the approved documents, you might start working to what the insurer is dictating, because why would you want higher premiums on your low-rise building? You know, for the amount of cost for installing non-combustible materials versus the combustible ones, you'd recover that in 4 or 5 years of excessive premiums. So why not just do it up front and make it non-combustible? So that might be the way the market goes. So hopefully what you're seeing here is that rather than having that binary approach that they had 7 years ago, insurers are getting a much better understanding of your facades, and they'll be looking at them on a facade by facade basis. So it won't be a one price fits all premium. So facades or external walls that cost more to repair or replace, which are more susceptible to fire damage, are likely to attract higher premiums. You know, that would be the sensible thing for an insurer to do. To say, if you're going to insist on having this very expensive facade that I'm potentially going to have to replace, then I'm going to charge you a higher premium for it. That didn't happen 7 years ago, and it's not happening yet, but the expectation is that it will. And taking fire safety out of the picture completely, if you have an insurance product which is a warranty which protects that building or that facade against other elements such as performance defects, such as water ingress or something like that, they're going to extrapolate that same data and say, well, if that facade fails due to water ingress and it needs to be replaced, and that's covered by my warranty, then if it's an expensive facade and it's difficult to replace or repair, I'm going to put a higher premium on it. And then, of course, you've got the end clients. So end clients have started to notice that they're getting higher premiums on some of their buildings, whereas other buildings have much cheaper premiums. So it's not beyond the wit of man that these clients are going to start saying, how do I keep my premiums as low, my fire risk insurance premiums down as low as I possibly can? And of course, that may mean that they start asking their professional teams to put stuff into the performance specification to ensure that they get the lowest premium at the end of the day. They may even have a conversation with the insurer before the building's built. And of course, both these end clients and the insurance companies that cover these buildings work across both the residential sector and the commercial sector. So everything I've talked about there is residential based, but it seems sensible that some of that's going to percolate across into the commercial sector as well. So just as a summary then, premiums are going to stay high in the short to medium term. Insurers are aware that regulations and ADB won't protect their asset. Insurers may seek performance that exceeds regulatory requirements for buildings below 18 metres. Insurers may seek higher premiums for facades that cost more to remediate or replace, and developers may start changing their performance specifications to reflect all those bullet points above. Hopefully that was useful and informative, and thank you.
Clive just got a couple of questions, if I may, while we're getting the panel discussion ready. Yep. So in terms of the premiums and the difference for higher risk products, perhaps, do you think that's substantial enough to drive a change in the, say, the insulation, if it's a reduced build-up with a phenolic compared to mineral wool? And
I think it's going to generate conversations. I mean, because obviously we've now got a definition from the building regulations as to what an external wall is, whereas before we just had facades and there was a probably within the industry, people thought, well, the facade is the bit that's on the outside of the wall, but now we've got an external wall, and the insurers are just looking at external walls. So there will be products that are used below 18 meters, frames. There's lots of timber frame structures below 18 meters. They're part of the external wall. I wouldn't see that necessarily. I have a whole conversation with you about timber frame buildings below 18 meters, but there's a market there for that. So I wouldn't say that the timber frame would necessarily change, but if you're putting a timber frame and you're then installing upon it lots of combustible layers, then that's probably something that the insurers are going to pick up on. Whereas if you say, yes, it's a timber frame, but everything that's installed within it and in front of it is non-combustible, that would probably be a different conversation.
Okay. And then you mentioned about water ingress. How do you think they'll go about scoring that sort of thing? I mean, would it be something like, oh, you had a facade consultant, you had Aneel come and do 20 site visits, no chance of any water ingress, we know it's going to be done right. How would they go about scoring that or understanding what the risk level would be?
It will be about the system. So they have a much better understanding of systems now. If you spoke to an insurer and said, I've got a unitized system versus a built-up system, they wouldn't have batted an eyelid. They had no clue. They are now getting clued up on what a unitized system is, how easy or difficult it is to repair. I mean, we have examples where it was a unitized system, it was installed from the top down, it was installed by a crane that was hanging off the top of the tower block, and then once all the unitized was installed, that crane was removed, and then they built another 4 stories over the top. Right. So now when that unitized comes to be replaced, no way of doing it. And so it's something that should have been relatively easy to get off is now impossible to get off.
Okay.
Not impossible, but very, very expensive.
Yeah. Okay. Well,
yeah.
Thanks for that.
So those are the things I'll be looking at.
Yeah?
Yeah.
All right. Thanks a lot, Clive.
Keep.
Okay. Next up, we've got a panel discussion on Great Charles Street. I do miss that car park. But yeah, Great Charles Street in Birmingham. Ian Gray is going to be leading that panel discussion. Over to you, Ian.
Cheers. Hi there, everyone. Thank you for hanging on till the main event. Thank you. So just while our panelists are all getting mic'd up and getting themselves situated, I thought I'd just give a quick introduction to Great Charles Street for those who don't know it, get to understand the project, and then we'll sort of step into a bit of how our esteemed panel have gotten involved, and then we'll dip into some questions. It's fine, Mark, you can sit there if you want to. My throne is your throne if you want it. Thank you kindly. So, very quickly, Great Charles Street. I'm just going to pop that down there, not on electrical items. So, Great Charles Street as demonstrated here. The project is this beautiful 3-block set next door to Birmingham Snow Hill Station, a scheme by Moda, set to deliver an iconic new addition to the Birmingham skyline. 3 blocks, 9 cores from blocks A, B1 to B4 and C1 to C4, with heights of up to 39 stories, set to deliver over 700 residential units, as well as commercial and restaurant space across a new communal public realm. Bringing together very different architectural styles with modern unitized curtain wall glazing, which sounds a lot more risky after Clive's talk, as well as light-coloured stone effect panels and multiple different masonry reliefs on a precast concrete facade. The project speaks to the many architectural influences that come from the surrounding city and provide a link from the CBD to the Jewellery Quarter, bringing the beating hearts of the city together. So, I am Ian Gray, and I will be hosting this panel. My involvement in the project was not as part of BB7. Sadly, BB7 were not involved in the project, but I was involved in the job at REBA Stage 3 during my time at Meinhardt, who continue on the project to this day on the client side, supporting the team and reviewing all the facade packages. As a part of that, therefore, I would like to hand over to the 4 people who know the project now far better than I do, and I'd like to give you all an opportunity to introduce yourself while I grab my coffee again. If I start with you, Marc, could you just give a brief introduction of who you are, where you work, and what your involvement is on the scheme?
Excellent, thanks a lot, Ian. Marc Blackie, Engineering Director at Thorpe Precast. We were responsible for the precast blocks C1 to C4 and B3 around the corner. And we clad those in brick face precast, and really there were 3 challenges for us to overcome. One was convincing planning to go for that solution, coordination with the main contractor, and disproportionate collapse. Hopefully we'll be able to cover some of those. But all of those, I think, have a happy ending.
Yes, excellent. Yeah, Bart.
We're doing Block A and Block B, the unitized facade and also the steel coating walling at the ground floor.
Fantastic, thank you. Andy.
Hi, I'm Andy Richards. I'm the project architect on Great Charles Street. I work for Whedon Architects, who are acting as executive architects for CISC.
Hi, I'm Ange Francis. I'm head of facades. We're now building envelopes, and our involvement is from everything from the very beginning of it all the way through to the site visits, etc. So we're kind of acting as the governance on the technical side of things.
Lovely, thank you very much. Just before I dive into sort of all the questions, we've had a lot of back and forth prior to this. I just wanted to say that we're at the tail end of this, we're going to do just a very, very quick Q&A session. So can I invite all of you, whilst you're listening to this, if you can think of any questions that you want to ask the team, you're not going to get a more sort of experienced panel to understand the project. If you can think of anything that you want to ask them, we'll just have a quick 5 minutes at the end for you to just literally shout any questions you'd like an answer to. So, without further ado, so the first sort of question, and it's quite a fun and easy one to start with. We've looked at this scheme. There's a lot of different sort of elements to it, but what would you say your biggest challenge on the project to date was? Now, I'll probably start with yourself, Bart, because when we had our discussions earlier in the week, I really enjoyed your answer to this question, actually. So, Bart, if you wouldn't mind starting us off.
Yeah, when we had that chat, my first question, maybe joking, was that we didn't have any big challenges, or no. And the more I think about it, the more convinced I am that we didn't really face big challenges. And I think this is because our early involvement with the main contractor, with CISC, with the consultants, architects. Also, we did the immersion down the road.
Down on Broad Street.
Which is probably not, from the architect's point of view, maybe it's a different project, but for us, we used the basis of the design from the merchant. We translated to this building. Yeah. So the system is very, very similar. So that with all the coordination we had prior to start on site, that helped us to find very few challenges. Yeah. Technically, something that we probably didn't hear here today was finding the right labor. Yeah. We're still on site. We've got about 70 fixes.
I think that was a photo that was taken at the weekend. So
So to find, I think we've got 50 on Block A and 20 on Block B. Yeah. And to find the right people, with the skills and the quality, I think it's difficult. We are also working in 3 Chamberlain Square. Yeah. And we've got subcontract teams there as well. So at the end of the day, all of us in Birmingham, we've got more than 110 fixers working for us. Yeah. So that's very difficult to find the right labor. Yeah.
Yeah. Yeah. Oh, fantastic. But great that you found that was not as many challenges as you would have thought?
We had some, we had some very technical, like there was some issues about ventilation at the bulkhead, where we ended up ventilating the cavity to the inside of the building between the suspended ceiling and the slab, rather than ventilating to the outside, because aesthetically and also we could put a little bit in jeopardy the performance of the facade. So we had discussions about it, also some discussions about cavity barriers within the external aluminium features.
Yeah, I think that's something that's worth us getting onto a bit later. But there are definitely some technical challenges that we were talking about that were very interesting. Before we go into that, though, I'd like to pass over to you, Andy. Like, what did you find your challenges were? I also know that you spoke to Gareth from Ryder, Gareth Callan.
I could say it's obviously the technicalities of managing three very distinct buildings all concurrently on site. It's probably from a CISC's point of view, delivering those three buildings is quite a challenge in terms of the sheer volume of information. But I think we've got a good technical assistance from these guys. Yeah. But also a very collaborative relationship with Ryder Architects, who are the concept guys. So we've always been happy to sort of pick up the phone to Gareth, the guy who actually did most of the facade work for Riders. Yeah. And like rather than presenting like a fait accompli, we've had to make technical changes. They're very open to a discussion to basically work through the problems and get an agreement.
So again, it feels like the challenges weren't strenuous to overcome just because of the collaborative nature of the team, the project.
Yeah, very much. It wasn't us and them. It's actually like a team effort.
You didn't have riders just go, there you go, have fun.
Yeah, exactly.
Yeah, fair. What about you, Mark? What did you find from a thought precast perspective?
Well, normally a challenge for us, especially bringing precast into, say, a place like Birmingham, for example, is convincing planning. That, people ask, well, is it going to look as good as handset traditional? It's a very sensitive area. And we're very encouraged by the response from Mr. Fuller when he came to who's head of planning out here in Birmingham, who came to our factory, and then brought his whole team to look at the panels in our factory and look at the samples, and hopefully he's as pleased with what's on site now and as he was when he looked in our factory. The other piece, though, for this, one of the ways of making it look like handset is to stack those panels one on top of the other. So this is all low-rise, under 8 stories. And the real challenge there is disproportionate collapse. So whilst it doesn't really fall under approved document A because it's not holding up the building, it's not contributing to stability. Most specifications that many of you in this room write call for what I like to call vaporization of a panel or notional removal. And it means that you've got these great big panels that are stacked one on top of the other, and it needs to be designed to remove one of those panels and prevent them all from coming down. You have to design basically your lateral restraints to turn into hangers. I was just on site this morning. Truly, really nice, tidy site, but seeing in the flesh the size of those brackets, now we did overcome that challenge, and we did manage to design them in. But on other jobs, we are getting around that by basically demonstrating that it's near on impossible to remove those panels in the first place. So that was a challenge we overcame, and perhaps later when we talk about what we would do differently, I'll dwell on that a bit more.
Yeah.
But what I must say, the final kind of challenge that was overcome, that would be near on impossible if it wasn't for the coordination with the main contractor, which I'd say is a challenge on most jobs, making sure that we don't have loads of remedials when we're casting and fixings in the superstructure. And I think the communication between Thorpe and Sisk and Gallagher's and the a handful of remedials on a job that size is a testament to that. Yeah, absolutely. I think at the risk of giving the game away, I think there is going to be a very large message of just how excellent collaboration was on this project, and I'm hoping that the audience will see that shine through as we continue. But Ange, what was your view on your
biggest challenge?
Your biggest challenge, okay. Of the multitude that would be on
No,
Sisk's
to be honest with you, so the biggest challenge we had for this project was the tender. The tender came at the lovely time of when we had COVID and we had Brexit. So it gave us a huge amount of positives because we had that length in time where being able to actually look at the tenders and really dig down into making sure that the subcontractors we were appointing, the products we were using, and all of that was great. It was a lot more time than you would normally get.
Yeah.
But then we had the other challenge of it with the view of this trying to keep these guys into, from a financial perspective, is your cost certainty. So you've constantly got this whole thing as time moves on, the cost of materials. We know at that time, particularly the aluminium side of things, the cost of the aluminium was just going up and up and up. So trying to keep the, trying to get that you would secure your prices in a week's time, never mind 3 months' time, etc. So there was that whole side of things and trying to manage that as it all went along, bearing in mind that we were actually still starting the project on site. So
no.
And that was still during the COVID period as well.
Yeah,
so.
Definitely. No, I recall there was a lot of downtime and speaking to RPS now Tetra Tech, they were like CISC have cracked on very much at risk. But one of the things that again I think we've all talked about is how that was very much a boon on this project. So I mean, in terms of that, I know that we spoke about whether or not that felt like that was a benefit on this project. Is that something that you feel would be beneficial on other projects?
I think, well, if you extend the programme on any project, I think everybody, no matter where you are all going to go, yeah, that's it. But the cost side of it becomes more difficult.
Yeah.
I think for us, we tend to follow the same process anyway.
Yes.
Just having that additional time to actually do it. And one of the things that we did have was, for example, the commercial guys who like to, save every single penny as it goes along. We had a very rogue price that came through.
Right.
So when that rogue price that came through, if we didn't have the time that we did have, I'd like to think that we would have still done the same as what we've done now anyway. But the reality of it is you were able to then actually go and say, look, this rogue price is a rogue price.
Yeah.
And these are the reasons, and able to actually go through the specification in a lot more detail, saying, right, wait a minute, have you done this, have you done that? And we actually found that by the time we had actually done all of that, which took more time, but we afforded us to do so, the actual cost difference between where we were originally and to where we ended up being was just a few $100,000. So compared to that, so that side of things is there, but I think we're all in the same game. We all kind of know how much something costs.
Yeah.
But it's as soon as you tell anybody you're going to get something for cheaper, your money men are definitely going to go, oh well, yeah, let's look at the cheaper options. So that's the main thing. Yeah.
Yeah, definitely, definitely. Sort of to everyone else in the panel as well. Actually, I mean, like I'll offer it up to whoever wants to answer this first. But like, how did you feel about that downtime? Did it affect you? Did it not affect you? Would you like that to be more commonplace? Do you think the programs are too constrained now, or would you like to see that stretch?
I mean, I certainly felt it was beneficial on this project because, for instance, Block B, it's got the stone effect aluminium cladding. That was all agreed with Birmingham City Planning before. Obviously, we started on site.
Yes.
So originally it was going to be a full GRC cladding system. We obviously convinced the planners that it's going to be better for many reasons to go with the interpon effect aluminium cladding. But then obviously when we showed them, this was one of the planning conditions we had to clear. And when we showed the VMU, the planners were a bit more dubious about it. So it took a lot of debate back and forth to actually get agreements. On the basis it was like we're tying in with the commercial facades of the city.
Yeah.
But also it ties in with the Portland stone of Great Charles Street.
Yeah.
But it gave us that breathing space to actually get it all fully approved, the condition approved before we started.
Yeah.
Which was a bit of a tense moment.
Yeah, I can imagine, because I know that certainly, having worked in Birmingham for a few years, that the planners can be very strict on the material is the material and it must look like the material. Yeah. So that sounds like that was a real benefit.
Absolutely.
Yeah, definitely. Well, you look like you were about to.
There's a benefit, but it's also there must be a balance because it's good CISC facade department had the chance to look at thoroughly in detail the whole tender.
Yeah.
That's very important for us because we price it properly. If they didn't have the time, maybe we wouldn't be doing the project because someone would be looking at only price.
Yeah.
So it's very important that it's a huge project for the facade, well, in the whole. But if you don't spend the right time looking at the tenders, you might end up making a mistake.
Yeah.
And on the other hand, waiting so long to get awarded with the project and asking your supply chain to hold the prices or to update them in a reasonable way is difficult to handle all that process. Yeah.
Because you've got a lot of pressures, which I'm sure you do as well, Mark, in terms of like making sure that you have the space in the factory to start fabricating, to make sure that you're that you're in a position where you can hold that price, especially considering this, as you say, was COVID time. We can all remember just how much material prices were changing in that period. So,
and it's programming the factory as well, and the teams. You can't be waiting a year for a project. You end up doing it, but
but you then are squeezing it in.
It's not the best case scenario. So it's what I said. It's good to have a balance, and I think it worked out well for us in this case. But in some others, you could end up losing it. Yeah.
Depends on the project, I guess.
Yeah.
What about you, Mark? How did you find it? I mean,
I'd echo what Bart said. I think generally speaking, it's important to stick to factory slots because it's like driving a tanker. You've got, to have that availability. I think also, like Bart, it worked out fine in the end. We do have the benefit of often being on early, precisely because we need long lead-in times to manufacture panels because they go up far faster than we can make them. So we tend to manufacture a large amount, store them, and then by the time we start installing, they go up much quicker than they're made. And that amount of time also lets you fine-tune the design and find efficiencies, which we're seeing more and more that early engagement necessary with Gateway 2s and things like that. But yeah, early is good. It allows you to fine-tune the design and get the most value out of it.
Yeah, but you don't want it to be too long that you've got a factory full of panels that you can't shift, basically.
Especially if the goalposts change. But, again, it's life. Things move, and we do what we can to accommodate it,
Yeah. No, fair. Yeah. So taking a bit of a different tack then, and I'll stick with you, Mark, if that's all right.
Fire away.
We had the downtime. We had all of that. We started getting cracking, and you were looking at interfacing with the mainframe, and the mainframe was all in situ or PT.
Yeah.
Now, particularly with PT, speaking as sort of facade consultant and designers, and we see a lot of challenges, particularly with PT in terms of coordination. How did you find that with this project? And would you say that it was difficult, therefore, to sort of get engaged? Would a steel frame have been better? Or
Yeah, I mean, it can be really difficult. And I think it's like, it's the motive, it's the life of an engineer that when everything goes well, it's when no one says anything.
Yeah, perfect.
unlike say, an architecture designer, where, if it looks good, then it gets noticed. So when it goes really bad, it goes really bad. And I won't name names of projects, but if you have a frame being thrown up, with cast-in fixings, which is typically how you, for most facades in an in-situ frame, with cast-in fixings, if they're out of place, you need to devise remedial solutions to that, post-drill on site, resin fix anchors, justify them. It takes time, it's costly, and it's just not as good. And it doesn't really matter where that cost gets covered. It's not good for anybody. Especially if you've got PT, you don't really want to be drilling into a PT slab if you can avoid it. It takes that extra level of coordination and so on. But what we did on Great Charles Street, which it should be really status quo, and I would encourage anybody on a job to ask for this to happen, is very early on, highlight what the builder's work is, In our case, what we did is we wrote a letter. All the information is always out there, but it's about poking people in the eye with it, signposting it really clearly. So in our case, there was a letter to CISC highlighting the tolerances, the specific cast-ins, the supplementary reinforcement around it. I can't tell you how disconcerting it is when people can't tell me if the rebar was actually cast around the cast-in. But CISC were very responsive to that. Gallagher were very responsive to that, and getting in there early. So if you're a facade consultant doing site visits, for example, some of those early checks even before the facade comes on, it's quite helpful to go and look at a cast-in and say, well, the rebar that we're expecting around it, is it there?
Yeah.
That kind of thing. And setting that benchmark early, I mean, the result was, in the end, like I said, we hardly drilled anything afterwards, which was a really great result.
That's the ideal, right? Is everything that's cast in works and is there.
Yeah.
Yeah.
And I'd add to that, especially where you have these fixings not only horizontally restrain it, but in the event of notional removal also have to, I mean, the forces are huge on these potentially, so it's just as well that they're in the right place.
Yeah.
Cast in first.
Just in case something gets vaporized. But.
Exactly.
But I assume that you had a very sort of similar experience.
Yeah, I can't say much more than that. I totally agree with you. It's very important to show what are the key elements. In this case, the casting channels for us the same. Yeah. They were, I guess, most of them or 100% of them in position. Yeah. So no rework. That's very important. I saw your drawings marking up a drawing might contain a lot of information.
Oh, so much. Yeah.
And sometimes you have to be able to show, in this case, the main contractor where to look at, the important bits, and they did it. We did something similar. No issues.
Yeah. Brilliant. And you seem to have seen the benefit of that signposting effort of these guys sort of coming in and highlighting it.
Yeah. I mean, from a CISC perspective, concrete frames is what we do.
Yes.
Rather than steel frames. We wouldn't say we wouldn't do steel frames, but it's not our bread and butter. We do have a very good in-house engineering services. So as part of the team that we do the facades, we've got the temporary works, we've got the engineers, and it's the communication between everybody, and it's the site communication, making sure these guys don't necessarily have time to do the checks and the balances before they get to site, so we do that, the information. So the communication of the whole thing has to be there, and it has to be the team effort.
Yeah.
And if you start dropping that, then that's where it falls down.
Yeah.
And I think as well is that it's this whole thing about when the information comes through to the teams, whether that's our team or the other ones, is sometimes you're putting the comments on there.
Yeah.
And it's great when that people are actually responding to the comments, because you'd be surprised how many jobs we do. You comment on a whole load of technical information and you don't necessarily get anything, but without fail, definitely from an ASA's perspective, we used to have didn't we, the lists of all the comments, and Kyle, my colleague, somewhere in the audience, I can't see because of the lights, but Kyle would sit with an ASIS and go through on a line-by-line basis, and it's that level of detail you really need to go to when you're building these kind of things.
Definitely.
Or you do get problems.
Yeah, definitely.
Yeah.
And it sounds like it's worked then. You're literally sitting with an ASIS, and I'm sure Thorpe as well, and Andy, actually, to be fair. I'm sure
we've had weekly workshops for the last 2 years.
Yeah.
It's kind of we've ironed out the problems early doors, hopefully.
Yeah. And have you found that very particularly valuable on your side in terms of being able to engage directly with the teams and say, right, okay, where's my problem here? Yeah. No, that's good. Again, it feels like a real testament to collaboration that, as you said, Mark, there's no problems. Everyone's fine with it.
I think it's transparency.
Yeah.
It's easy to kind of think, we've got a problem and hide it.
Yeah.
But we all know is as soon as you encounter something, it's actually better to just bring it out in the open and deal with it, because the reality of it is 9 times out of 10 it's a lot more solvable than you think it is.
Yeah.
And it doesn't cost as much money.
Yeah.
Definitely we don't want to be pre-drilling pre-tension slabs. No.
But also we talked about the engagement not only with fine people on this stage, but also building control. We were saying how there was a lot of engagement with building control in order to make sure that they were on board with some of the complex details. And Bart, you mentioned the fire stopping, but
for instance, with the Bart was saying with the ventilating the facade, we had to come up with a detail to ventilate it into the apartment.
Which is very unusual, but I've not really seen that on many schemes before.
The original design was basically bypassing the fire stopping. So we had a lot of back and forth to try and come up with a system that a civil guy were happy with, a fire engineer was happy with, and that basically worked.
And that engagement would be key in terms of getting that through. And also understanding what you can do, Bart, in terms of your sort of capabilities in the team, and saying, is there any other way we can do this? Can we bypass in another route?
Yep.
So, yeah, really good. Again, I think it really is a project that speaks to the positive message of what early engagement and collaboration can do. Sort of, again, a slight tack in a different direction, and I'll start with you, Andy, on this one. But there is obviously a lot of different facade types on here, and a lot of very different sort of architectural expressions on this site. How has that been from an interfacing perspective? I mean, you've also got very different systems in precast versus unitized versus. How did you find that?
I mean, again, not wishing to knock steel frame, because we work around steel frame a lot as well. But in this particular project, having nice planes of concrete to seal against, to fire stop against, has certainly made this project a lot easier in that respect, I think.
Yeah, just giving you something that you can actually robustly seal against, rather than having to come up with some imaginative detail. Yeah. What about you, Bart? How did you find it from an interface? I mean, particularly I'm thinking between blocks B3 and B2, which is your precast on one side and your unitized. Is it literally just an easy abutment? Were there any complications, any challenges there? Or?
As you say, probably block A doesn't really have big interfaces because it's all the way up for us. And in block B and C, there's typical interfaces, membranes that requires a lot of coordination, but I can't recall right now.
No, fair enough. But again, speaks to the positive that you have nothing bad to say about it.
Well, maybe there are some other things.
Fair enough. Anything that springs to mind?
No, not really. But I'm saying we're here all, talking about the positive stuff that we've gone through. Maybe there are some other things, but minor as any other project.
No, fair enough. What about you, Mark?
Well, we were pretty lucky that we had minimal interfaces with the other facade types. So all of blocks C1 to C4 were all brick face precast. So they interface with each other. It's still precast with a different brick pattern on the front, so that was relatively straightforward. It was just the same as, it was designed to look as 4 different blocks, and I believe it does. But as far as the weathering joint between those 4 distinct blocks was concerned, it's still a double mastic seal, so it's pretty consistent. Around the corner when you get to B4, which is brick face precast interfacing with the GRC system.
Yes, B3, I think.
Had a look this morning when I went, because I knew you were going to ask that question. And it looked pretty straightforward. The flashing was in place. It wasn't overly complicated. So I do think we have a series of systems, at least from our perspective, where now I think that we also benefited from coming in first. So if you ask the GRC installers, it might be a slightly different question, but it's still relatively straightforward joint between the two.
That's good. That's good.
Again, what's what you want?
Yeah, exactly. What about you, Ange? Did you find anything particularly sort of challenging from an interfacing perspective? And
I think it's just we see the volume of that's coming through from everybody, so they're only seeing the drawings perhaps from whoever they're interfacing with. So we're looking at all. I think simplicity becomes, and that was down to the architects as much as anything. We find, and I don't know if everybody's got the same thing, but we find when we have the buildings that go really well and the facades that go really well is when you actually really think about the things that are important to give you the performance, your weather tightness and your air tightness, and you can achieve that really well without making it massively complicated. And then if you've got your details that are simplistic, easy to follow, then the level of the quality of the workmanship is going to be much better as well. The interaction that, again, Kyle, wherever you are, sorry, is
Clearly
been
needs to stick his hand up. At
yeah,
this
I
point
know, I
if he's
can't
here.
even see him anywhere. He's over there.
Ah,
he's
there we
over
are.
there. So, Kyle is the guy who's on site interfacing with these guys on a regular basis,
Yeah.
making sure that not only what's actually on the drawing, but how that's executed on site is actually what's happening.
Yeah.
And I think the only thing we don't have here is the guys that did the windows. So
Yeah.
the windows that went into the precast was there, and the only challenge we had with them was they're a very slim system. It's a Connier system, they're very slim, and getting the testing that we needed to get because of the high wind loads, etc., etc. So
Yeah.
that was probably the biggest challenge we had on that. But in regards to the interface details, we would always say,
keep it simple,
keep
stupid.
it simple.
Yeah.
Yeah, don't complicate it, because that's when you're in, the guys that are actually on the coal face doing the installation will take a lot more time to do the details if they're simple.
Yeah.
If there's a whole load of stuff they've got to do before they put the EPDMs on, they don't do it.
No.
And they stick the EPDMs on, particularly on a Friday afternoon. It's like they're coming up to lunchtime. It's like I've got to travel home, etc. Oh, bugger it, stick the stick the EPDMs on. Nobody will know.
Yeah.
And it happens. It's life.
Yeah, no, absolutely. Whereas if it's it's much more
If
simple
it's a bit more
detail,
simple,
then-
they'll take the time. They'll take the extra 10 minutes or 15 minutes, and that doesn't matter whether it's Analysis or whether it was Thorpe's or Bennett's who did the windows.
Yeah.
Then you will find it.
And I guess that's true as much of on-site as it would be if it was the windows installed in the factory at Thorpe. It would be exactly the same principle of keeping it simple, making sure that the guys have the ability to just put it in, lap it straight away, and then walk away happy.
We like to call it agricultural details. Simple, robust.
Yeah. Fair, like it. So I'm going to do one sort of final question, then we'll sort of move to closing remarks and then the questions, because I'm conscious of time. But it's one that I think is sort of present in the fact that we're looking at a 39-storey building, and the fact that this was right at sort of the start of COVID was when we were coming up towards planning submission and all of that. Things have changed a lot since then. So there's been lots of reforms to the Building Safety Act, Part L has changed, sprinkler rules have changed, 2 staircases, etc., etc., etc. Basically, my question really is sort of twofold. Is one, were there any sort of challenges that came out of those regulatory changes in the final form of the building now? But also, I suppose, would it have been done differently if we were to do this again now? And Ange, if I can start with you, possibly.
In regards to all of the facades, no, everything that we have done would pass regulations as it is now.
Yeah.
So would we do anything differently? No.
No.
Because the way that we look at, particularly in regards to fire, the checks and balances we do is something that we've always done, even pre-Grenfell, etc.
Yeah.
So the only thing that's different for us is perhaps looking at how the combustible materials, if you like. So definitely we've reduced that levels down. But the checks and balances and how we've done it, and this, we wouldn't have changed anything.
No.
The sprinklers wouldn't have changed because it's the same.
Yeah.
Might be controversial in regards to the 2 staircases.
I won't
that's
dive
the
into
architects.
too much detail, but
So, no.
Yeah, I think right from the start, again, it's going back to the what might be meeting building regs, but insurance-wise, yeah, so the decision was taken early doors to have no combustible material in the facades. And even though like block C's less than 18 metres, that's still fully sprinkled, still has the same facade standards as the other 2 high-rise blocks.
Yeah. So it was a very robust design, met all of the sort of the Part B amendments anyway. So
I think it ties back
concerns.
into even what Clive was saying earlier, though, is that when you've got buildings that are low levels, is realistically, you're often just as cheap to use your non-combustible materials as you are to go the other route. And the reality of it is, if you're doing something like this, where you've got many different heights of the buildings, doing everything in exactly the same way, it makes it harder for somebody to make a mistake then.
Yeah.
Because the reality of it is they're all the same. I would totally agree in regards to the insurance. We're driven by the insurers a lot as well.
Yeah, no, that makes total sense. You've got to plan for the entire life of this building, and like 50 years plus, particularly with precast. Actually, Mark. speaking precast.
Yeah.
Yeah. What I suppose from your perspective, were you affected by any regulatory changes, and also would you do anything different were you to do this again?
Yeah, I think if we were to do this again today with the new current regulatory landscape, I think we would end up, as Ange says, in the same solution. I mean, it's precast, it's non-combustible. You've got arguably the best condition for your fire stopping, concrete to concrete facade, concrete slab. What I would do differently, though, is I would, if I could rewind the clock and be early enough to have a discussion with the specifiers and so on. And again, I do think our understanding has moved on since many years ago when we were talking about this from a disproportionate collapse perspective. I think the received wisdom was notional removal, so I don't hold it against anyone for doing that. But moving forward, and for those of you who are interested, EC0, EC1 Part 7 give a really good framework for defining the accidental loads. You don't have to design for notional removal, especially with the inherent robustness of this. If you go down, say, EC1 Part 7, or EC1-1 Part 7, which gives you accidental loads, and look at it's table 4.2 for anybody taking notes, you'll find that in an urban environment, the impact load is 250 kilonewtons, 25 tons. If you put bollards around it, you can get that down to 75 kilonewtons. These are huge panels. Without much extra work, you can sustain those loads and have sufficient residual strength. The CWCT guidance for loading has a provision for residual strength of impacted elements to prevent progressive collapse. So you might find that you can avoid a whole lot of overdesign of brackets by simply demonstrating that the inherent robustness of what you've got there is likely to sustain any accidental loads. Blast often gets quoted as another one. If you've not got gas piped to the building, and we're moving away from that for sustainability reasons, you don't have to design for 34 kilonewtons. That's Ronan point. Kilonewtons per meter squared, by the way. If you do have blast at all, 17 kilonewtons per meter squared tends to be a figure that people accept, and I can give the reference to anybody who's interested, or not at all, right? So you can get to a position where you can really get the true benefit of stacked facades and still be safe from a disproportionate and robustness perspective.
Yeah.
And I'd encourage anybody moving forward to consider that.
Fantastic. Brilliant. I will probably pick your brains on those standards later, and also whether or not they're the new EC standards or the old ones.
All new,
they're
all
changing.
current.
Right.
Yeah.
Excellent. Anyway, we will digress. But same question to you. So in terms of all the regulatory changes, did it affect anything that you were doing? And then also, is there anything that you would change were you to be building this?
I don't think the change in regulations affected or had affected the facade.
Yeah.
I mean, we would have done everything the same, but probably a few changes, but from our own internal perspective. Maybe level 18 is a particular level where the facade sets back.
Yes, I think you can just see it here.
And maybe there's a better way to do it, and there's a way to maybe design it in a different way and install it quicker. But that's nothing to do with the change in regulations. It's more down to the experience. Once you design it once,
you tried it, and you go,
you probably find always a place to improve it.
Yeah.
Things like that, or maybe some drainage channels within the system, but not related to
minor
the
tweaks
regulations.
just for speed rather than anything else. So which I think you mentioned that you had some fun with level 18 as well, which was
the glass replacement was quite a challenge on the level 18.
So that might be something that would be potentially in the future something were you to do it again, it would be looked at. But lovely. Well, I'm conscious of time. We've pretty much landed on pretty much exactly the time for the panel discussion. So thank you very much for your insights. I'm sorry we don't have more time because I think we could actually talk about this for a lot longer. I had a lot more questions. But I want to throw it out to everyone out there. If there is anyone that has a question, please raise your hand or shout up, or if anyone has anything.
Good. No.
Oh, okay. David. Oh, no, David.
Not particularly. I think the hardest detail was probably where we had the glass So where the glazing went across the floor slab location, so instead of having your double transom detail, it's, you know, the nice architectural detail where the glass comes over. That gave huge challenges in regards to, you've got your fire stopping in those locations, we've got the acoustics in regards to your flanking, etc. And then obviously the thermal stress that we end up on the glass. And then added into that was the whole ventilation problem that we had as well. So there was a massive amount of stuff that was going on in one location. And again, when you've got various different parties with different opinions, it doesn't always play out as well as you'd expect it to do. But in that whole detail, we had Bart's team were involved, Andrew's team, we had the fire consultants, building control, and was it easy to get it through to where it is now? It was a lot of difficult discussions, but it's about that, having the difficult discussions, which I think you really should do. It's rather than just shying away. And
yeah, no, I'm not sure who's going to make that decision, pass the buck.
Well, I think the reality of it as well is it's the design responsibility, because it's very easy for people to insist they want something specifically done. So in regards to the way that we let the packages, the design responsibility for the unitised facade lays to Anasys and Bart's team.
Which could have been a real problem for you, Bart, if you'd been sort of like, there you go, there's your problem, sort it out.
No, but then the reality of it is, again, you go back to the whole thing that Clive was talking about in regards to the insurance side and your PI. As we know, Bart, etc., in regards to fire, with they don't have that responsibility. No. So bringing the fire consultants in, and whilst maybe they over-egg the pudding a little bit, don't you think? The reality of it is their PI is the one that's on the line, so that's how you've got. So there's the elements of it where you've got to give and take a little bit, and then come up with the best solution. Yeah. And I think that's what's happened here.
And how long did that process take to get to
I don't know.
Because I can imagine that's
better for Andrew to ask.
Yeah, 3 or 4 months, I think.
Okay.
Yeah.
Fair
but
enough.
we had the longer time, didn't we? Sorry.
Yeah, no, fair enough. Well, there you go. That's the benefit of having that time, I guess.
Yeah. Would you want to do that again? Probably not.
Yeah. Would you use the detail again? Would you use the detail again, Bart? Would you be like, yeah, that's fine. Now we've got it sorted. That's fine.
Well, I think in particular to fire barriers, cavity barriers, I think I'd probably stick to what we did in this project, because after a few weeks discussions, we were able to put every different party to an agreement. So there was a fire, two fire engineers involved, the contractor, the consultant, us. So I think if we were able to get an agreement from all those parties, I think it's because
that's the most robust, probably detail that you've had in a facade for.
Yeah, but I think in regards to the other areas, it was pretty straightforward. Yeah.
Brilliant. Thank you very much, David. I think that we are now out of time, so thank you very much. If they do any other questions for anyone, collar us in the pub afterwards. But otherwise, thank you very much. Thank you very much to everyone who joined me on the panel, and thank you very much for everyone here.
Do we leave now?
Okay. Thank you, guys. Great talk. So that's it. That's the end. Thank you for everybody to staying to the end. Hello, Claudia. I just want to thank everyone at Zak and all the staff for putting this together and bringing it to Birmingham. It's great to have it on the calendar. After party, it's at Armin's? No. It's at Sack of Potatoes. If somebody wants to have a quick drink there, we can go there. But yeah, thanks again for coming along, and I'll hopefully see you soon. Thank you.